Yes, thank you. Well, welcome everybody. It's super to see you. What a fantastic turnout and what a brilliant venue that the professional services team have managed to get hold of. It's great to have you here for our 20th annual conference. It's a combination between the Institute of Women's Health and the Women's Health Division audit. And I'm very grateful that Stuart and the clinical team have agreed to again allow us to coordinate this and have it as a whole day of audit, which I really think is great because it brings everybody together and it means that we can really have a lot of networking, we can present our excellent research, education and impact. So please do take lots of pictures. We have some content creators. We have Alana and Phoebe. Do you want to stick your hands up or stand up? They're over there. They will be roaming along with their mobile phones, taking video. They might even interview you. Please do talk to them. They're going to be putting out some nice videos, just their experience of the day. So please do chat to them about it. We have posters across the way. We have a poster session. We've got 50 posters. It's a mix of Institute people, UCLH Women's Health audit team, presenting their audits, presenting their research, all of their work. And there's some really interesting posters. I was going through last night. There's some posters about education in disparities in women's health, posters about gene therapy as well. So do go and take part and go and talk to them. So I'm going to kick off this 20th annual meeting and say very welcome to you and bring us back to home in terms of what is our mission. So our mission in the Institute is to bring together everybody at UCL and UCLH, the expertise of clinicians and researchers from a wide range of disciplines to deliver excellence and innovation in research, clinical practice, education and training to make a real and sustainable difference to women's and babies' health locally, nationally and worldwide. And my gosh, I'm very privileged in this position because I get to see everything that you all do and it's fantastic, I can tell you. So who are we? I thought I'd put a little bit of information about our numbers. So as you can see, we had a little bit of a tail off naturally after COVID, but our numbers are creeping up. This is our numbers within the Institute. But of course, the Institute is not just those people who are employed by UCL, it's also our fantastic honorary staff. And you can see the breakdown here. We have 141 honorary staff. That's people who have a contract with the UCL, who also deliver research, education and impact. And many of them, 80 of them, are UCLH honorary staff, and they are really contributing to everything that we do. So thank you so much for taking part. We also have Institute visitors. These are people who are perhaps finishing off projects, master's student projects, etc. And we have some new Institute staff, a long list here. I'm not going to go through everybody, but particularly to welcome Christina Claxon-Bonington, who's our artist in residence for our UCL 200 Bicentennial celebrations next year in 2026, when UCL will be 200 years old. We cover the life course in the Institute. So we cover promoting healthy development as well as restoring health. And I think this is really important. It's not just about when you become ill, it's about preventing ill health and keeping well. And that very much plays into the vision for the Women's Health Strategy for England, which was published and commissioned by the Department of Health and Social Care. 100,000 people responded to this invitation. You may have noticed there is a men's health strategy now published, very important as well. Please do read that, focusing much of it on suicide and mental health in men. So because of that, we have been able to leverage some funding out of the UCLH Biomedical Research Centre. This is a research centre funded by the National Institute for Health and Research. And we've been funded £500,000 over 4 years to deliver on the DHSC Women's Health Strategy. And that's focusing on menstrual health, fertility, menopause, healthy ageing. And we've had some work done by Duncan Cartner, who's a data engineer, who's been helping us really interpret our EPIC electronic patient records. We've got some great work being done on endometriosis, reproductive endocrinology, preterm birth and menopause, and some collaborations developing with groups, for example, like Mereda, Mother and Infant Research, electronic data analysis. I mentioned the UCL's Bicentennial, so we are 200 years old next year. And if you want to see a light show at UCL, please do sign up to tickets. So the light show is going to be open in the quad between 11th and the 13th of February. It looks amazing. Go and have a look at and sign on via the Eventbrite. As you know, they're remodeling the main quad, the Bicentennial Physical Legacy Works. And it's going to be a really amazing show. They basically shine lights all over the columns at UCL. And we have a committee that's been working on how we're going to celebrate 200 years. We have, as I said, an artist in residence, Christina Claxon-Bonington. It's a collaboration with the Institute of Education, the Bartlett School of Architecture, focusing on women's spaces. What are the spaces that women occupy? What are hospitals like? What is it like at home? How can we improve women's spaces? How can we make sure that when we build a building, we have spaces for women and men to go and change nappies, to look after their children, and for women to breastfeed when they come back from maternity leave? So we've done a lot at UCL in terms of women's health, and little snapshot, we are writing a history of women's health at UCL, which goes right back to the beginning of UCL. 1 year after it was founded, Professor David Davis was the foundation professor of midwifery at UCL, and he wrote a book called Elements of Operative Midwifery, and it's still available on Amazon, which is fantastic. I went and I had a look and I thought, gosh, it really is there. And you can go and read what he was talking about in 1827. He designed forceps instruments to safely deliver babies. And he also delivered the mother of Queen Victoria. So he basically delivered Queen Victoria, which was a pretty scary thing to do in those days because the previous Prince of Wales had died in birth, his mother that had died in birth, and then the obstetrician had actually killed himself because of it. It was a triple tragedy, and go and read about it. It's really interesting. But he was very brave enough to deliver Queen Victoria, and thank goodness for that. There's a portrait of her actually in the poster room if you want to go and see. Then, of course, we have Elizabeth Garrett Anderson, who was the first woman to qualify as a doctor in the UK. She opened the London School of Medicine for Women, becoming the Royal Free School of Medicine and merging into UCL Medical School. And then those of you who used to work at the old EGA hospital will remember you used to walk up the stairs in the old hospital, and there on the wall was a plaque. In 1932, in this hospital, Chassamoyer first studied the effects of ergot preparations on the human uterus. So John Chassamoyer discovered the effects of ergotamine, the first drug to treat postpartum hemorrhage and preventing maternal ill health death globally, and it's still used today. So we are 200 years next year. Please do read our publication when it comes out, and thank you to everybody who's working on it. So moving on, a few little snapshots of what we've achieved over the last year. So fantastic congratulations to all of those who've been promoted. Alexandra Gentry Maharaj, Professorial Research Fellow Women's Cancer. Sarah Hillman, Maternal Fetal Medicine Professor of Obstetrics and Genomic Medicine. And Rajvinder Kada, Professor of Gene Therapy in Maternal and Fetal Medicine. So well done to them. We've also had some inaugural lectures. So Adam Rosenthal spoke about gynae cancer and prevention, an unwelcome inheritance, tales from cancer prevention. Bola Grace, who's a professor of practice, spoke about women's health in 4D, cross-pollinating ideas across industry and academia. And Professor Pan Pandya talked about was he a suitable boy to be a professor of fetal medicine? Well, certainly he was. Coming up, we have an inaugural lecture from Professor Subrata Mitra, who is going to be talking about invisible light, use of near-infrared spectroscopy in neonatology and maternal fetal medicine. So just a quick summary of things that are happening in the departments. So our neonatology department, the first baby has been recruited, I hear, to the Acumen Phase 1 first-in-human trial of melatonin to treat hypoxic ischemic encephalopathy, funded by the MRC. So congratulations to the team led by Nikki Robertson, Raymond Pang, and to all of the research team that are involved in that. We have the team from Professor Howard Clark and Jens Madsen, who completed the first in human clinical trial of a novel surfactant to treat chronic lung disease in neonates. So congratulations to them as well. Furthermore, perinatal brain repair, led by Maria Hristova, is looking at curcumin as a way to treat neonatal HIE and to prevent the damage that might come from this hypoxia in labour. And as I said, Suba is going through optical imaging, optimizing the care of babies that have low oxygen at birth using this near-infrared spectroscopy device that tells you a lot of information about how the brain is functioning. In maternal fetal medicine, Dimitrios Issakos completed the ROTATE multi-center randomized controlled trial. That was looking at manual versus instrumental rotation of the fetal head when the baby's looking sideways or upwards. And he's developing a nanosensor glove, which should be able to tell you a bit more information about which way round the baby's head is just by feeling it, rather than sort of doing it subjectively. It would actually give you some information about where the skull sutures are, and that would tell you actually which way round is the baby's head. And then also working on perinatal mental health, Chiara Petrosalini is finishing off her PhD looking at the connection between sleep disorders and perinatal psychosis. Again, Suba has been working with the maternal fetal medicine team and a big group of research midwives and engineers, basically looking at, can we image the placenta using NIRS? Can we shine light into the placenta and get information about not only its oxygen level, but how it's functioning? And they are currently recruiting on the labour ward. Thank you to everybody who is helping with that. And we're getting some really interesting data showing that we might be able to assess placental function, fetal function much better than the current method, which is using CTG, fetal heart rate monitoring, that really only tells us about 50% of the time that it's correct. We're also working on using placental MRI. So Ros Orgwain, as well with Andrew Melbourne in medical physics, is using MRI to have a look at placental oxygen and also placental function in babies, in women that have early onset fetal growth restriction, preeclampsia, etc. Owen Vaughan and his team are looking at how we might be able to improve fetal cardiac dysfunction in women who have obesity using targeted apelin, and also investigating the role of GLP-1 RA, so Wegovy, for example, Mounjaro, what impact that might have on the placenta and on the fetus. And then the team that we have looking at preterm birth, we've been funded by Tommy's Centre. We are one of the Tommy's Centre, National Centre for Preterm Birth Research, that we've done a policy lab on preterm birth, developing individualised risk prediction, and we have a midwife working on conversation analysis to improve parental counselling, developing a new training method to improve people's knowledge on how to scan the cervix, and also studying genetic prediction of preterm birth. And then with Kim, my postdoc, we've been looking at completing a study, developing a treatment for fetal growth restriction, and writing the clinical trial application for that first-in-human study. And then also looking at how we can improve safety monitoring in women who undertake clinical trials in pregnancy. How can we improve the safety of the mother and the fetus in terms of adverse event reporting? Fetal surgery, we continue to drive forward NHS England's specialist commissioning fetal surgery service for open spina bifida. We've now done 70 patients over 7 years with excellent outcomes. And we've recently moved on to doing the procedure fetoscopically. So rather than doing a big cut on the uterus, we actually go through a very small hole in the womb to actually treat the baby. And we've done 5 cases at UCLH. And then Raj Kada's team are developing novel preclinical gene therapy and RNA editing to treat childhood neurological and neurometabolic disorders, and have funding from LifeArc and the MRC to do this. And Pascal's team, we've completed the first clinical trial of in utero stem cell transplantation for brittle bone disease, and she's working on EVs, so exosomes secreted by stem cells, which might be able to improve collagen production and mineral deposition in faulty bones. Sarah Hillman's group, Genomic Technologies, are mapping the maternal fetal interface using single cell spatial transcriptomics. So can we actually look at the expression of genes in a single cell and map where those cells are in the fetal maternal interface, and really finding out some very interesting evidence about preeclampsia and the origin of placental insufficiency. And finally, Julia Zollner's work is looking at how we can predict gestational syndromes and can we improve the care for women after they have their baby, after diabetes, for example. Can we prevent women who get gestational diabetes from developing diabetes fully later on in life? In reproductive health, the NIHR Policy Research Unit, led by Jenny Hall and Judith Stevenson, have been doing a huge amount of work. This was an investment of 3 million, launched in 2024 and recently extended to 2028. And current live projects, lots of scoping reviews, looking at future reproductive health data, looking at why women are perhaps turning away from hormone contraception. And teams working on preconception care. We are part of the NIHR Challenge Maternity Disparities Consortium, which was announced earlier this year, £50 million investment to try to improve care and try to reduce the disparities that we know exist in care across the UK, focusing mainly on preconception and inter-pregnancy health. Fertility Education Initiative has been looking at trying to improve women's knowledge and attitudes to the menopause, for example, and research and action to disseminate and say we need to be more aware of our fertility, not just women, but also men. The team have been working with Hadra Katak on ovarian tissue preservation. I know that the reproductive medicine unit are very much part of that. And also rolling out across the UK, be prepared for menopause, find out more about what may happen and find out more about the symptoms that you might be having. Brain fog, it might be menopausal. And then we have a group doing pre-implantation genetics, a new group of multidisciplinary collaborators expanding from the lab to artificial reproductive technology clinics. And then Eric Jonio leading the group on early placentation disorders, studying the impact of climate change and environmental pollution on the placenta, its function, and developing some really novel ways to assess that, looking at the placenta in more detail. And then finally, women's cancer, the group led by Martin Witschrender have developed a methylation-based test. It's a test that you take with a swab from the cervix, the vagina, and it tells you information about the endometrium, and it is looking probably better than just doing an endometrial thickness on an ultrasound. And this NHS pilot is funded by NIHR, and UCLH is one of the key centres. Adam Rosenthal has been leading a team to adopt this ROCA-based screening for women at high risk of ovarian cancer. So women who perhaps carry the BRCA genes are going to be offered this test, which will reduce their risk of developing cancer if they're deemed to be high risk. And lots of multiple collaborations with international institutions, AIMS and Korea, AIMS in New Delhi, Korea University as well. And then the We Care Centre, led by Philippe and the team there, looking at why they can improve prediction and prevention of ovarian cancer, perhaps exploring the fallopian tube. And they're part of the NEMO consortium, which is a collaboration between UCL, Manchester, Cambridge, Oregon Health and Science, and Stanford University, developing new ways to predict and perhaps prevent development of ovarian cancer. And congratulations to Alex Gentry Maharaj. She's Director of Research for CRUK ACE team, and with lots of funding there from NIHR Cancer Research UK. I also wanted to highlight the UCLH Women's Health Research Team. So they are funded by the NIHR Research Delivery Network, and basically they're employed within the trust to help deliver on research studies, and they do a fantastic job. Without them, we wouldn't be able to recruit the women, we wouldn't be able to do the consent, upload the consent, and collect all the data that tells us about how trials have actually worked. And they've expanded to 22 research delivery staff working on 50 studies in obstetrics, gynecology and neonatology, 30 of them open to recruitment. And it's not just when you recruit, there's a whole heap of work that needs to be done to collect all the data, put all the data into databases, make sure it's all signed off and close it out. And so we've got 20 in closeout, and that's a lot of work. 9 under feasibility review. So obstetrics and gynecology is ranked second for patient recruitment in the trust. So that's below neurology, but way above oncology, hematology, imaging, etc. And the Women's Health Division ranked third, below Queen's Square and the Cancer Division. So it's really testament to their hard work that we're able to deliver on some new studies. So a new study that's coming in, Enhance 24, it's a neurostimulation headband to reduce chronic pelvic pain from periods and endometriosis. And then the NEO-SCB Jaundice app, a smartphone app to measure severe jaundice in the sclera of a baby's eye to avoid having to bleed the baby. So this is currently being tested out. And I just wanted to highlight a few of their excellent outcomes. So this is from the Celebrating Research annual open event that happened at UCLH. The Generation Study, which is a study taking blood from women at birth, from the baby's cord, to basically test for rare genetic conditions. They were the third in the country for enrolment for booked women, and one of the first sites that was opened for this multi-centre study funded by Genomics England. Truffle 2, they completed this international multi-centre trial optimising timing of birth in preterm babies with fetal growth restriction, and were the second largest recruiters. And My Birth, which is a late gestation MRI study to optimise mode of birth, they've recruited over target, 175%. I mean, wow, that's fantastic. And they've also been nominated for the Royal College of Midwives Award for Excellence in Clinical Research just last month. So well done to them. In global health, we have been continuing to develop our collaboration with Uganda, the Uganda-UK Health Alliance, training Uganda doctors in maternal fetal medicine within the SCALE programme. We've recently received £18,000 from NHS England to facilitate reciprocal visits, inviting doctors and midwives over from Uganda, and Diane Lambo and myself are going over in Uganda early next year to train some doctors in how to scan. And Sarah Hillman has been working with the REACH Alliance with the University of Toronto and various medical students and other students, improving care for women from disadvantaged communities. The education team also really are doing a fantastic job. So the IBSC, the intercalated BSc, you can see our numbers. We are now up to 34. I'm very welcome to all of you who are from that course. The idea, originally when it started, we were hoping that we'd probably go for about 12 to 15, but it's been hugely successful. So well done to them. We are working on potentially delivering a cross-faculty BSc, and if people are interested in helping to develop that, it would be a BSc programme with child health, cardiovascular health, global health, healthcare informatics, and data as well. So please do contact Susie, Maria, or Melissa about that. And what about taught education? So although we closed one of our MRCs, the one in reproductive genetics and fetal medicine, and sort of moved so that some of those modules into other masters, we continue to have to be very popular with students. Our latest headcount is 93 students and 22 overseas. And mostly stable overseas students, and we are over target. And we're delighted that people would like to come and study women's health with us. And we are changing our module delivery. It's going from being short and fat, 3-week blocks, to being long and thin, to make it easier for people to perhaps do part-time working, to do modular learning as well. Postgraduate research, we have very high numbers of PhD students, 38 currently that are doing active research, and then we have another 12, I think, who are writing up at the moment. And it's a mix of doctors, midwives, scientists, clinical, lab-based data analysis, social science as well. And we have opened a double PhD with KU Leuven in Belgium. If you're interested to take part in that, then please do come and talk to us. What about funding? This is what keeps us going. So we are able to bring in good funding, both from education and also from research. And you can see our income, research overhead income has gone up, which is music to the ears of Central UCL and the finances there. And some of our grant portfolio highlights are listed here. Awards to Neha Patak, NIHR Advanced Fellowship, working on inequalities in reproductive choice, MRC DPFS to Raj Kharda, a new investigator research grant to Owen Vaughan, the Acumen study to Nikki Robertson, Welcome Leap, further funding to SUBA to develop this near-infrared spectroscopy device, a clinical lectureship award to Katie Gallagher, some philanthropic funding from the Bookman Foundation to Nikki Robertson and her team, and then to the CR UK ACE Alliance, the Nemo novel, Early Markers for Ovarian Cancer, to Philippe Correa-Martins. Not just funding, we've been visited by royalty, which is great. We hosted Her Royal Highness the Duchess of Edinburgh to the EGA Institute, to Cheney's Muse specifically. She's a patron of the charity Wellbeing of Women, and this was really an opportunity for them to show her around our institute, to introduce her to some researchers that they've supported, including Emily, who is funded by Wellbeing of Women, and she's focusing on chronic histiocytic endometriosis, so CHI, a cause of recurrent stillbirth. And she also met some patients affected by CHI. We have a number of people who've been funded by Wellbeing of Women recently, and we're very grateful that they give so much to support to early career researchers. Other visits that we've had, so Professor Jane Hurst from Imperial College came and spoke to us about the problems with warming planets and how extreme heat may impact pregnancy. And this was part of our Edward Home public lecture series, which the second one, which took place in September. If you want to know, if you want to listen to it, please do go to the link there. And we've also been doing International Women's Day events. So we had a diverse programme of events back in March 25 with performances, art exhibitions, panel discussions, etc. And Institute initiatives, we're very grateful to Olivia Moyer, who launched the second series of her Women's Health podcast, It All Starts Here. And the first 2 episodes are now published. And Holly Palmer, our communications officer, is redoing all of the comms that we have. And you have a new website. We're about to launch an Instagram as well. Please keep Holly updated with any news and events you wish to advertise. So special thanks to the EGA Hospital Charity with funding the programme today. Thank you to the programme organising committee, including the UCLH audit team, Stuart, Lavery, the Institute of Women's Health Professional Services staff. They've done a fantastic job putting it all together. This is the abstract booklet QR code. So if you want to download that, it will take you straight to the abstract booklet. And we have a series of fantastic talks and invited lectures. We're going to have a debate. And I'd like to welcome Tim Child, who's Associate Professor of Reproductive Medicine from Oxford. Thank you, Tim, for coming along to debate about the rise of influencer-led health advice. Social media is a threat to women's health. We also have our invited speaker, so Andrew Horne from Edinburgh is going to talk about non-hormonal strategies for endometriosis. And then Richard Smith from Imperial College, who I worked with many, many years ago at the Veterinary College, is going to be talking about uterine transplants and how he's really taken that to live births with a whole team. If you want to follow us, please do scan the QR code. Here are the social media handles. We're on LinkedIn, Instagram, Blue Sky, Facebook, and X. Don't know how we keep up with all of this, but anyway. There's the debate. We will be having a Slido, so we will be taking a poll before the debate and after the debate as well. Don't forget, we have a photo just before lunch, meet on the stairs, breakout sessions during lunch, and we also have an ethnographic film that you can watch, which runs for about 12 minutes, 2 screenings at 1:30 and 2 o'clock. Posters will be available on display in the Macmillan Hall, alongside an opportunity for Q&A as well. And we need your feedback. What would you like to see us presenting in 2026? It's your meeting. Please tell us. So enjoy the day. There is the Wi-Fi code. Thank you very much. And a big round of applause to all the organisers. Thank you. So I'm now going to hand over to Raj Kharda, who's going to chair the session 1 Hot Topics. Raj and Kim Botting. Thank you.
Good morning, everyone, and welcome to the Gene Therapy Hot Topic session. As Anna said, your chairs for today will be Kim Botting and myself, Raj Kharda. Unfortunately, our last speaker, Mr. Pat O'Brien, won't be here with us today, but we have two very fantastic speakers in today's session. I'm going to hand over to Kim to introduce our first speaker.
Thank you, Raj. So the first speaker today, many of you probably know her. So it's Professor Raj Julu, and she's in fetal maternal medicine, and she's going to give us a talk today on extracellular vesicles in medicine and cosmetics. Perfect.
Thank you very much. So my name is Pascal. I'm here because my group develops nanotherapeutics using exosomes and lipid nanoparticles, and we are using those to treat bones and brain. So today I present a hot topic, and actually that's very interesting. I was on the train this morning, and I saw a woman taking a comb out of her bag and fixing her hair. And then on the train, I saw someone else taking a little bag and applying makeup. So really, the way we look is important to all of us. And that's not quite new. If we refer to the ancient philosophers, aesthetics was linked to goodness. And aesthetics and beauty drives attention. It drives desire towards either virtue or illusion. And in the ancient time, it was even really, really important. And aesthetics played an immense role in all aspects, in politics, in art, in daily life. And it could be judged by the way people were looking and presenting themselves. So in a way, what we can say is appearance is the first draft of our identity. That's how we present ourselves. It's the first impression. That's how we reflect in the mirror what we think about ourselves. Our confidence is based on the way we look and on our aesthetics. So who does that affect? Everybody in the world. In the world, there is 8 billion people. And in many different ways, we all, one way or another, fix our appearance. Maybe in developing countries, we have one way, and in others, we have other ways, but we are all involved in aesthetics, and we all want to enhance our appearance. So how big is the market for cosmetics? If we look at skincare, color cosmetics, that's makeup, fragrance, perfumes, and hair care, that's about $0.64 million per minute spent in the world. If we add personal care, like soap, for example, shampoo, that's 1.13 million spent per minute. The market is absolutely huge. It's one of the largest markets. So what do we want from these cosmetic products? At any age, from teens or even it starts babies, they are not willing, but moms are willing. So from very young and teens and adult and women and men, we want our skin to be clean. We want to hydrate our skin. We want to improve at some point our skin elasticity when it starts to go down. We want to maintain our skin texture, increase our skin tone, decrease wrinkles, change something, maintain it, or improve it. So here we go. What can we do? There's an aesthetic surgeon. I will pass the name. The name is not important. It's the principle. But that surgeon said, as a facialist, I'm often asked to deliver an undetectable glow and lift. We want our skin to glow. We want to look good. Increasingly, my clients are seeking a natural alternative to injectables, which can leave the face looking overdone or frozen. Okay. So there is a history of the different cosmetics that are available, from the most natural products to the things you can apply, like the creams, and people saying, well, creams, they don't really penetrate, but we have this new cream that is actually penetrating and delivering what it should, to actually injecting, right? So I think everybody has heard of Botox, and there is plenty of other chemicals that we are very willingly injecting in our skins to modify the way we look. And then there is the word exosomes. And that's quite recent. Sorry, it went the other way. So what is exosomes? An exosome is an extracellular vesicle. It's secreted by most cells. We study the exosomes secreted by stem cells, but really all your cells are going to secrete exosomes. Why? Because that's the way to deliver a message to another cell to modify its behavior. Exosomes contain a lot of things, in particular proteins and growth factors and microRNAs and other nucleic acids, DNA and mRNA. They're really, really small. It's a nanotherapeutics. If we talk about the small extracellular vesicles, they're about 50 to 150 nanometers. They're tiny, tiny, but they're very complex. And that's the hype at the moment in cosmetics. So there was this article in The Guardian, beauty clinics in the UK offering banned treatment delivered from human cells. So exosomes are delivered or secreted by all cells, plant cells and human cells. So we can potentially use them. And what was written in this article is that exosomes can potentially improve skin's texture. Forget about potentially. Exosomes improve skin texture. And that's from someone who is a professor of regenerative medicine, so he knows what he's talking about. I can tell you myself from working on exosomes, they do work. And yes, they can improve your skin texture, for sure. We have evidence for that. I put here examples. It's on the market everywhere. If you want to have some, you can. Some are really expensive, some not so much expensive. Relatively speaking, 30 ml, 450, 430 pounds. You're going to need more than one vial, I can tell you. But still, that's interesting. When it says the best kind of exosomes are thought to be human-derived. So we went from the hype of having aloe vera-derived exosomes to human-derived exosomes. But owing to the contamination risk, most exosomes used in skincare are plant-based. So when I learned that someone else, a dermatologist, can extract exosome, he says legally, had to say legally, right? From his client's own blood, my ears perked up. So they're doing a little competition between plant exosomes. Are they dangerous? Actually, they started by plant exosomes because plant, if it's natural, we think being natural is healthier. It's not dangerous. Where poisonous plants are very natural. They can kill you. So going natural is maybe not the right way sometimes. And now we're saying, well, coming from human cells, maybe that's better. Is it better? For sure, it's better. We've done exosomes from lemons. We've done exosomes from curcuma. We've done exosomes for plants, and they work. Human exosomes are more complex. They work better. So that person was saying using a patient's own blood is safer than plant-based sources, trying to sell the message. I would have major reservations about injection of plant-based exosomes. So here we go. Let's kill the natural. Let's go for human sources. But that's interesting what they do with that. Plasma exosomes, I don't want to read the whole thing, but what's important is that they took the blood and they isolated the exosomes and they injected into my face, my neck, and around my lips. Why not? Right? There's a lot of injections we can do around our lips, face, and neck without having the risk of dying, although there is a risk, many risks associated with that. I noticed that my acne scarring and sun damage diminished. Brilliant, it works. And recommend the treatment doing maybe once a month for the cost of 1,200 euros. A bargain. It works. Is it risky? Yes, it is extremely risky. That's why I'm in the hot topics here and not presenting my work on exosomes. Why? It contains viruses. It contains growth factors. If you have a cancer, you're injecting yourself with growth factors, you're putting maybe the oil on the fire here. It contains microRNAs. MicroRNAs are involved in certain pathologies such as Alzheimer's. Are you willing to take the risk? They enter bloodstream, they go everywhere because they talk to cells, but they talk to cells to change the way they function. And they target all cells, all cell types. And they can modulate brain cells function. So I have my colleague and friend Maria here who's injected, she has injected exosomes into the brain to treat neonatal encephalopathy. It works. Exosomes love the brain. They love neurons. Now, is it legal? No, it is not legal. Human cell exosomes in UK beauty clinics are unlawful as a cosmetic. If you apply them, it's not legal. If you inject them, it is no more a cosmetic, it becomes a medicine, and it would be unlicensed medicine. So it's in tiny, well, that's just to tell you the reference, right? It's the European Commission that says two things. The first, cells, tissue products of human origins are prohibited in cosmetic products. It's a no. It's illegal. Category 1 and 2 materials, that's the regulation number if you want to look at it, and ingredients derived from cells are prohibited in cosmetic products. So take-home message here is that human-derived exosomes are banned in cosmetics in the UK and Europe, all right? It's under the prohibition of cells, tissue, or products of human origin. So when you have a human exosome facial, it's not legal. That stops there. Now let's inject them. There are plenty of ways. There is plenty of companies. You have Glove, you have others that you can have. You don't have to go to an institute, beauty institute. You can have that delivered at home for now. They're doing Black Friday. It's going to be Christmas. You can inject. You can do microneedling at home. Now, if you inject, it's not cosmetic. It's a medicine. And that triggers MHRA rules. There are no authorized exosomes injectable for aesthetics use in the UK. So when the clinics are offering injections, they're stepping into an unlicensed medicine territory. So it works, it's illegal as a cosmetic and as a medicine to improve the way you look. So the conclusion for this, before going on something else, is that I love innovation, but I like to have evidence first. So in the UK, human cell exosomes facials are illegal. Injections are unlicensed medicine. Really what we want to remember that the public, all of us, we shouldn't be the test bed for products that haven't met the basic safety, quality, and regulatory bars. It's too dangerous. So what can we do to have exosomes accepted in clinics? We need GMP manufacture. We need screen donors. We need to validate potency, purity, have independent tests for viruses and sterility. And we need to have MHRA-approved trials that show benefit. Until then, no, we shouldn't be the test bed. Shouldn't. Can we still do it? Yeah, you can. You can spend your money. So I'm going to advertise this product. It works very well. It's a professional serum. It says it contains PTT6. Key ingredients, growth factors, exosomes, albumin, fibronectins. And the person developing, it's Dr. Carlos Escobar, the power of the growth factors and exosomes in calcicim have transformed our post-procedure results and patients' recovery, making treatments far more pleasant experience for them. I Googled it. Yeah, it's not a stock image. It's really someone fantastic, Carlos Escobar. I recommend that. It's good work. It's very good work. You can inject it. You can have microneedling for the cost of £200, bargain. You could have your microneedling with exosomes, with stem cells, a bit more expensive, $250. You could put exosomes in there. It's a bit more expensive because we had to isolate them, and it costs you $450. That's to show that it's a hot topic for me because it's mixed feelings. On one side, I know it works, and I know that the work they are advertising in this clinic probably does work. So if you go and have this done by the Professor Escobar, it's going to work. But you have to be aware that it's illegal. And if it is illegal, there is a good reason. You're putting your life at risk for the sake of beauty. But at the same time, beauty is very important, isn't it? So that's what I have to say. Thank you.
Thank you, Pascal, for amazing talk. Does anyone have any questions?
Thanks, Pascal.
Come back.
So, I mean, it was great that you finished talking about the sort of need for evidence. Notwithstanding MHRA sort of regulatory approval for medicines, in terms of using exosomes, even of non-human origin cosmetically, can you explain a little bit more about what's already been done and maybe what's possible in terms of evidence collection?
Yes, something that we actually develop in our lab. So the idea that exosomes work is a nice proof of principle, and we have in vitro assays for that. And we validate in vivo. We look at biodistribution, and in vitro we have very nice models using human induced pluripotent stem cells, iPS-derived cells. We have models, for example, for skin elasticity at the moment in our group. So the evidence is always at the experimental level, and in animals we validate that it works at the organ function. To me, this first step is really experimental. It's showing that the exosomes contain factors that are really important. I think that before we can translate that really to the public, we need to identify the key elements that are responsible for this action. So because for years and years, and I said we work on brittle bone disease, but it's a collagen deficiency. Skin aging is collagen. So we are all working on collagen really. And there is factors in their proteins and microRNAs that are boosting collagen formation. So the idea is really to go from something that's a soup in the form of an exosome, so isolate the candidate proteins and then just give what's important without giving all the unwanted proteins. And that's why we develop now the next generation of therapeutics and cosmetics in our group using lipid nanoparticles, where it's the same principle as the COVID vaccine. You have a bubble of fat, a lipid nanoparticle, and then we encapsulate the RNA that is responsible for translating in your protein of interest. And then the beauty of it is like we decorate these lipid nanoparticles with proteins that are specific to certain cell types, so we can really target the effect to where we want to be, whilst the exosome will go anywhere. So I think the exosomes work, and this work, and the fact that unfortunately some people have, without knowing, done this exosome therapy as cosmetics, even if it's illegal, you have plenty of people, they all say it works. right? So we just have to remove the danger and to go through really something that is absolutely defined and not of human origin, but totally synthetic, the cases of the LNP, lipid nanoparticle therapy.
When you say that it works, does it depend on the age of the donor? In other words, if you take exosomes from a 20-year-old or an 80-year-old, would they affect in the same way the skin?
So you're talking about the origin, the age of the origin, right?
Yes.
It's interesting. I don't want. So I would say yes, because we have evidence from stem cells. So when we looked at the fetal stem cells compared to the adult stem cells, there is a clear advantage of having a younger genome. When we look at iPS-derived stem cells, where we have reprogrammed them and we have reset the clock, they are more efficient than even primary cells that we isolate from a fetus. So it is fair to say that the younger the donor, the better the outcome. We haven't tested for the exosomes, but we are testing at the moment with a master project of one of my students here, comparing the exosomes from the serum of bovine. It's bovine, of course, it's not human, but a fetus to an adult. And the idea is yes, probably, although we do not know why.
Questions? Great. Thank you very much, Pascal.
Okay, so our next speaker today is going to be Dr. Anna Keegan. I think Anna would like to introduce her own title, which will hopefully come up on the screen soon. Oh, here we go. Perfect.
Hello, everyone. Those of you who I haven't met before, my name is Dr. Anna Keegan. I work at the Carda Lab developing new neurological disorder, new gene therapies for rare neurological disorders. And one of those being my PhD, which was the development of a neonatal intracerebral ventricular gene therapy for a disease called pyruvate dehydrogenase complex deficiency. So PDH deficiency is a rare, life-debilitating metabolic disorder of carbohydrate oxidation. And typically, following glycolysis, pyruvate is converted into acetyl coenzyme A by the PDH enzyme complex, which goes on to the TCA cycle, and that's where we generate the majority of our ATP. In cases where the PDH enzyme is deficient, we get a reduction in acetyl coenzyme A. The TCA cycle is then disrupted, and we get a huge decrease in ATP production. Now, because the brain is a high energy demanding organ, this results in a neurological phenotype. This can range in severity and symptoms, but typically we see developmental delay, ataxia, abnormal brain architecture such as ventricomyalgia, and unfortunately early infantile death. The main cause of the disease is mutations in the PDH alpha-1 gene located on the X chromosome, and this affects both males and females. And for the purpose of my PhD, this is the gene that we focused on. So the model that we have at UCL really recapitulates the group of severe male patients due to its severity. And it was generated using a Krelok system to knock down exon 8 in the PDH alpha-1 gene in astrocytes and neurons only, resulting in a brain-specific reduction of the PDH enzyme activity. And this again resulted in a neurological phenotype similar to patients where we saw cerebral atrophy, abnormal locomotion function, neuropathology throughout the brain, so cortical and corpus callosum thinning. They were significantly smaller to their wild-type littermates, and we saw a maximum survival of 22 days, so a severe model. And though the original paper had been around for years, there wasn't much behavioural assessments done. So a part of my PhD, I wanted to perform behavioural assessments to characterise the model. And using traditional methods such as rotor rod and open field. So the rotor rod, the mouse is placed on the rotating rod and you measure the time it takes for them to fall off. And we showed that the mice had a really poor ability to stay on the rotating rod, showing that there was, again, poor locomotion function. And we also used open field, so the mice are placed in a box for 15 minutes and it's recorded or tracked by a computer. And this showed that the mice were hyperactive, so there was a reduction in resting time, an increase in mean speed, and an increase in total distance. So AAV vectors have been widely used in the clinic, and they're really at the forefront of most gene therapy clinical trials at the moment. And this is due to the safety profile, as well as the use of different serotypes to target different tissues. So AAV9 is currently the gold standard for treating the central nervous system. And that's not to mention Zolgensma. So Zolgensma has been a milestone therapy for AAV vectors. It was the first systemic gene therapy to be delivered to treat spinal muscular atrophy. And although super successful in the clinic, this wasn't without massive limitations due to its dosages. So these children received huge vector genomes to induce a therapeutic outcome. And unfortunately, this resulted in some of the children experiencing liver toxicities or off-target toxicities. So there's been a massive effort to reduce the need for these high titers. And one of these efforts, or the outcome of this, has been the production of novel engineered AAV capsids. And one that was brought to our attention was AAVF, which was generated by integrating a random peptide sequence into the VP1 region of AAV9. Now, the original paper showed via IV injection to adult mice, they could increase the expression profile by maintaining or using the same titer as AAV9. However, in our study, we wanted to deliver to neonatal mice via intracerebral ventricular injection. And not only did we show that AVF was significantly better at increasing the expression profile using a GFP or a green fluorescent protein, we showed actually that we could administer 10 times lower of a dose and maintain the same therapeutic profile as AV9. So you can see here with AVF low dose and 10 times higher with AV9 high dose, they're virtually the same. So then we wanted to move into our neonatal gene therapy study. We delivered a human PDH alpha 1 gene driven by a CAG promoter. We delivered via intracerebral ventricular injection with just 5 microliters in the first 24 hours of life. AV9 was delivered at a 5 times 10 to the 9 or 5 times 10 to the 10. And we compared this with the novel vector AVF at just 5 times 10 to the 9. We split the study into two, so our wild-type toxicology study, which ended at P40, and our knockout gene therapy study, which ended at P100 with 4 different behavioural assessments. So first, the purpose of our wild-type toxicology study was to see our safety profile of our gene therapies at our different dosages. And it was successful. Our wild-type toxicology, we didn't see any fatalities. There wasn't any significant weight loss in the wild-type mice. We didn't see any behavioural abnormalities using our open field assessment, so no hyperactivity. We didn't see any upregulation of microglia using CD68 staining. However, we did see a slight upregulation of astrocytes using GFP expression. But, sorry, these colours are gone a bit off. But we were satisfied that this was mild enough to move forward into our knockout study. So we kept everything the exact same, just rather than delivering to wild-type healthy mice, we delivered into this severe knockout model. And our first measurement outcome, we showed that we could not only improve the weights in our AV9 high dose, our AVF low dose, but as well in our AV9 medium dose. Similar to what we saw in our biodistribution study, we showed that AVF low dose
virtually performs the same as AV9 high dose, with AV9 high dose in purple at 80% survival, AVF low dose in the blue at 75%, compared to 0% with our PBS treated knockouts. So as I mentioned before, we had 4 different time points for our behavioural analysis, and we used the traditional methods, rotor rod and open field. And you can see here at P16, there was definitely an improvement with the treated mice, their ability to stay on the rotating rod. The same with the open field. This is total distance travelled. There was a reduction in that hyperactivity phenotype that we would have seen in the previous study. But as the study went on, up until P100, there was definitely a phenotype that we were visualizing as scientists, but the open field just wasn't picking it up. They had an abnormal gait and they were slightly ataxic. So we knew we needed to identify a new method to quantify this abnormal behavior. And this is where a deep lab cut or our AI assessment came in. So DLC is a 3D animal pose estimator that's used to quantify individual body parts in an animal that's in a Perspex box for 15 minutes. Right, that's stop a little bit. So the DLC software generates a scatter plot, and then we compare the groups within these scatter plots, and we can pull down each body part and quantify that individually. So you can see here in the tail, for example, AVF low dose has a much higher usage of their tails. And this has been associated in previous studies with being an epileptic phenotype with that rigidity of the tail, which made complete sense to us. Next, I went on and looked at whether the PDH enzyme activity, the metabolites and gene expression had all been restored. And once again, I showed that AV9 high dose performs the same as AVF low dose, as both groups restored the PDH enzyme activity to wild type levels. When we looked at metabolites using GCMS, and these pyruvate, glutamate and GABA were all abnormal in the original paper, we showed that this was restored in all groups for pyruvate. GABA was restored to wild type levels only by AV9 high dose and AVF low dose, glutamate was, and GABA was restored to wild type levels by AV9 high dose only. We showed that there was a significant increase in human PDH alpha-1 expression compared to mouse PDH alpha-1 expression in the cortex, forebrain, in AV9 high dose and AVF low dose, with the cerebellum only being targeted by AV9 high dose. And that was really important for our next assessment. So when we looked at neuronal loss and the upregulation of astrocytes, this had been virtually cured in AV9 high dose and AVF low dose in the prefrontal cortex and cortex. But if you look at the cerebellum, they weren't cured. In fact, the disease progressed pretty badly, where there's a huge significant loss of neurons in all the treatment groups, with a huge inflammation of astrocytes as well in the cerebellum. And if you remember when I spoke about the dosages earlier, there is a tiny, tiny dose compared to Zolgensma. It's 50 and 40 times lower. So I don't believe it's an artifact of the study. I believe we've just given too low of a dose, that we haven't gone far enough back into the brain. Finally, when we measured the cortex and corpus callosum, so these are signs of pathology that are associated in the clinic that clinicians will use, we showed that these were restored to wild type levels, again by AV9 high dose and AVF low dose. So in conclusion, I think we've shown that the therapy so far has been definitely successful for such a severe model. We can administer AVF at 1 whole log lower and maintain a similar expression profile or therapeutic outcome compared to AV9. But there's just some tweaking that we need to make to the therapy to hit the target, or to hit the cerebellum, whether that's increase the dose or the volume, or potentially even change the route of administration. Thank you to everyone that was involved in this project, and I'd like to take any questions.
Thank you, Anna, for a very brilliant talk. Do we have any questions?
Thank you, Anna. Really, really great to see this. I love the way you were able to monitor the mouse moving around in this perspex. So what would be the next steps? Let's say you're successful with your increase in dosing. What would be the next steps to get it into the clinic?
So we're currently applying for funding. So we will repeat these. Just funding has been a little bit of an issue as of yet. And then we'll take it from there should it be successful.
Any other questions?
Thanks, Anne. So if I understand correctly, although you've got correction of the brain phenotype, there's still some motor deficits in the treated animals. Is that right? So do you think that's a consequence of the tropism of the virus to the brain, and maybe the motor deficit you're still seeing is a consequence of like muscular problems or something like that?
So I think what's happened is we've injected into the front of the brain at such a low volume and low dose that it hasn't gone all the way back. And as the animal grows, the disease has progressed in the brain. So because the animal dies so early, we haven't seen further disease progression. I don't think it's an issue with the therapy or anything or the tropism. It just hasn't gone all the way back because the cerebellum is slightly in a fourth ventricle, so it just hasn't gone back there yet.
Any other questions? No. Thank you very much, Anna.
Thank you.
So we're now going to move on and to our debate. The rise of influencer-led health advice. Social media is a threat to women's health. And introduce Zeynep Gurtin, who is going to be chairing this session. Zeynep, thank you very much. Over to you. Can we put up the QR code on their screen for the voting? Maybe Sarah's going to be doing that. Sarah? Who's doing that? Somebody's doing that.
Hello, good morning, everyone. So we have our very exciting debate now, which is on a very timely and topical issue about the rise of influences with regards to women's health. And we're going to have Anna Marsh, who's going to speak for the motion. Anna is CQI program lead at North Central London Local Maternity and Neonatal Systems. And then Tim Child, Professor Tim Child, is going to be opposing the motion. And he is Associate Professor of Reproductive Medicine at University of Oxford. They're each going to have 10 minutes for their talk. And then we're going to have a little bit of time for Q&A. And then we will take another vote. But before they start, I think we really wanted to, Sarah, is that right? We wanted to vote before our speakers started. I think that's what we wanted, if we can get the QR code up, because we wanted to see to what extent everybody changed their minds. I know we're running a little bit early. Did we want to get the QR code up so everybody could vote before the talks? Okay, we're going to wait a few moments. You can all spend a minute or two looking at influencers on your social media apps, what they're saying about women's health.
In the welcome, yep. Do you know what slide?
Very end. Go back.
There we go. No?
10-minute time.
Thanks so much.
Okay.
Yeah, let's
And then
Perfect. Everybody, the QR code is up. If you could please log in and cast your votes now, and then we will see to what extent our speakers have swayed your opinions. Okay. Do you want some?
You want to give everyone? Are we getting it up? Yeah. Are we getting the results up? Do I need to press it? Yeah. I've got my. I think it's. Do you want the results to go up from the poll? Do you see what I mean?
Sarah, will we see the results of the poll up here? Okay, so we haven't got the results of the poll up on the screen, but so far we've got just over 50% who agree that the rise of influencer-led health advice is not good and that social media is a threat to women's health. Just over half of you in the room. And about a third of you disagree. So there's 13% currently who are undecided. And there are a few of you yet to vote, I think. So this is the benchmark that we're working with, about 55% now who agree that social media is a threat to women's health. So Tim, you've got the tougher job here. All right, we will start off with Anna. Thank you, Anna.
What a lovely way to start. I'm already winning. Hi, everyone. I'm Anna. I'm a midwife. I am the Quality Improvement Programme Manager for the North Central London LMNS for one more day, and then I'm packing all my things into a van and moving to Newcastle tomorrow. So that's why I didn't put that on the slide, because it would have filled up the whole slide. But I'm going to be a maternal medicine midwife in the North. I'm also a researcher. I have done a bit of work with the NIHR on a fellowship and with the Wellbeing of Women, looking at social media and midwifery and maternity, which I think is why I've been invited to speak today. So we know that the media is influencing health. That's not just a dramatic open as my presentation, although it is, but that's actually a fact. It's been like that for ages. It's been like that for decades, if not centuries. Think about the newspaper, think about television, huge amount of influence from those. Absolutely undeniable evidence in research. Social media we know less about. There's been pieces of work. The research area is not as strong. In the media, for example, a really great piece of work, a really kind of horrifying piece of work, found that as a result of suicides in Wales, the Bridgend suicides, the way that the media reported that was influencing more people to commit suicide. There was direct research that found that. As a result, huge funded studies. Now there's a reporting criteria for journalists, qualified professionals to report this information safely. We don't have that. We don't have that in maternity. I don't have that as a midwife. But actually, the public are the ones advising on health on social media. So I can only imagine that this amplifies the effects of social media. We don't know it, though, because there's really not that much research into it. So I'm going to do my best to work with what we can do. We do know, and there's this massive kind of sweeping statement that social media should be considered a major determinant of health. That's what we're saying. That's where we were last year. And actually, there's been loads of work since. So it is the front of everybody's mind. If you look at the Ofcom reports, about 97% of people of childbearing age are on social media. It is in the pocket of absolutely everybody. I'm assuming probably everybody in this room has it. It is affecting people on a day-to-day basis, but we don't really know how. But what we do know, I'm going to try and argue my case a bit more. Really worryingly, considering that I've told you that lots of people are influenced by social media and that it's in the pockets of 97% of the population, 28.8% of social media posts by this decent sized study, to be fair to them, were misinformation. It was misinformation about health. This is a risk. This is a risk to women's health. This was, interestingly, they did lots of work after COVID, where it actually got even worse. Think about vaccines. We've all seen it. I'm sure you've all laid in bed and got the rage scrolling through some absolute kind of rubbish conversation about vaccines and terrible things as a result on Instagram or Twitter. You know, misinformation is high. That is a risk. That is a risk to women's health. And it is women's health as well. This is taken from the Ofcom media attitudes and something report they do every year. And it is a women's health problem. It's a men's problem as well, but it is women's. If you look at some of these I'm going to pull out, this was from their annual report, makes social media or online communication platforms, same thing, makes me feel better about myself. Less women say that than men. It's a women's health problem. And I mean, beautifully followed on from that fantastic presentation by Pascal. We know that image is important to people. And social media is not helping that. It doesn't make people feel better about themselves. I feel there is pressure to be popular on these platforms. More women feel that. I spend too much time on social media. More women feel that. It is a women's health problem. Social media and maternity services. Not heaps of research, as I've said, but as a midwife, I thought I better delve into it. Research has shown that up to 89% of pregnant women use social media for questions and advice. 89%. And that was in 2018, so I can't imagine that statistic looks much better now. And I did a bit of a literature review and look at all of those things that are proven to be a result of pregnant women on social media. Misinformation. I mean, I think that's a given considering the previous statistic. Delayed help seeking. What a terrifying prospect. Delayed help seeking. Oh, I'll quickly ask a question on social media rather than going in. And actually, when you look at the state of maternity services, as a practicing midwife, we're not always there to advise women. We have problems answering our phone line in maternity triage nationally. Look at all the CQC reports, all the national reports, the Ockenden report. Women aren't getting the advice they need. So actually, of course, they're going to social media. And if that misinformation is there, that is a risk. They're going to delay getting that help seeking. How often are you in a maternity triage and someone says, oh, my waters went last night. They were a bit green, but I thought, oh, I'll just wait and come in the next morning. Delayed help advice. They're probably not going to say, oh, I just messaged my friend or I looked on this help group and they said it would probably be fine. They're probably not going to say that. But actually, if we delved into it, how much does social media play into that? I haven't put them in this presentation, but I've got some horrifying screenshots of bits of advice on Facebook groups where a woman's saying, my baby's not moving that much. How often do you see, oh, have a cup of tea or have a drink of Coke and have a think about it and come back? We know that's not advice. That's delayed help seeking. Encouragement of unsafe practices such as free birth. I'm not going to go into this too much, but if you've not read the Guardian article, I strongly recommend that you read into it. It was published, I think, last week about the echo chamber of social media providing a platform for free birth. I'm all for choice, but if that's not informed choice or it's being informed by people that aren't regulated or able to give that advice accurately, such as on these free birth groups, I think it's a very interesting point. I shan't harbour it too much, but that is a risk. And actually, the Guardian article showed that there's lots of negative outcomes on these, which we all know. Lower self-esteem, again, kind of already been plugged into. Social media addiction related to anxiety. I think this is really relevant, especially, I mean, I think you're going to hear from Chiara later, but about sleep, and pregnant women don't get much sleep. Postnatal women get even less sleep. And when are you at your most vulnerable? When you're scrolling in the middle of the night? Who's there? Not a midwife or a doctor to give advice. It's going to be whoever's on social media. So does that loop into anxiety when you're at your most vulnerable? And sharing sensitive data without realising the risks. So there are some social media groups run by the NHS, not many, but there are some, and they will get all sorts of information sent to them. That is a relatively safe place. However, on Facebook, Meta still owns that data. It's still being advised. They get kind of people say I'm experiencing domestic violence sometimes through their Facebook pages. And that information is not secure. Women seem to be happy to share on it, but it is a real risk of data privacy. And I think that our lack of engagement as healthcare professionals is perpetuating inequalities. We know from Embrace reports that there is a huge constellation of bias, they call it, where people that are facing deprivation, people from Black and brown ethnicities, people that don't have access, financial hardship, are having the worst outcomes. And we are continuing to perpetuate this because social media is free. It is 24/7. It is very translatable. So there's actually already built-in interpretation services into most social media. So actually, and I've said 97% of the population are on social media in the UK. That includes people that don't speak English as a first language. It is faceless. So there's huge bits of studies about how the next generation of people prefer to text rather than to call, for example. They prefer to look online rather than to speak to a person about it. Social media is that opportunity, but if we aren't there as healthcare professionals, they're going to be asking this unregulated conversation. It's used daily. People are already there. It's not another leaflet you've got to pick up out of clinic or, another question you've got to remember to ask. It is there. It's in your pocket already. And is it opening the behind closed doors? I think possibly. I'm just conscious of my time. Aren't healthcare professionals changing the narrative? Alas, no. I did a study where I looked at 1,200 posts of midwifery influencers on Instagram. And actually, we're not doing a great job either. So we know that midwives are worried about using social media. Our guidance is really difficult. We're quite restricted with how we can. So there's lots of private companies, private midwives that are using Instagram or Facebook to advertise their own companies. But they are overrepresenting white women. They are not being proportionate. They are not posting pictures or births of people that are from our diverse population. They're also overrepresenting home births as midwives, these popular influencers. So is that giving women an accurate picture of birth? I don't know. It's a choice for some people, but this was 65% of images and videos from the States were home births. So that's massively high. We know that we have less than 1% in the UK, but do the women looking at that know that? Not sure. And then lots of people use the pool, which is great, but again, not proportionate. So I can't miss this opportunity to say, and I'm supposed to be arguing my point that it's a risk to women's health, which hopefully I've argued. But I also just wanted to catch you, because I love a captive audience, about what you can do about this, because it is our problem. No one is going to come in and save us. No one is going to come and stop social media for maternity or for women's health. As researchers, as doctors, as midwives, as nurses, as allied health professionals, we've got to take responsibility for this. Firstly, we need to start with our regulators. We know that the NMC and GMC ain't that keen on social media, but I think it's time they are. And actually, having met with them, they're pretty open to it, but they rightly say, but there's no research, Anna, so what we're going to do about it? So we need to work with the funders, we need to work with everybody, we need to get on it and think of social media as this key priority for research. We need to listen to women. Ever asked a woman why she's asking for something in particular in a clinic? Or, when a woman says, I know I'm high risk, but I want to have this. Okay, cool. Let's talk about it. Let's talk about what's got you there. Have that conversation. In my experience, people are usually quite open about it. If you directly say, have you seen something on social media? Shall we talk about it? I think it's a really good opportunity to talk to people. Let's listen to them. And then embed social media within our clinical practice. So there are some fantastic services where women can ask questions in pregnancy to a midwife directly. They're few and far between. They're basically all just run on a wing and a prayer, and usually goodwill. Let's make that a proper service and make it a bit more across the country. And be social media aware. I think that's the key for you all. Be aware of it, keep your ear to the ground, and be open to it. It's not my time. Thank you.
Thank you very much, Anna. Lots of food for thought. And we will invite Tim up.
Thank you. So the fight is on. So the tie is off. First of all, what a great day this is. I've obviously come down from the sticks from Oxford, and we don't have anything like this. So well done to Anna and the organisers for such a good day. Hopefully my slides will come up at some point. Hopefully my time won't start until my slides come up. Or I'll do it myself.
Is yours?
Yeah. Okay, so the rise of influencer-led health advice. Social media is a threat to women's health. Now, I'm probably not the sort of person you might be thinking might be debating on this. I'm not really the right demographic or anything at all. But anyway, as I said, I've been dragged down from the sticks to talk to you about this. Put your hand up if any of you have a social media account. Keep your hand up if you ever post on health-related topics. Okay, hardly any. So that's an interesting starting point here. Social media is not a threat to women's health, and I'm going to show you why. Because it's not a threat. In fact, it's an opportunity. Anna has just argued why you should vote for me, because she's pointed out that something like 98% of pregnant women use social media. These women can't get in touch with their GP. They can't get in touch with their midwives. Labour wards are full. It's really hard for them to get advice. We should be giving them the right advice, replacing the potentially wrong advice that they're getting from influencers. It's a huge opportunity. Now, I would agree with Anna, there's definitely a shortage of studies in this area. This is just one. I come from reproductive medicine, and this is a study looking at egg freezing on TikTok and Instagram. Who is teaching whom? Over 80% of the posts on egg freezing were by non-clinical people, and the majority of the posts were wrong. So that I accept completely that that's the situation that we're in. Now, but why does this matter? Why are we talking about this? So we know that the majority of patients do search for health information online. We know that health information is really highly emotional and shareable. And we know that that can mean that patients take decisions that might be ill-informed, or they come to us in consultations with their own sort of fixed idea of what the outcome should be. And we then get a bit of a head-to-head challenging situation. Now, there is advice on this, and I disagree that the regulators are negative about this. The BMA have a really good publication here, and they are saying doctors should engage with social media, but you need to do it in a responsible manner. I'm aware that not all of you in the audience are doctors, but certainly if you're working within a regulated profession, you need to be aware that even if you're posting on a personal basis and it's anything to do with health information, you can't escape the fact that you are also a doctor and are regulated. Now, I'm going to show you a couple of case studies here. So a classic thing, certainly within my area of reproductive medicine, is this whole nutritionist thing. Patients like it because it's seen as natural. I didn't know until 2 years ago that anyone can call themselves a nutritionist, but you cannot call yourself a dietitian unless you are a registered dietitian and have gone through bachelor's and MScs, etc. And this is an issue because what it means is that you have people like this. I've searched through this person's website. I cannot find what their qualifications are to call themselves, first of all, a nutritionist, and secondly, an expert fertility nutritionist. And you'll look here that Grace she'll look after you if you've not yet tried to conceive, if you've tried to conceive for up to a year, and if you can try to conceive for over 12 months. Well, that's pretty much the whole population, I would suggest. And normally what happens is when you click through on these pages, you then see that there's a price you can pay. So you can pay $2,000 to get some online help from Grace. Maybe it will help you get pregnant, maybe it won't. I've absolutely no idea. We don't know what her qualifications are. Then we have other influencers like this. This is someone with 200,000 followers in the States, a health and wellness advisor. And if you sign up for her, you can get your levels of mercury, lead, arsenic, and aluminum, as she would have said, tested. Now, I didn't even know you could test for these things. What do you do with the results? I have absolutely no idea. But people are paying for this. So it comes back to what Anna said. People are online. People are paying for this because there's a void of information. That doesn't mean we should stick our head in the sand, though, and think, oh, we wish it would go away. It means we have to sort of take this as the opportunity to improve women's health, to let women improve their own health. Now, Instagram and TikTok are full of self-appointed experts, and we've just seen 2 experts there. Are they experts? I don't know. I think I'm an expert in my area because of 6 years of medical school, 10 years of postgraduate, 2 fellowships. I'm happy to say I'm an expert, and I'm happy to put that on my website, but it's really difficult for patients to judge who is an expert and who isn't an expert. But it's not just about influencers. On the other side of the pond, we have officials who are running the Department of Health Service, you can see on the flag behind him, and coming out with all sorts of crap about paracetamol causing autism, about don't take vaccines, about cutting women's health generally, but obviously women's healthcare as well. So this is not just about influencers. This is about us helping our patients get the right information to help them make informed choices. So should doctors be on social media? There are advantages and disadvantages. Advantages, you can increase your outreach. If you're someone who wants to show off a bit, it's a perfect thing to do. But most importantly for our patients, you can myth bust. You can break down the rubbish that's being put out there, and you can help improve public trust in what we do as healthcare professionals. Disadvantages, it might be that you might be worried that your words might be misinterpreted. Obviously, it does take some time as well if you're going to be out there on social media. And you might be worried that there are risks to your professionalism. But as I said, there's really clear guidance from the BMA in the UK and also the American Society of Reproductive Medicine in the US and various other professional bodies on this. Now, it's not for everyone to myth bust and to go out there, but every team should have a voice. And I was really pleased to see, here at UCL, obviously you're putting more of an effort as well into what you're saying to help promote women's health. Now, I only realized this morning, actually, that probably one of the best UK educators of women's health Dr. Brooke Vandermullen is sitting at the back there, is at UCL. I didn't know she was a UCL senior registrar, because within UCL, you have a lot of expertise already in people who are really pushing the boundaries to help improve women's health. So we have on the left here, Joyce Harper, and on the right, Helen O'Neill. And if I'd known Brooke was here, I would have put a big one, Brooke, there as well. Because what these people do is they try and bust myths, particularly Brooke. And I've had a go myself, even though, as I said, I'm certainly not Brooke's demographic. But about 2 years ago, I had a change in job. My kids were saying to me, oh, you know, I was complaining about all the rubbish I was seeing online. My daughter, who's a biology graduate, was telling me that she was going to come off the contraceptive pill because she'd seen all this stuff online about how it was really bad for you. And I said, you've got a degree in biology. Why are you worried about that? And she said, well, I keep seeing it coming through again and again and again. And my friends are switching away from the pill and moving on to sort of, you know, natural type methods, i.e. ones that don't really work very well. Because if you'll know from social media, if you click on something, the algorithm recognizes that and it just keeps coming back again and again and again. Now, one of my favorite online influencers is this person here in the States who's got a site, Babies After 35, 1/3 followers, and she's a professor of OBGYN, as they'd say, and maternal fetal medicine. And the thing I like about her, it's this big following, is she will look at the trends that are there. She will look at videos that are coming out, whether it's from influencers or whatever it might be, and she will take them down. She does not care what she says. She invites people to be vitriolic to her in her comments. And if they do that, she just blocks them. She's amazing. I think Brooke is the UK version of this, but get even more aggressive, Brooke. I think we need to see more. But this is a person to see. She's gone for RFK Jr., all that sort of stuff. She really breaks things down. But it's not just about doctors doing it. There needs to be organizations doing it as well. Now, the RCOG has a go, but, you know, 52,000 followers, and probably a lot of those followers are going to be professional followers, probably not the patients that we're trying to get out to. So our organizations need to make much more of an effort. We're not doing it very well at all. Now, Anna touched on, and I've done no research in social media at all. Obviously, Anna has got a research background in this area. But there are some trials showing the benefits of social media. There was this Turkish trial showing the effect of social media-based support on breastfeeding self-efficacy, a randomized controlled trial. And it did show that for these generally fairly isolated women, particularly in rural communities, that helping support them with their decision, if their decision is, for example, to breastfeed, actually results in higher breastfeeding rates. And there's similar trials from Saudi Arabia and other places as well, showing that you can get improved outcomes by supportive, factual information. And even the European Parliament has also published a recent paper on the impact of the use of social media on women and girls. And one of their main outcomes there, social media can also be used to further the rights of women and girls through large-scale campaigns, such as #MeToo and Everyday Sexism. So that's what we need. We need more large organizations really pushing the agenda here to help inform our patients. So my last slide. Social media is not a threat to women's health. The real threat is silence. Now, I asked all of you who has social media accounts, and then how many of you actually post things on that, on health? Hardly any of you did. Hardly any of you did. And I understand the reasons why. But that silence, that vacuum is filled by people who are posting either through ignorance or for commercial gain, and they have to be challenged. And it's down to, you know, it's quite a young audience here. It's down to you to really take this forward and help promote this for our patients. And my last line, let's be louder with truth than myths are with noise. Thank you very much.
Stay there, Tim. Thank you so much to both Tim and Anna. Can we invite you both up there and we'll take some questions? We've got a bit of time for questions. We've got Jenny Hall here.
Hi, Zeynep. Thank you. Hi, so I'm Jenny. I'm a professor of reproductive health and I co-direct the policy research unit in reproductive health. we have a project at the moment looking at social media and its effects on contraception. So really interesting to hear about your daughter, and that is a really common thing that we're seeing. And we are seeing that play out on, as far as we can tell, contraception use in the country. But I think one of the challenges is in the social media, there are excellent health professionals out there trying to balance it, GPs, like CSA, other people's names I can't remember. But often what they are saying is not necessarily what people want to hear, whereas the influencers are telling people what they want to hear. And so how do we get those factual messages across in a way that speaks to people in the same way that the naturalness or the wellness or the other things that people kind of connect more with, rather than the kind of scientific evidence that doesn't speak to them in the same way?
I think we just have to get those ones that, we just have to, squash you. No, don't worry. I think we have to get the people that are already on social media doing the posts as well. So we need to engage with the people that already use social media, the people that have those voices that are listened to. We need to be listening. Some of the successful services that exist, Ask a Midwife in the North, for example, is led by people that wanted to lead it. And it's actually a population of people that are representative of the demographic of the women that use the service. So it's peer kind of posting and things. I think we need to not assume that we know what needs to be posted. We need to go to the women, speak to them, and then kind of use that as a way to continuously inform the post. Appreciate it's not always that easy, but yeah, it is difficult, but we need to be listening to people.
I agree with that, everything Anna's just said. And there's another recent study from Australia where they asked people, again, postnatal women, were they looking online for information and what were the challenges that they had? And the challenges they had were knowing which information was correct and which wasn't correct. And the follow-up study for that was asking them, well, how can we better inform you? What can we do? Because it is a difficult situation, and I would be the wrong person to know what a pregnant woman or postnatal woman is really looking for, and without asking them, though, I don't think we'll know that. So I think these follow-up studies just saying, well, how can we give you that better information? And in our area, I work with Stuart's reproductive medicine area. The HFEA tries very hard to put audited, correct, believable information out there. But even from an HFEA perspective, we really struggle to get that reach, because, as you say, people like seeing what reaffirms their biases already. And the problem is, if someone's bias is already like that, it doesn't matter what you say, you're going to be struggling, but we can only try.
Thank you. We've got another question over here.
Hi, Breed Rogers. So this is an observation, and obviously there's a question with it. Listening to both of you and looking at the title, I was a bit confused because the title was Women's Health and Social Media, but both of you focused on women prior to the age of 40. And the last time I checked, I think our life expectancy is around 83. So you're kind of missing the larger second part in both of your sets of arguments. And yet I think there's a reasonable amount of evidence that social media has actually been very positive for women post-40, whether it's to do with breast screening, being aware of symptoms of ovarian cancer, menopause, osteoporosis, and also cardiovascular disease and the symptoms of heart attacks in women, which are not well known because they're different from in men. And in fact, neither of you actually analyze the role of social media post the age of 40, which might in fact have redressed the balance one way or the other. So I'm just curious, one, why? And two, if you've got a point of view on that.
I mean, there's definitely a huge amount of fantastic social media work looking at menopause and post-menopause on social media. I think the Davina McCall campaign and all of that was incredible and definitely had lots of reach. So the Ofcom media attitudes and whatever it's called report that comes out every year, reports on social media usage by age. I definitely focused on my age population because I'm a midwife, and that's kind of tend to be where my interest and kind of focus has been. But actually, there is a lot of work that looks at how people use social media differently. Have to be careful not to generalize, but it's very generalized. But which app or platform they use tends to vary. So, for example, my mum is an absolute Facebook warrior, but I haven't used Facebook for 10 years, and that it's an age group thing as well. How people use them really varies by age as well. I don't think we could ever do a study looking at, I don't know, women of all ages use, perhaps the makeup that was just presented, and include everybody in that without considering that how different age groups use and value social media. Again, really broken down in this report. It's really interesting. Older people tend to be a little bit more skeptical of social media, for example. You know, there's lots of work in there, but it is massive. So yeah, I definitely chose to focus on maternity as that's my area, but I completely agree that it is incredibly important that we consider it's the kind of women's health continuum. I suppose, including maternity and reproductive health, we will be hopefully helping people as they progress to the next kind of phase. But yeah, it's definitely super important.
It's a fair point. I guess 10 minutes was a bit tight to try and crack through a few slides there. And, you know, as a reproductive medicine specialist, I do look after menopausal women as well. It's part of the whole reproductive lifespan, obviously. So Joyce Harper from here is, I mean, her big focus now actually is on post-reproductive health or, you know, post-menopausal health. And she posts a lot on that. And what she says, which I think seems to be understandable, is that a big part of social media for that population is a sort of the supportive side and the grouping side of things, perhaps rather than looking for an easy fix to, you know, with some of these influences here. So it does shift to a different type of mechanism and outcome. But yeah, I apologize for having not mentioned that.
Different question completely. My name's Claire Stevens. I'm a GP and I'm co-clinical director of the NCL Cancer Alliance. I'm interested in your views on whether we should be starting far back to think about this problem. And isn't the main issue that we don't teach people at any age how to be discriminatory in their use of social media? And is it time now for us to request to have dialogue with Departments of Education around what needs to be mandatory in schools, and perhaps a mandatory teaching is something that's very clearly focused on how you can keep yourself, how you are discriminatory when you're seeking information. So children and young people get education on being safe on social media. But I'm thinking that perhaps we need to extend it into being more discriminatory in the way that you use it for information. And if you agree, you've got so many people here, perhaps we should use Slido to take a vote, and then this conference can communicate with the Department of Education around doing something around that.
I would agree with everything you said there. There's certainly the British Fertility Society do a lot of work with trying to push education back into schools, I guess from a reproductive health perspective, but I know they do also touch on the social media side as well. So absolutely. I think also, whether it's from a GP surgery perspective, just having more information that patients can access online about how to be more digitally literate, to understand why people might be posting stuff. So not just school-age children, because I guess by the time 10 years' time, everything will have completely changed anyway. But perhaps people right now who are looking for this information to help them understand how all of this works, and how, you know, number of likes or number of followers on a page is not the same as quality of information.
I completely agree. I think that's absolutely, yeah. I think we also need to look to ourselves as well. I mean, I graduated 9 years ago, and I definitely remember a very passionate lecture about how social media is going to get me struck off as a midwife. And, you know, if that's what the teachers are teaching, that's what we learn as learners. And, you know, that cycle is going to perpetuate. So I think it needs to be like a blanket training, really, doesn't it? It makes me think we should have training in what is good practice as healthcare professionals. But I think the next question would be, okay, cool. What is good practice in what healthcare professionals should be doing? You know, we know the principles, but what does that actually look like? And I think that's where we need some kind of funding and further research, really.
Oh. ChatGPT now artificial intelligence to rather than social media, and if you have any comment about that, it's a big topic.
Yeah, I mean, the AI is interesting, actually. So again, with my HFEA hat on, we're looking very closely at AI, and the government is about to hopefully soon release a paper on how AI should be regulated from a health perspective. At the moment, it falls under the MHRA. So any AI tool which is being used within healthcare is considered a medical instrument now and falls under the MHRA. But there's a lot of intersections there where it's not really clear who's regulating it. And, if there's a mistake, is it the guy in Palo Alto who's responsible, or is it you who's bought the machine and the software who's responsible? There's bias, there's all sorts of issues with AI as well.
And I think AI and social media are increasingly becoming the same thing. If we think about the algorithm, that is massively driven by artificial intelligence, putting in front of you what they think you want to see. So I think we need to be open-minded to it and try and use it to our advantage.
Okay, we're going to have two last very quick questions. We'll take the two questions together. We've got one at the back and one over here. I'll run to you first. Oh, you've got a mic. Go ahead.
Hi, thanks so much. You both talked about myth and misinformation in your talks and the problems associated with that. But I wanted to understand what you count as myth or misinformation, because there are a lot of people on social media talking, they're not necessarily professional, they're not qualified, but they have real experiences that happen to them. And that could be quite an educational resource. Not everyone's the same, of course, but when would you consider that it should be dismissed as myth, quote unquote?
I mean, what a blurry line it is. It's so difficult, isn't it? I think that makes me think we just need to get the overarching principle together of choice and informed consent and kind of promote that. Totally agree. And it's, for some women, they use it as a way to kind of debrief after quite a significant event. And also people want to help and they share their experience and they think that's going to help as well. It's quite complex. From the study, I think the study that I quoted, it was quite frank misinformation, as in, vaccines will give you autism kind of level of, I think they erred on the side of caution, but I completely agree. And that perhaps means that it's even higher than, the papers show, which I think is quite an interesting concept.
Yeah. I mean, lived experience, of course, is really important. And it's quite right that people would say what their lived experience of something has been, of course. But I think when you see those, it doesn't necessarily translate into them selling something to someone else or saying this happened to me, therefore studies, some made up study or whatever shows something. So I think there is a difference there.
Okay, thank you so much to Anna and Tim. That was such a brilliant debate. And I think we could have had loads more questions. We're going to do the final Slido and see. I think we're going to have the big reveal, are we? If everybody has made up their disagree. Oh, sorry, we need to wait for everyone to vote. I'm getting too excited too early on here. But thank you to our speakers. What a topical, interesting debate to have had today. And I think we're pretty lucky that we have our very own Joyce Harper, who's trying to bust as many myths as possible out there. And Helen, of course, through fertility as well.
Brooke, where are you? Are you at the back? Hi, Brooke. Hello. Welcome. If you want to know about how to do it really well with style, go and talk to Brooke, because Brooke is fantastic.
Be lovely to share your handle or something, maybe on the slide. Okay, is this the final results?
It's the Upgine mum. So the Upgine mum.
Okay, perfect. So I think, despite a really fascinating debate, we've had hardly no movement at all. So, or everybody's switched over, either that or we're all very stuck to our preconceptions. 55%. Oh, has it switched? Oh, okay. So it's switched. So now.
So it was 56% agree, disagree 32%, and 12% unsure.
And what is it now?
Yeah. 54% disagree. So it's gone from 56 down to 54%. It's very close.
They've moved the bars around, I think.
Oh, they moved the bars around. Oh, they moved the bars around. You're quite right. Oh, wow.
Okay, well, what does that mean? That means Tim's done very well, I think.
Tim's won.
Thank you to both and enjoy your tea break.
Yeah. So we now have a coffee break. After the coffee break, we will split up into parallel sessions. Maternal fetal medicine, neonatology in here, and reproductive health cancer in the Woburn suite just behind this room.
So we have this breakout session for early career researcher talks. And we're going to have 4 sessions. I am co-chairing with Dr. Horne as well. So yeah, it's our pleasure to welcome you here. Our first session is going to be presented by Kim Botting-Lowford, who will be talking about treating severe fetal growth restriction with maternal uterine artery gene therapy results in asymmetric fetal growth with selective expansion of perirenal fat mass. Sorry.
Perfect. Thank you, Tanya. So what I'll be talking to you today is about fetal growth restriction. It's a severe complication of pregnancy, and it happens in about 8% of pregnancies. And it's not just a small baby, it's a baby who should have been bigger, but whose growth has been restricted in the womb. It contributes to a conservative estimate of 1/3 of all stillbirths. And if the fetus has survived that environment, she goes on to have an increased chance of neonatal morbidity or mortality. And if they get through that hurdle, they actually also have an increased risk of sort of aging diseases such as cardiovascular disease and cardiometabolic diseases. And there's absolutely no treatment. In the majority of cases, once you remove chromosomal abnormalities, for instance, it's caused actually by a problem in the placenta. And this problem actually starts very early in gestation. And it happens when the trophoblast cells of the placenta during placentation, they're supposed to remodel the spiral arteries of the uterus. And in doing so, what they do is they expand the volume that these vessels can take. And that's really important because you need to supply that then grows the placenta. And during fetal growth restriction and also in preeclampsia, there's inappropriate remodeling of the spiral arteries. And this results in poor perfusion of the placenta with maternal blood. And you can see this clinically in the second half of gestation. In an appropriately grown fetus, you'll have an increase in uterine artery blood flow towards the end of term, 40 weeks in humans. But in a consequence of fetal growth restriction, you have inappropriate increase in uterine artery blood flow. And you can see quite a difference by the end of gestation. Now, this poor perfusion of the placenta results in the placenta itself becoming hypoxic and having higher oxidative stress. And you can actually see this clinically using Doppler studies of the umbilical artery of the fetus. That fetal heart is having to beat against the pressure and resistance that is in that placenta. So if there's high resistance in that placenta, you will start to see an increase in pulsatility index in the umbilical artery, It starts off looking healthy, which is the top one in green, where the peak is during systole, the trough is during diastole. And if that resistance is really high, you end up having no flow during diastole. And actually, when the heart is relaxed and things are looking terrible, blood will start going backwards. This is the point of delivery. This hypoxic and oxidative stress within the placenta means the placenta becomes insufficient at supplying the fetus with enough oxygen and nutrition to grow. And you can see in these estimated growth curves, especially in that really rapid growth phase that the fetus has in the second parts of gestation, their weight starts dropping off of the median line in red. So fetal growth restriction is defined as a fetus who has an estimated weight below the 10th centile, third of its extreme. And it's this adaptation the fetus has to make to survive this poor in utero environment that actually is now programming that fetus to disease later on in life. It may be beneficial to survive, but then it has negative consequences later in life. But ultimately, what will probably end up happening in severe situations is these fetuses will have to be delivered early because their Doppler suggests that they will otherwise demise. And we know that if a fetal growth restricted baby is born early, they actually do worse than an equivalently early born, healthy grown neonate. And so if we look here at 27 weeks in particular, if you had fetal growth restriction, your survival is sitting at about sort of 65%, but you can see actually half of those will be born, but actually have some sort of disability. So the aim of a treatment we want to treat fetal growth restriction is ultimately to increase the time at which the fetus can be happily surviving in the womb. If you can delay delivery just by 1 week, you can significantly reduce the amount of disability that neonate may then end up with and increase their survival. And if you're looking at it on a cost perspective, you would decrease the cost that's associated with looking after this fetal growth restricted infant by 30% for just one change of week of delivery across the preterm range. Now, no treatment for fetal growth restriction is not through lack of trying. The lab I was in before I was working with Anna, we were also trying to look at it. There's been so many different ways that we've tried to attack this problem with no result. The closest we got to was sildenafil, but that trial had to be suspended because sildenafil will cross the placenta and it did interfere with the maturation of the pulmonary circulation of that fetus. Ultimately, what you want to do is increase angiogenesis and increase the health of blood vessels. So our approach to doing this is to actually increase the amount of vascular endothelial growth factor in the uterine artery of the mothers who have low flow when they have a fetal growth restricted pregnancy. And by doing so, we would want to increase the expression of VEGF in the uterine artery. We would hope to dilate the uterine artery so that there is an increase in blood flow towards the placenta. We'll do this by activating angiogenesis and protecting the vasculature in a hope to restore perfusion of the placenta to increase fetal growth in severe fetal growth restriction. Now, the first target that Anna tried, this was before my time, she went with the obvious target of vascular endothelial growth factor A. It is the most dominant isoform that you'll find in the circulation. She gave VEGF-A to sheep pregnancies that had fetal growth restriction. And she found, if you concentrate on the brown, that if they got a vascular endothelial growth factor to the uterine artery, there were less severely growth restricted fetuses compared if she gave saline instead. Then interested in whether or not it had effects on postnatal health, but also by using an animal model with a placenta that's more similar to ours, a placenta that will have trophoblast invasion like humans do, and also have the same sort of degree of membranes between the fetal and the maternal circulation. The guinea pig is an excellent placenta, which you would not believe, for human development. Then had a model of fetal growth restriction in the guinea pig. The growth restriction was induced, importantly, by maternal nutrient restriction before conception, so you're interfering with that stage of placentation. At mid-pregnancy, she gave vascular endothelial growth factor A to the uterine artery of these pregnancies. And then 10 days later showed that you would have an increase in VEGF. Excellent. There was a decrease in contractility of those uterine arteries if you isolated them out and assessed them in a water bath. And then there was an increase in fetal weight by the end of gestation, crown rump length. And then Owen, who's also in the audience, he took them out to early adolescence in these offspring and tested their health, blood pressure as well, and there were no adverse effects in the offspring. But they were seeing with VEGF-A, as well as in other groups who were using VEGF-A as an adenovirus in, say, ischemic heart disease treatment, that actually VEGF-A has other non-vascular targets. And that's because it acts via vascular growth factor receptor 1, these non-vascular targets. And they were also seeing an increased degree of vascular permeability and edema in the adventitia. So instead, the Everest group pivoted the gene that they were then put inside the adenovirus, and it's now been changed to vascular endothelial growth factor D. And the delta N, delta C just means it's the short form of the human vascular endothelial growth factor D. And that's because that does not act on receptor 1, and it also has the greatest affinity to receptor 3, which will still do angiogenesis, less affinity for 2, where the vascular permeability was. They got healthy sheep uterine arteries, and they've treated them with VEGF-D and shown that the vessels themselves were less responsive to vasoconstrictors such as phenylephrine, and they were better at vasodilating in response to bradykinin. And importantly, they didn't see any of the sort of inflammatory or vascular changes that were negative consequences of VEGF-A when they gave VEGF-D instead. So this is where I come in. So we use the same animal model that I talked about before in guinea pigs, maternal nutrient restriction to induce fetal growth restriction. We started it from 4 weeks before conception, where they get 70% of the diet of a control until mid-gestation. Because guinea pigs, like humans, the massive acceleration of fetal growth happens in the second part of gestation. You need to increase that proportion to 90% to maintain the pregnancy, or you'll lose it. At 35 days gestation, we did ultrasound to assess the size and the Dopplers of the umbilical arteries of the fetuses. And then we administered the adenovirus for vascular endothelial growth factor D, or we added saline. And then we did a post-mortem at about 60 days gestation. So maternal nutrient restriction resulted in fetuses that were already smaller at mid-gestation. This is an important point because if you want to use a preclinical animal model where you want to treat fetal growth restriction, you need them to already have fetal growth restriction when you treat them. So we were able to establish that they had a smaller crown rump length at mid-gestation, and they also had this clinical feature of an increase in pulsatility index in the umbilical artery. So we have the signs of an increase in distance.
Really good to see you in person. How are you?
We then carry them to term and we find that they are severely growth restricted. For an animal model, this is a very severe fetal growth restriction where almost all of them are under the 10th centile of a control body weight. And this growth restriction is asymmetric. And that's important as well. So they're not shrunk, small or over. They have a bigger head relative to the rest of their body, which is also a clinical feature of fetal growth restriction and part of the fetus's response to dealing with that adversity. This is how we give the therapy. So the adenovirus is really cold in the freezer up until the point that we want to apply it, and we mix it with a pluronic gel, which does the opposite to what you might think. When it's cold, it's a liquid, but it warms up to body temperature, it forms a gel. And that's really important because when we apply this to the outside of the umbilical, the uterine artery and the radial arteries, we want it to form a gel there and sit there for just long enough so we can incorporate our vector into that vessel. The aim is not for it to circulate. We are treating the vessel itself. And in the middle diagram there, that's an example of a guinea pig uterus. This is a non-pregnant uterus. It's got two horns. The biggest red vessel pointing down there is the uterine artery. So there's two, and then the radial vessels come off towards the uterus. And then in previous studies, they added a LacZ reporter. So beta-galactosidase will change the color in a colorimetric assay afterwards. So everything that's blue, you can see where the vessel's incorporated. We then recovered the animals and then collected all the tissues imaginable at the end of gestation to determine where the vector goes. For the 1 times dose, focus in on the green. I've got in order of highest concentration to lowest concentration. This was through qPCR with probes specific to the vector itself. And we show the greatest concentration in the radial arteries that we treated. Perirenal fat's another one, and then the uterine arteries, and actually a range of maternal tissues. This is in line with reproductive toxicology studies where they've done that in rabbits, and what you find is usually by about 3 months postpartum, this is completely gone. It's all resolved. We attempted dose escalation, and you can see there's a bit more in the pinks for a given organ, and a little bit in the placenta, which wasn't there if you'd only given the 1 times dose, which is a therapeutic dose. And most importantly, regardless of what dose that we gave, none of it has touched any fetal tissues. We do not have it in the fetal circulation. We then sent all of our tissues off to a pathologist, Anil Sabire, which I don't think is here today, but many of you will know, and he didn't identify under blinded conditions any anomalies. We took maternal and fetal blood. We did biochemistry and hematology, and again, there was no adversity to the mother or fetus of this treatment. But what did it do to fetal weight? So the green ones are the animals that were treated with vascular endothelial growth factor D, and you can see just as an overall group effect, it didn't have a significant effect. But you can see there is a cluster of animals where there was a pronounced effect on their growth. So if you classify them in terms of birth centiles, there were significantly more animals in the therapy arm that had a body weight that reached the 7th centile of controls, and even some of them got to the 25th centile, and none of them in the saline group did. This is likely a problem with using a litter-bearing species as an animal model when you're trying to treat with this therapy. But what happened on a group level, a whole effect of giving therapy of adenovirus to VEGF-D to the uterine artery is that the fetuses gained more fat. So much fat that there were some of them were as fat as controls. So this is a readout that we are delivering nutrition, more nutrition to these fetuses, but they are choosing for that nutrition to be laid down as fat, measured in the perirenal fat depot, rather than growing other organs. We had a MSc student, Kate Norton, who unfortunately can't be here today, and she was interested in why that may be. So perirenal fat is very important for a neonate when it's born. It is predominantly brown, so that means it's involved in thermoregulation. It's also an emergency store during that neonatal period when they're establishing feeding. And it's the largest brown adipose tissue store in the abdomen. And in guinea pigs, like in humans, and really sheep as well, there's limited animal models where they will actually lay down brown fat before delivery. And so guinea pigs are a very good model to be looking at perirenal fat. And Kate found we took one male and one female from each litter. At the end of gestation, we took their perirenal fat and she assessed a whole range of genes that could be involved in the maturation of this perirenal fat. And what she found was that if you compare those that were growth restricted in grey to those that were healthy in control, that she had an upregulation of the gene signaling for IGF-2. So IGF-2 is a major growth factor for the fetus especially. And IGF-2 was increased in the perirenal fat compared to healthy controls. There was also a tendency to, but not significant difference of its main receptor, which would initiate growth through the signaling of IGF-1 receptor. There was also a downregulation of IGF-2 receptor, which would normally clear IGF-2 from the circulation, making it less bioavailable. And there wasn't a change in IGF-1 mRNA, which is its counterpart ligand to stimulate growth. And what's very important here is that if they treated with VEGF-D or saline, it made no difference to this gene profile. So what it looks as though is that we have exploited a programming effect of that fetal growth restriction in that infant. And by delivering more nutrients, we're preferentially then growing the perirenal fat. We had some growth changes as well. So if you looked at the occipital snout length, which for guinea pigs is a bit longer than ours, we found an increase in the rate of growth. So we were able to look at the size of it on ultrasound at 35 days and then what it was at the end of gestation. So they are growing some bone longer. And then if you look at the proportion of growth of their abdomen versus the proportion of growth of their head, actually they were growing their abdomen faster rate than they were growing their head, which aligns with what we were seeing with the increase in perirenal fat. But we were really interested in what was different about the ones that responded compared to those that didn't. Are we just burying ourselves with the non-responders that we can't actually see what is actually happening? So we've had a look and just done a bit of a sub-analysis of those where there was a response. And what we found is that for those where there was a response, they had grown a bigger placenta. So this was an effect of vascular endothelial growth factor D. They have bigger placentas. And unsurprisingly, if you're increasing flow to that placenta, you now have a bigger placenta that may have more transport capacity. Now you've got bigger organs. So now the fetuses were able to grow their livers, they were able to grow their lungs, they were able to grow their hearts. But there wasn't much of a change going on in the brain, which fits in very well with what we know physiologically, and that's that during fetal growth restriction, you protect your brain. It will tend to grow in fetal growth restriction anyway. So in conclusion, maternal nutrient restriction in guinea pigs from before conception results in asymmetric growth restriction by mid-gestation with an increase in resistance within the placenta, very clinically relevant. And if you then treat at the middle of pregnancy when you already have fetal growth restriction with adenovirus vascular endothelial growth factor D, there is no evidence of harm. There is an increase in fetal weight of some, but not all fetal growth restricted fetuses. And the greatest growth was seen in those where the placenta was able to grow and support organ growth. Increased perirenal fat mass was due to the programming of fetal growth restriction on that perirenal fat by IGF-2. And by exploiting this mechanism, we may be able to improve perinatal outcomes in severe fetal growth restriction, even if overall their body weight hasn't changed. So this adds to a large body of evidence that Anna's collected over the years. The maternal uterine artery adenovirus vascular endothelial growth factor D is a promising clinical therapy for treating diagnosed fetal growth restriction. Thank you very much.
Okay, excellent. Thanks, Kim. And I think Kim will be happy to take questions in the break. So I'd like to invite the next speaker, who is Laura Pentecost and Amy Cresswell. Lindsay Cresswell. Okay, so Lindsay Cresswell is going to speak about maternal placental growth factor predicts outcome in early onset fetal growth restriction.
Thank you very much for having me to speak. I'm presenting on behalf of Laura. This was her MSc project that both myself and Professor David had supervised in the fetal medicine unit. And our talk today is on maternal serum placental growth factor concentrations and outcome prediction and early onset fetal growth restriction, which we feel is a very promising biomarker for being able to predict the outcomes of fetuses with early onset growth restriction. We've talked a little bit about the problem already today. We know that fetal growth restriction is defined as the failure of a fetus to achieve its expected and genetically predetermined growth potential due to a pathological cause. This is the consensus of the definition of early onset fetal growth restriction, which has been reached following a Delphi consensus. Early onset fetal growth restriction less than 32 weeks is when we have an AC or an estimated fetal weight less than the 3rd percentile, or the presence of absent or reverse end diastolic flow in the umbilical artery, or it can be defined if you have a combination of features, including an AC or estimated fetal weight less than the 10th centile, when there is an increased pulsatility index in the uterine or the umbilical artery Dopplers. The reason why we care about this is we know that this is associated with adverse outcomes for our fetuses, including stillbirth, neonatal sort of morbidity, and also preterm birth. In terms of the Everest sort of prospective study, this has really been the basis for a lot of and really inspired the research that Laura had done with Professor David and myself. And the Everest multi-center prospective study was designed to try and characterize the natural history of these pregnancies that are affected by early onset growth restriction, identify ultrasound and biomarkers that are able to help us in terms of prognosticating for these pregnancies, and to be able to understand the biological mechanisms that underlie fetal growth restriction. And this looked at women who had a diagnosis of early onset fetal growth restriction between 20 and 26 plus 6 weeks of gestation, where fetuses were less than the 3rd percentile, with no structural anomalies, no known chromosomal problems, or no viral infections, focusing really on placental-mediated fetal growth restriction. And these are the sort of wealth of outcomes that we know about these fetuses that have early onset growth restriction. This is when we took the UK subgroup of the early onset FGR fetuses from the FGR study and then matched them with sex-matched, age-matched, appropriately grown fetuses. And these are the outcomes that we counsel patients with in clinic, which, can be quite frightening for patients whenever they come to clinic, that 1/3 of these pregnancies will either have a stillbirth or they will have a termination of pregnancy because they will never reach a viable gestational age or weight. We have a mean gestational age of birth whenever you have this diagnosis at 31.4 weeks of gestation, and 80% of these infants will be born preterm less than 37 weeks, and 85% of them will be admitted to the neonatal intensive care unit. When we then look at what the outcomes of these neonates are, the postnatal mortality in the fetal growth restriction group is about 1 in 10, and most is because these infants are being born less than 29 weeks in a very extreme premature group. 39% of those that survive will have major neonatal morbidity, and this is typically sepsis or having bronchopulmonary dysplasia. And early onset growth restricted infants are much more likely to experience a composite of poor outcomes compared to their age-matched sex-matched controls that are appropriately grown, with an odds ratio of 5.0. And these include things like respiratory distress, sepsis, treatment for retinopathy of prematurity, necrotizing enterocolitis requiring surgery, and also focal brain injuries, which have an implication for these children going on in their early childhood and into adulthood. Now, in terms of looking at PLGF, so we've talked a little bit about vasculogenesis, and we've talked about trophoblasts and how that is really important in the etiology of placental-mediated growth restriction. So PLGF is a member of the VEGF family. It has angiogenic, vasculogenic properties that have a huge influence on trophoblastic growth, differentiation, and invasion into the maternal deciduea. So there is good biological plausibility of how this could be useful in being able to stratify our patients. If you have a low PLGF, it stands to reason that you're more likely to have placental-mediated growth restriction. And this is one of, again, another study from the Everest group that looked at what the most discriminative model would be to predict fetal death or delivery less than 28 weeks because of growth restriction. And the best prediction included using PLGF and the umbilical artery Doppler with an area under the receiver operating curve of 0.89, suggesting that it has an excellent discriminative ability to be able to predict and identify those fetuses that are at the greatest risk. So this again was the kind of sort of basis for the study that we undertook. So this was a retrospective cohort study looking at women attending our early onset fetal growth restricted clinic in UCLH. Between 2022 USA and 2024. These were all singleton pregnancies that had that definition as per the Delphi consensus. And we looked at maternal serum PLGF that was sampled at diagnosis. The aim was to be able to, I suppose, give a comprehensive review of real world FGR cases and their findings to be able to help us in counselling patients, but also to see how well this how well low PLGF for the gestational age was related to having adverse neonatal outcomes. And we did a univariate logistic regression analysis to be able to look at that. So I'll just show overall kind of the very basic demographic data. So there was 102 singleton pregnancies. The median age of diagnosis was 25 weeks in our cohorts, and the majority of our patients were being diagnosed less than 28 weeks at 57.8%. We had actually very good outcomes of our overall cohort. We had 91.2% of women having a live birth. When we look at the spontaneous fetal deaths or the stillbirths, most commonly these are related to, again, placental insufficiency. So we performed placental histopathology for all of these cases. We had 3 cases of MVM, 1 finding of FVM, 1 case of a Breus mole, and 1 case of CHI. We had 3 women who went on to have a termination of pregnancy, and this is because these fetuses never reached 500 grams and the prognosis was very poor. And then we also had neonatal death and infant deaths, which were all related to prematurity. Then in terms of birth outcomes, you can see that less than a quarter of women had a term delivery. So this was, again, very much in keeping with what we had seen from the Everest cohorts. And we had then 14.7 being born less than 28 weeks. And we had 25.5% being born between 28 and 32 weeks. In terms of mode of delivery, we had less than 20% of women achieving a vaginal delivery, and the majority of these women require a caesarean section because of concerns of fetal distress in labour. And then very interestingly, then getting to the crux of it, looking at sort of maternal serum PLGF concentrations to predict outcomes. So we have the dark green bars, which is looking at women who had a PLGF less than the 5th percentile per gestational age. And with the blue, then we have PLGF, which were more than the 5th centile per gestational age. So then looking at all of the bars together, we have preterm birth less than 32 weeks, where you can see that only 1 woman had a PLGF greater than the 5th centile who had a preterm birth. So this looked to be an excellent discriminator for being able to predict those women who would need to have early delivery to be able to prevent stillbirth. In terms of then looking at the other outcomes, so if you have a PLGF less than the 5th centile, you're more likely to have abnormal Dopplers, you're more likely to have a birth weight less than the 3rd percentile. All of those fetuses that died within our cohort then again had a PLGF less than the 5th centile. And looking then at adverse outcomes for the neonates and the woman having severe preeclampsia, again, all had PLGFs less than the 5th percentile. And this supports our hypothesis that a low PLGF indicates a worsening phenotype of FGR, and these are more likely to need early interventions. Then comparing PLGF with our other biomarkers, things that, again, we look at in clinical practice every day, PAPA, uterine artery Dopplers, abnormal uterine artery Dopplers. Well, PLGF was the only biomarker that we use that had a sort of an ability to be able, or was the strongest real predictor of having an adverse outcome. So preterm birth weight less than 3rd percentile, we saw that these were statistically significant, where other predictors, PAPA, uterine artery Doppler, abnormal umbilical artery Doppler, was not statistically significant to predict having a preterm birth or birth weight. It's important that we also stress that all of our cases of mortality, as I said, had a PLGF less than the 5th centile, consistent with those severe phenotypes, and all deaths and terminations of pregnancy had a PLGF less than 25. We typically use 25 or 20 within our counselling in clinic to be able to say to these patients, we feel that you're more likely to have a severe phenotype, we're more concerned about you, we're going to see you every week to be able to look for these adverse signs on scan and predict delivery. So in terms of our conclusion, in pregnancies with early onset FGR and an estimated fetal weight less than the 10th centile, low PLGF less than the 5th centile is strongly associated with a preterm birth less than 32 weeks, a birth weight less than the 3rd percentile, and perinatal death. PLGF is outperforming conventional markers that we would use, PLGF, uterine arteries, for outcome prediction, and therefore it has excellent clinical value for risk stratification and counselling our patients, and helps us identify those patients that need to be seen every single week. In terms of the implications of this, we believe strongly that this supports integration of PLGF testing into routine early onset FGR care, but larger studies are required to be able to validate our findings. Thank you.
Excellent. Thanks, Laura. And if you don't mind, I'll ask you to keep questions for the break. Thanks. Okay.
Do we have our next speaker? So our next speaker is Lauren Crawford. Yeah. Sorry. Yeah. So yeah, we have Lauren Crawford, a case study on cumulative live birth rates in patients who underwent pre-implantation testing for monogenic conditions and the potential of increased success following germline genome editing.
Now say it 3 times fast. So I'm sure we've all heard a lot about in vitro fertilization, the central dogma being you take a sperm, you take an egg, you mix them together. This can either be through conventional IVF or through ICSI. You then culture that embryo for 5, 6, 7 days. If you're happy with it, you transfer it. If you don't, you get rid of it. Over 13 million babies have been born through IVF since the birth of Louise Brown in 1978. So we know that this is an incredible tool for people who can't conceive. But what about for people who can conceive, but when they do, they have a high chance of having a child with a genetic disease? So pre-implantation genetic testing for monogenic disease, or PGTM, is an established technology considered the gold standard for avoiding genetic disease. With that day 5 embryo, you take a biopsy, so a few cells, and you genetically test it for a mutation. If it's got the mutation, you throw it in the bin. If not, you're happy to transfer it. Whilst this may seem simple, the discard of affected embryo means patients have fewer and fewer to choose from. We already know that IVF has loads of places where it can go wrong, whether this is gamete mutational arrest, fertilization failure, implantation failure, miscarriage, etc. So adding in that extra step of screening and decreasing the number of embryos that are available means that people have lower and lower chances of having a baby. We also know that most people are only screening for one mutation, but there are people who are screening for multiple. And we know that women are starting to have babies later. Although PGTA itself is a bit controversial, people are still having PGTA more and more. And so that's making more and more embryos which are unviable and more thrown in the bin. And this paper by Van der Kellen et al. Basically found that although these people are fertile, they are having similar or lower rates of having a child as infertile people. So rather than throwing these embryos in the bin, what if we were able to rescue them? And by doing this, we could do it through CRISPR germline genome editing. This is a Nobel Prize-winning technology which has been used in almost every single species to correct mutations that cause disease. So for my master's project, what we wanted to do was analyze cumulative live birth outcomes for a PGTM cohort. So people that were going through this testing, seeing what their chances of having a baby were. We wanted to look in a bit more detail as well. So looking at what kind of indications were being screened for, how many, and how many of them could be amenable to rescue, and what effect could that have on people having babies. So we wanted to really quantify the potential benefit that CRISPR could actually have to these PGTM patients. So we did a single center retrospective cohort study over 10 years. We had 1,925 patients, almost 8,000 cycles, and over 42,000 embryos. And we wanted to look at people that were having PGTM. So we were either looking at people that were unaffected and had euploid embryos. So this gave us our cumulative live birth rate. And then we wanted to look at those that were affected but euploid, so that could potentially be amenable to CRISPR rescue. And that could potentially give us a better cumulative live birth rate. So the general population, as I said, 1,925 patients with an average maternal age of 31.9, which is similar to everyone accessing IVF. I just really want to draw your attention here to the potential that is lost when people go through IVF. So on average per cycle, women were getting 12 cumulus oocyte complexes taken. When they went through the maturation, insemination, fertilization process, by the time we were looking at how many embryos could be transferred, it was 1.8. That's only 15% of those eggs that got taken were potentially viable to transfer. So looking at our results, if we were to look at the donut on the right-hand side here, so if you look at the outer one, this is how many babies were born. The middle one is looking at those embryos, and the very middle one is looking at the CRISPR potential. So our cumulative live birth rate was 67% of all women going through any number of cycles. Of those 33% that were unsuccessful, looking at their embryos, only 12 women had no embryos at all that were available for biopsy, so didn't even go through any PGT. And of the ones that did, there was an equal mix of people that had genetically normal embryos but were still unsuccessful and didn't have a baby, and people who didn't actually have any genetically normal embryos that were able to transfer. In both of these groups, about 70 to 80% of people had embryos that could be amenable to CRISPR rescue. Had that have been implemented, the number of transferable embryos could have increased from 39 to 74%, so basically doubled, meaning that cumulative live birth rate went from 67 to 74%. That is, from that 1,925 cohort, 146 women who walked away without a baby could have had a baby, and that is including success per embryo transfer. We then wanted to look at, obviously we can talk about cumulative live birth rates, but women that are going to an IVF clinic don't care about cumulative live birth rates. They want to go into a clinic, they want to go through one cycle of IVF and come home with a baby. So we then wanted to look specifically at that first cycle. So as you can imagine, that live birth rate was drastically reduced. So only 39% of people had a baby within their first cycle. Again, of the people that were unsuccessful, we were still looking at about 70 to 80% of people had embryos that could have been amenable to CRISPR rescue. That's over 200 people could have not had to go through that second cycle. That is, if you're imagining the injections, the physical, the emotional, the financial pull that it puts on people to have to go through multiple rounds of IVF, the outcome is insane. So what we currently know about CRISPR is there's only one person that's actually done it in human embryos, and he went to jail. But obviously that was 6 or 7 years ago now. There's a lot of space for interpretation, and there's a way that we could do it in an ethical way. So next thing we need to do is look at the feasibility. So what percentage of embryos could actually be amenable to CRISPR rescue, and how could this work in the clinic? Thank you so much for your time.
Thank you so much. We do have time. We'll do a little break for a quick question. So if you want to stay, Lauren, you actually, yeah. So if anyone has a question, please.
Great talk. In your analysis, have you looked at the difference between autosomal recessive PGTM and autosomal dominant or X-linked dominant?
Yeah, so we looked between each the dominant versus recessive, and similar to the rates that you can imagine, it was a 3-to-2 ratio. So people that had a dominant condition were 1.5 times more likely to not have a baby than people with recessive, because obviously you can transfer carriers.
And you would benefit more from the CRISPR technology for dominant disorders, right?
Yeah.
Thank you.
Any other question? Well, if not, thank you so much, Lauren.
Okay, so then it's my pleasure to introduce the last speaker in this session, who's Anna Murtaza from the Neonatology department. So Anna's going to present curcumin derivative nanoparticles as a novel treatment in neonatal hypoxic ischemic brain injury. Thanks, Anna.
Hey, hi, everyone. My name's Amna. And for the last year, I've been researching curcumin derivative nanoparticles as a treatment for hypoxic ischemia, or HI. So a bit of background. HI is caused by lack of blood flow and oxygen to the brain, and it's the most common cause of disability in neonates. It's caused by reasons such as uterine rupture or placental abruption, and it can lead to long-term neurological impacts and potentially be fatal. So a bit of pathophysiology of HI. There's 4 general stages: primary, latent, secondary, and tertiary, with the secondary being the one in which there's most cell death. And there's 3 main mechanisms that cause this: inflammation, excitotoxicity, and the formation of reactive oxidative species. And another thing that exacerbates damage is the activation of microglia and astrocyte cells, and that's what we focused on in this study. There's a latent phase in which there's a transient restoration of blood flow, and this is a phase where we tend to give treatment as is the ideal therapeutic window. Currently, there's only one approved treatment for HI, and that is therapeutic hypothermia, in which the body of the infant is cooled down to 33.5 to 34.5 degrees. However, there's still multiple side effects such as bradycardia, hypertension, and arrhythmias. And so Unfortunately, 40% of neonates are treated still go on to develop adverse neurological outcomes, and 8 infants need to be treated for one of them to show beneficial effects, which is why it's very important that we come up with a more effective treatment. So that's why we started looking at curcumin. Curcumin is a chemical compound that has antioxidant and anti-inflammatory properties, and multiple studies have shown that it reduces brain tissue loss, cell death, and glial activation in neonatal HIE. However, some disadvantages is that it has a low bioavailability and low aqueous solubility, so is absorbed not that well in the body, and it's metabolized quite quickly. And so our 2 solutions to overcome this in this study was to use nanoformulations to allow crossing of the blood-brain barrier, and to use curcumin derivatives as they are more bioavailable and have stronger antioxidant properties. So in this study, we looked at these 2 particular derivatives, CNB001 and J147, and as you can see, they're derived straight from the structure of curcumin. So the aims of this study were to compare glial activation in mice that were induced with HI when treated with our derivatives, and we assessed this using alpha-M and GFAP astrocyte markers. And we also compared the in vitro properties of the curcumin derivatives, and our hypothesis was that the mice that were treated with our derivatives would have a significantly reduced glial activation. So then we went on to prepare our mice. We used postnatal day 9 mice, and we included ischemia in the left by occluding the left common carotid artery to induce ischemia in the ipsilateral hemisphere. And then we put the mice in a hypoxic chamber for an hour at 10% oxygen. And then the mice were treated with either a high or low dose of both of our derivatives, or they were treated with the MT solvent, which is the DMSO group. And then we also had a naive group, which is completely healthy mice, and a sham group, which had the surgical procedure done, but no HI induced and no treatment given. So our general methodology, we used alpha-M as a stain, as it stains for activated microglia, and this is general how we did it. So we prepared the slides using 5 sections per brain. We fixed the brain sections onto the slides using formaldehyde, and then we used bovine serum antigen to prevent non-specific antibody binding, and we used 5% goat serum to prevent non-specific binding of the secondary antibody. And our primary antibody was rat anti-alpha-M, and we left this overnight. And then the next day, we paired goat anti-rat secondary antibody with mouse serum, and we added this. And then we used avidin biotin complex to amplify the signals. And we used diaminobenzidine to give a brown color change that could be seen under a microscope. And then we looked at all of these slides under a microscope, and we assigned a score from 0 to 4 based on the level of activated microglia, with 0 being not that much coverage of activated microglia and 4 being the majority of the slide covered in activated microglia. And we did this for 6 brain regions: the cortex, external capsule, piriform cortex, striatum, hippocampus, and thalamus, as these are regions of high metabolic demand and so are susceptible to injury in HI. And then we did a similar method for GFAP, which stands for activated astrocytes. But instead of rat antibodies, we used rabbit antibodies, and we measured the optical luminosity values using a Nikon camera, and ImageJ software was used to calculate a mean and standard deviation. And then we used this equation to work out the OLV values, which we then used to plot a mean and standard error bar graph. So here are our results for alpha-M. So a high value means high activated microglia and low means low. And as you can see across the majority of brain groups, the HI and DMSO groups have the highest alpha-M scores, as they have HI but have not been treated. And the lowest groups are the sham and naive groups, as they don't have HI, so have little activated microglia. And as you can see across all the brain groups, all of our derivatives have reduced alpha-M score compared to HI and DMSO groups. And if you look at J147 high dose, which is like that little yellow bar, it's actually reduced the alpha-M score to that of sham and naive groups who have no HI induced, and this was statistically significant. And then for our GFAP, similarly, a high score means high astrocyte activation and low means low. And again, all of our groups have reduced it compared to the HI group. And if you look at total, which is average across all 6 brain groups, CNB001, low dose, gave the greatest reduction in GFAP score. However, if you look at each brain region individually, for the majority of them, J147 high dose created the greatest reduction in GFAP, which again is similar to our alpha-M results. And then for these results, that was an in vivo study in which we used DMSO as a solvent, because curcumin has low bioavailability. It's a hydrophobic compound, so we had to dissolve it in DMSO to be able to give it to our mice. However, DMSO is toxic to humans in small amounts, so we can't use it in neonates, which is why we had to move to using nanoparticles to give the same effect as DMSO, to provide the water solubility and the increased bioavailability, and to be able to give it to our human neonates. So we had this in vitro antioxidant assay to make sure that the nanoparticles still gave that antioxidant property. And we used DPPH, and we added our solutions to this, and we observed a color change from purple to yellow, and we measured the absorbance using a spectrometer, and then we plotted these two graphs. So we used ascorbic acid, which is a known strong antioxidant, as a comparator. And the graph on the left is the IC50, which is half the maximum inhibitory concentration. So a lower value means that it's a more potent antioxidant. And both of our CNB001 DPEG, that just means that it's the nanoformulation, and CNB001 alone means that it was the free form. Both of those have stronger antioxidant properties than ascorbic acid, and J147 has weaker antioxidant properties. And then the graph on the right, a percentage RSA, which is radical scavenging activity. And again, CNB001 has similar results to ascorbic acid and also shows increase in percentage RSA with increasing concentration. And for the majority of concentrations tested, the nanoformulation of CNB001 had a higher percentage RSA than the free form. And again, J147 shows weaker antioxidant properties than CNB001. So to discuss these results, our derivatives showed reduced microglial activation, and this might be due to their ability to inhibit pro-inflammatory stimuli. And we also saw that different brain regions had different responses to both of our derivatives, with some responding better to CNB001 and others responding better to J147. And this may be due to differences in absorption and metabolic demand of the different regions. And we also saw that J147 high dose was consistently more effective than the low dose, but for CNB001, there wasn't much of a difference between the two doses. And we hypothesized that this might be due to the fact that CNB001 reaches a plateau of effect in its concentration. Some limitations of this study is that, of course, we used a mice model to represent humans, but they differ in size, heart rate, and metabolic rate, and so have differences in injury response. And also, mice brains are not at the correct stage of white matter development as humans, so human neonates, it might not be the most accurate model, whereas a piglet model is more accurate, but they have stricter regulations in use and are more expensive. And also in our mice, we only induced HI unilaterally, whereas in humanates, it's bilateral, and we had quite a limited sample size. Although we used 16 mice per group, a lot of them were lost to human error, and HI brains were quite prone to damage. So in conclusion, our study agreed with the hypothesis that our derivatives would reduce astroglial and microglial activation, and there was significant reduction in most regions in both microglial and astrocyte activation. I think in future it'd be more useful to do a larger sample size and potentially move on to a piglet model, and to also test other nanoformulations that have smaller sizes and may be better at crossing the blood-brain barrier. Thank you for listening.
Excellent. Thanks, Anna. I think we have time for one quick question. Yeah.
Thank you for the question.
Can you repeat it for the online audience?
Oh, yes. I just wanted to ask you why you use alpha M as marker for microglia instead of something more specific.
From my understanding, alpha M is specific to mice antibodies, and since we were using mice brains, it was the primary antibody that we used, so it would bind specifically to the activated microglia in our mice cell. But I think it was specific to this study because of the type of mice that we were using. But yeah, thank you for your question.
Okay, excellent. Thanks, Anna. And thanks to all the speakers in the session. And thanks to Tanya and everyone for listening.
So we're just going to wait to be joined by the group from the other building, the other room, I should say. So 5 minutes really to chill out, go to the bathroom, etc. Thank you.
Okay, everybody, we're going to make a start. Well, good afternoon, everybody. It's great to see the room filling up again. We've had a great morning and we're about to continue into a wonderful afternoon. My name's Stuart Lavery. I'm the Divisional Clinical Director for Women's Health, and it's a real thrill for me to be here today and introduce our first keynote lecture. This is a lecture about endometriosis. the medical world does not have a great track record with endometriosis. For years, we haven't listened to patients tell us about their symptoms. It takes us years to diagnose endometriosis in patients. And then we have treatment that lacks an evidence base, and in some cases actually does more harm than good. So endometriosis is a field that's crying out for good research. It's desperate for evidence-based medicine, and it's in dire need of great medical leadership. And so it's a real thrill today for me to introduce Andrew Horne, who's professor in Edinburgh, where he runs the department there, the Centre for Reproductive Health. Andrew's main areas of interest are in pelvic pain and in endometriosis. Indeed, he's the president of the World Endometriosis Society. So I can think of nobody better to give us this lecture today, entitled Pioneering Non-Hormonal Strategies for Endometriosis, From Bench to Bedside. Andrew.
So thank you very much indeed for the introduction. It's a great pleasure to be here today and be part of this meeting. I've really enjoyed some of the talks that I've heard already this morning. As you've heard from Stuart, I'm a clinician and a researcher based in Edinburgh, and I have a long-standing interest in endometriosis. And I want to talk to you this morning a bit about some of the work that we've been doing, trying to develop new non-hormonal treatments to manage the condition. These are my potential conflicts of interest. So I understand this is quite a mixed audience here. So just to start, I thought I'd give you some key facts about endometriosis. I think the first thing to note, which I think always surprises people, is how common it is. It's as common as asthma and diabetes in women. And this equates to up to an estimated number of sufferers of around 190 million women worldwide. The primary symptom of endometriosis is pain, which can often be incredibly debilitating, but it's also associated with symptoms like infertility, GI and urinary symptoms, chronic fatigue and depression. As Stuart's already said, it's very difficult to diagnose, and this is largely because we don't have a non-invasive biomarker or test for endometriosis, and we often still rely on surgery. And this has contributed to this really quite unacceptable diagnostic delay of 70 years. Currently, there's no cure for endometriosis, and it's treated either by surgery to remove the lesions, and surgery is only successful in around 2/3 of patients and has high recurrence rates, anything up to 50% within 5 years. And the alternative for our patients are hormone treatments, largely hormones given to suppress the ovarian production of estrogen, because we know that this is an estrogen-dependent disease. But of course, these hormones are not fertility sparing. They carry with them a number of side effects, and they're only effective when they're being taken. So perhaps not surprisingly, endometriosis comes with a large socioeconomic cost, as estimated here at £8,300 per woman per year. These are costs that were estimated over 15 years ago, so are likely to be much higher now. And it has a significant impact upon the life course potential of patients affected. And I think now in 2025, we're moving away from thinking of endometriosis as purely a gynecological condition, because we are aware that it's a whole body condition, a systemic disease. It's progressive, it's associated with other gynecological comorbidities, and also puts patients at risk of other conditions, for example, different cancers and cardiovascular disease in later life. And I think it's hard to really understand the impact that endometriosis can have on a patient's life. This is a report that was published a year ago now by the Office of National Statistics, which looked at the impact on monthly pay and employee status in patients after a surgical diagnosis. It's perhaps not surprising that pay dropped in the 3 months following the diagnosis. They then seem to return to normal in the 4 to 12 months thereafter. But I think what's shocking is that beyond 12 months, monthly pay and probability of being in paid employment continue to decrease up to 5 years post-surgery. And the same month that report was produced, NCPOD produced its report, which of course combines data from multiple sources, clinical and organisational questionnaires, case notes, patient and clinician surveys. And the conclusion of this report was that only 17.3% of patients were satisfied with the results of their surgery for endometriosis. Just over 40% reported no improvement with hormonal medication, and nearly a third were being prescribed with opioids, which suggests that their current management for endometriosis pain is unsatisfactory. And just in August this year, we carried out a national survey of just over 1,300 individuals with endometriosis in the UK, and we asked them which hormonal medication helped most. And this is the word cloud derived from that survey. And you can see that despite the fact that there are multiple ways of giving hormones, none of them stands out. And if anything, as you can see, many patients were saying that none of them helped at all. And we concluded from this survey that current treatment leaves around 50% of patients with persistent or recurrent pain. So I think there's no doubt there's a need for novel, innovative approaches to treat endometriosis and also to try to predict response to current therapies. So in Edinburgh, we've set up what I'd call it like a research pipeline where 7 or 8 years ago now, we carried out a James Lind Alliance priority setting partnership to identify the research priorities most important to patients and clinicians. And we've used the information from that initiative to really drive our research over the last few years. We've established a large biobank of tissue samples from patients. We've looked more longitudinally at patient changes using wearable technology and home-collected samples. And we've established cell and animal models of endometriosis. And we've used a lot of these resources and models to try and take ideas from the laboratory both into early clinical trials and larger scale multi-center trials. And I'd like to talk to you just now about some of the work that's led to some of the earlier clinical trials shown here. So just a little bit of information about the human tissue resource we use. So any patient that comes to our service in Edinburgh with suspected endometriosis is invited to take part in research. And if they're undergoing surgery, we ask for their permission to collect biopsies of the lesions if they have disease, the peritoneum, brushings of the peritoneal mesothelial cells, and peritoneal fluid. We've established models. This is a very simple co-culture model, which we call our lesion in a dish. And essentially, we culture primary peritoneal mesothelial cells isolated from patients with and without endometriosis in conjunction with endometrial stromal cells. And then this allows us to add, for example, investigatory drugs to look at the impact upon the function of these two cell types. And then together with colleagues, we've established a mouse model of endometriosis. I'm sure many of you are aware that mice don't spontaneously develop endometriosis. They don't spontaneously menstruate. So my colleagues, first of all, developed a mouse model of menstruation. That's the donor mouse shown at the top. And then that menstrual tissue is injected into a recipient mouse. And these mice actually within about 7 to 10 days actually spontaneously develop endometriosis lesions, which look very similar in appearance to the lesions that we see in our patients. So with these models, we've carried out a body of work to try and better understand the commonest pelvic subtype of endometriosis, superficial peritoneal disease, which accounts for around 80% of the disease that we see. And the long-standing theory for the development of peritoneal endometriosis is around this idea that patients experience retrograde menstruation. But of course, we know that 80 to 90% of people who menstruate have retrograde menstruation. So why does endometriosis just develop in a proportion of them? And our interest has been in looking at changes in the peritoneal mesothelial cells and changes in the pelvic microenvironment that lead to endometriosis development. So we've demonstrated, first of all, that there are patient-specific changes within the peritoneal mesothelial cells. This is illustrated in this cartoon here. This is a body of work from one of my PhD students, Vicky Young. And essentially what she demonstrated was that there was an increase in the metabolic drivers of anaerobic glycolysis, both in the endometriosis lesions and the adjacent peritoneum. But importantly, what she demonstrated was that there was an increase in the production of lactate within the pelvis, and this is derived from the peritoneal mesothelial cells. And we know from studies in cancer that lactate is important for processes such as adhesion, invasion, and angiogenesis, which are all critical steps in the development of endometriosis. So we wondered if we could target lactate as a potential therapeutic for endometriosis. And we went down a drug repurposing route, identified a number of potential drugs, either in preclinical stage or in early phase studies. And we've been focusing on a drug called dichloroacetate, which has actually been used clinically, but only to treat rare metabolic disorders in children for a number of years. So the first thing that we did was that we introduced dichloroacetate into our lesion in a dish model, and we demonstrated that lactate could indeed reduce the production of lactate in the peritoneal mesothelial cells from our patients. And this in turn seemed to have an impact upon the ability of the endometrial stromal cells to proliferate, suggesting potentially in a very coarse way that it might have an impact upon the most important cell types of an endometriosis lesion. We then exposed our mice with endometriosis to dichloroacetate given by oral gavage or compared to vehicle control. And we were able to demonstrate that it reduced the burden of endometriosis, the volume of endometriosis in these mice. So this gave us enough preclinical data to take dichloroacetate into a clinical trial. This is a clinical trial called EPIC. And we started this clinical trial right in the midst of the COVID pandemic. So despite only wanting to recruit 30 women with endometriosis, it took us rather a lot longer, as you might imagine, to recruit to our target. So this was an open label, single arm exploratory trial. So you have to take that into account when you look at the results. Patients in this study were given a 12-week course of oral dichloroacetate. We looked at doses that had been given in other studies. They were started at a half dose and they were allowed to increase the dose after 6 weeks, depending on their response to treatment and depending on what side effects they had. We used patient-reported outcome measures in this study, so they were asked to complete pain scores and endometriosis-specific quality of life scores at the beginning and at the end of the study. Now, this study was really just an exploratory study. We really wanted to find out whether patients would be willing to take dichloroacetate, whether they would find it acceptable, and to look at their side effect profile. There weren't any serious adverse events, and only 3 of the patients just stopped the treatment due to the side effects, and I'll talk a little bit about these shortly. But although this study wasn't powered to look at efficacy of treatment, what really struck us was that pain scores in these patients were reduced. Their EHP30, the validated endometriosis quality of life scores, improved by about 50%. And I think what was most striking was that 2/3 of the patients in the study reported using less analgesia compared to at the beginning of the trial. So what about the side effects? Well, a number of patients reported this peripheral tingling in their fingers, which a lot of them said they didn't really care about as long as it had an impact upon their pain symptoms. But what we noticed was that this was related to the levels of DCA in the serum of these patients. And this is interesting because the enzyme that metabolizes DCA, GSTZ1, exists in 2 haplotypes, and these haplotypes dictate whether or not a patient is a fast or slow metabolizer of DCA. So we're currently about to start another trial. This is led by my colleague Lucy Whittaker in Edinburgh, and this time this is a double-blind, randomized controlled trial. We're going to be running it in a centre in London as well as a centre in Edinburgh. And the idea with this trial is that we'll genotype our patients in advance and decide what dose to give them with a view to trying to reduce the side effects experienced by patients. And again, in this study, the patients will take the treatment for 12 weeks. And again, our primary outcome measures will be patient-reported outcome tools. So we're also interested in how immune cells contribute to this change in the pelvic microenvironment, leading to the potential development of endometriosis, in particular macrophages. We know that macrophages are abundant in lesions and peritoneal fluid. We know they have roles in lesion growth, vascularization, and potentially are important in the development of pain symptoms. But what's most interesting about endometriosis macrophages is that they exist in a pro-repair rather than a pro-inflammatory phenotype, and they're very similar to tumour-associated macrophages. And I'm sure many of you are aware that there are multiple anti-cancer strategies in the process of being developed that involve macrophage repolarization. So we've been working with a group in California who've developed a drug called RRX-001. This is a drug that's been largely tested in head and neck cancer. And whilst it is able to repolarize macrophages, it's also interesting because it has differing activity in normoxic and hypoxic environments. So clearly that's an added advantage in the context of a condition like endometriosis. So we've exposed our endometriosis mice to RRX-001. On this slide here along the top, you can see the control mice, and then along the bottom, you can see that very quickly treatment with this drug again reduces the volume of the disease. And we also did some fairly basic pain-like behavior tests in these mice, and we showed that the treatment, as well as reducing the volume of the lesions, it also attenuates evoked pain-like responses. So again, we're just about to start another trial early next year. This is a much earlier phase clinical trial, more of a dose finding trial, but we will be looking at the impact upon pain and quality of life scores in patients in this study, as well as of course looking at acceptability of the treatment. Interestingly, this treatment's been used quite a lot in cancer trials, and the patients haven't reported any side effects with it. And I think it'll be interesting to see how patients like ours, who are obviously a younger, healthier population, respond to the treatment. The other thing about this treatment is it's quite a high burden treatment. It will involve patients coming up on a weekly basis over 6 weeks for a 2-hour infusion. So again, this will be something that we'll be looking at in the context of the trial. And then we're also interested in cannabinoids. You'll all be familiar with THC, which is the major psychoactive component of cannabis, but we're interested in cannabidiol, which works by different mechanisms, has been licensed for certain forms of childhood epilepsy. And the reason we became interested in it was one of my PhD students, as part of a national survey about food supplements and diet, found that nearly 1/3 of the patients with endometriosis who responded to this survey were using cannabinoids in some form or another to manage their painful symptoms. And around the same time as we did this study, there was a large review published which looked at cannabinoid treatments, and again concluded, similar to us, that these were being widely used, but noted this paucity in well-designed, robust studies to look at cannabinoids as a treatment for endometriosis. So again, we used a very similar approach. We looked for the receptors for the cannabinoids, in particular CB2, in both the human lesions and then in our mouse model, and demonstrated their presence there. And then we used the mouse model again and gave a CB2 agonist, which would be given to us by a drug company. This was a treatment, again, that we repurposed. It had been primarily developed for treating patients with rheumatoid arthritis, but had been dropped by the drug company at quite a late stage. Very sadly, despite getting some really interesting results, not only looking at the impact on the pain behaviors in these mice, but also on the burden of the disease, pretty much overnight, as often happens, the drug company withdrew its interest in women's health. So we then spent just about 18 months trying to identify an alternative. And what we're going to be using is a tincture, a cannabinoid tincture that's got a very low level of THC, so hopefully it won't have any of these adverse events within it. And we're going to be testing this again in a very similar design trial to our EPIC trial. So a randomized controlled trial in 2 centres of 100 patients, again using similar pain and quality of life outcome measures. And we're not the only people looking at cannabinoids. There are a lot of studies being run around the world at the moment, looking at them in the context of endometriosis. So I'm hopeful that we'll soon have an answer as to whether or not they're of benefit, and also whether or not they have any disease modifying potential. So just to finish with, I'd like to talk to you about sort of, I suppose it's like a pet project of mine. If any of you follow our work on social media, you may have heard about the Endo 1000 project. And this, we decided to set this up as it's a bit like a community research project. So it's an awareness raising, fundraising and research project. I'm pleased to say we've just reached our halfway target. We're aiming to raise £1 million to fund this project. We have a number of ambassadors shown here, some of the faces you may recognise, and they talk about the project and talk about endometriosis for us on social media. We run charity events. We even had a comedian doing some events for us in this summer's Edinburgh Festival. And Endo 1000's aim, as it might sound, is to recruit 1,000 people with endometriosis-associated symptoms and work with them really closely over a two-year period. We're going to get them to document their symptoms, their behaviours, any treatments they have, whether that's surgery, medical management, self-management strategies, any changes to their health on an Endo 1000 app. It was just launched on Monday. We're going to get them to wear smartwatches to measure their sleep patterns and their activity. And then we're going to get them to collect biological samples at various time points in their own home. So they'll be collecting saliva so that we can look at their genetics, blood so that we can look at their inflammatory profile, and urine and feces, and a vaginal swab so that we can look at their microbiome and their metabolome. And the idea is that once we've collected this information from this 1,000 cohorts, we'll use machine learning and AI to try and identify patterns which may help improve the diagnosis of endometriosis, but I think most importantly help us predict which patients respond best to the different medical, surgical and self-management strategies available to them. So where do I see the future of medical therapies in endometriosis? Well, I still think there's obviously going to be a role for pain management, but I'm hoping that opioids will be replaced by drugs like the cannabinoids. There's always going to be a place for hormone treatments in particular because of the fluctuation in symptoms that patients experience in response to estrogen. I hope that we'll see some disease modifying drugs, for example, like our drug, like dichloroacetate. Immunotherapy as a potential treatment. There's a lot of discussion about why endometriosis isn't classified as a cancer and treated in that way. But I think what will be most important is that if we can identify a way of delivering a precision medicine-based approach to predetermine the best treatments for our patients moving forward in the future. So I'll just like to finish there by acknowledging my team in Edinburgh, my collaborators, funders, and the patient organisations who support us with our work. And thank you very much for listening.
Thank you very much, Andrew, for a really great scope and the breadth of the work that you're doing. We do have some time for questions from the audience.
Hello, very nice talk and very important topic. One question about the lactates. Have you seen cyclical variations of lactate levels matching with the cell cycle that could explain the changes with pain?
So from the patient samples, we collected them all, or we compared them all in terms of cycle stage. But we didn't actually see any changes across the menstrual cycles. Obviously, we couldn't predetermine when we would collect them from the patients at the time of surgery, but we were able to do that retrospectively.
So what do you think is the mechanism that, how does the drug affect the pain?
Yeah, we know it, we did do some work and we know that TGF-beta is the main driver, and we did think about targeting TGF-beta, but it's a bit like taking a hammer to the problem, I think. But we've largely now focused, our efforts on moving towards a treatment rather than looking at the underlying mechanism.
Thank you.
Great talk, Andrew. I know you mentioned at the beginning of your talk that there's no early non-invasive screen for endometriosis, but a couple of groups, well, more than a couple of groups, are looking at microRNAs from saliva in order to screen or as an early biomarker of endometriosis. And surprisingly, there's now a company called Ziwig that is funded by the French government, reimbursed fully by the French government, published a clinical validation study and a CE-IVD, I think, or close to being a CE-IVD test. What's your comment on that?
Yeah, so I mean, I'm sure you're aware it's quite controversial at the moment, and it's caused quite an uproar in France because there's a lot of political drive around it. I think it's quite interesting because they marketed the test way before they published their validation cohort about 2 weeks ago. And there was a lot of unease kind of in the community about it because nobody had seen it being validated, and yet patients were being charged €1,000 for the test. The validation paper is actually very good. I think you can't really criticize it. And so I am hopeful that as a test it will be useful. I think what you do have to bear in mind, though, it's always going to be expensive because they're looking for over 100 microRNAs. It's restricted in that patients have to go to their gynecologist, they have to sit and wait for half an hour because there are things like if a patient's wearing lipstick or chewing gum or whatever, that affects the results of the test. And then the test has to be taken in the gynecologist, it then has to be sent to the company. So it's not really a kind of simple point of care test. There is another group in Canada who've got a microRNA blood test, which is probably a bit more practical, if you like. And they're currently validating in a multi-center study at the moment. So I think, I don't know whether the Ziwig test will be the be-all and end-all test that we're looking for, but there's definitely, a move forward to developing a test. I think we'll definitely see a test that's potentially used in the NHS in the next 5 or 10 years.
Hi, thank you very much for that fantastic talk. I'm Vola Grace. I'm an honorary professor of practice here at the Institute. There's a paper from you and your team that I cite a lot on kind of digital health technologies and digital ecosystems. I think it was in Cell Molecule. And I remember a couple of years ago, I gave a talk here at this event on the application of digital health technologies. And someone here asked a question that I cite a lot around some of the unintended consequences. So for endometriosis, it means it's constantly in your face and it affects mental health because women are constantly seeing the results. I wonder if you can speak to some of the impact of digital health technologies in this area, whether positive or negative. Thank you.
Yeah, I mean, I think, so we've certainly found them as a useful tool for collecting data through apps. I think that's very useful. The wearable technologies useful because we for example had patients wearing them where we've been able to identify patterns on the smartwatch, which will then predict whether or not a patient's going on to have a flare. So useful in that respect. Interestingly, the smartwatch that we have doesn't give any feedback to the patient, so that I think it doesn't then kind of stimulate, you know, or kind of traumatize them in terms of constantly reminding them about their endometriosis. So I think it's good and bad, isn't it? I think, yeah.
Hi, great talk, thank you. So my question is really from the cancer side, with endometriosis being a risk factor for clear cell and then endometrioid ovarian cancer, whether in your Endo 1000 project you could be linking the data and have prospective data, because you will have really rich biospecimen data and demographics, and then in a way looking at the longer term outcomes, in a way which people or which individuals would be at risk of developing those, as one question. And then the second question is about the RRX 001 and whether there, if you went to, after the dose finding, to the next stage, whether data on longer term outcomes for ovarian cancer could be captured in the future.
Yeah, so a really important question. So I think the first thing we always say to patients about the risk of ovarian cancer is, because obviously the prevalence is still low in the general population, even though the risk is increased in endometriosis, it's still not increased sufficiently to warrant any increased monitoring. I think the other thing is it's ovarian disease which carries the increased risk, which is obviously less common than peritoneal disease. But you're absolutely right. One of the things that will get permission for this 1000 is to be able to link to their data and to follow them up at long term. So we've asked them all for permission to contact them again at a later stage, because I think it'll be a really useful resource. And then we haven't thought yet as far about the design of our next RRX 001 study, but yeah, that's a very good point, and we should definitely do some longer term follow up with them.
Well, we hope Andrew will be staying with us for lunch. So anybody else who has any burning questions, please interrupt his lunch. But please join me in thanking him for a wonderful presentation.
So we're now going to move on to our Medical Student Prize talk session. That's going to be chaired by Melissa Whitten. Thank you, Melissa. Just a reminder that immediately after this, we're going to move out into the corridor and we're all going to stand on the stairs and have a photograph taken. So no dashing off to get an early lunch, please, because we want to get your mug shots showing what a fantastic turnout this is. Melissa, over to you.
Thank you very much, Anna. So just to sort of introduce the Medical Student Prize. So we have a number of medical students who submitted papers for the meeting today, and we're really lucky within the Institute that we have students at all different years of the medical school curriculum. So there are lots of preclinical students in their first couple of years who do projects aligned with areas of women's health. And then in the third year, we have an IBSE program where students spend a year working together with us in the Institute. And lots of you have been involved in supporting and supervising a wide range of projects over the years and been involved in the teaching of our IBSE group. And then we're lucky enough for our internal UCL students that they come back to us again in the fifth year. And in their fifth year, they do their clinical placements. And some go on to do their electives and kind of final year placements with us as well. So we've got a whole range of students who have undertaken pieces of work relating to women's health. And the students abstracts get judged anonymously to identify the kind of highest scoring abstract, and the highest scoring person is invited to give an oral presentation. And then there's a number of other presentations that you'll see in the poster displays after lunch. So I'm really delighted to welcome Ria up to the stage. So Ria's done a piece of work around understanding patient perceptions of genetic testing relating to diabetes. And this is a piece of work that's been carried out in conjunction with colleagues within the Institute, supervised by Julia Zollner, who's sitting here at the front. And I'm sure we'll all be really pleased and excited to hear Ria's presentation, and so welcome her to the stage. Thank you very much, Ria.
Good morning, everyone. My name is Ria. I'm a final year medical student at UCL, and I'm delighted to be here today presenting this work with Dr. Julia Zollner, Understanding Patient Perceptions of Genetic Testing to Predict Type 2 Diabetes Risk After Gestational Diabetes. So to begin with some background, we know that in the UK, the prevalence of gestational diabetes has been found to be around 10 to 20%. Of these women, estimates suggest that up to 70% will go on to develop type 2 diabetes within 10 years postpartum. However, advances in genomics have made it possible to assess an individual's genetic risk of progression to type 2 diabetes, and this complements existing risk scores. However, little is known about women's perceptions of this genetic testing, including whether they would want to test, what their concerns may be surrounding this testing, and whether knowing their genetic risk would have any influence on their lifestyle choices to try and prevent progression to type 2 diabetes. As a result, we set out to understand the following. Understand women's willingness to undergo genetic and non-genetic testing for this, to examine associations between attitudes towards genetic testing, demographic factors, and women's willingness to test, to assess their motivation to modify their lifestyle based on this information, and finally to identify key concerns related to the collection and use of this genetic data. So how did we go about doing this? We disseminated a survey to women in the UK with current or previous experience of gestational diabetes. The channels that we used for dissemination included Gestational Diabetes UK, Diabetes UK, and the Diabetes Research and Wellness Foundation, amongst others. We collected responses from the 1st of April this year to the 16th of September. So moving on to our respondent demographics, we received 112 complete responses. The average age of our participants was 37, and this ranged from 23 to 63. The majority, 49.1%, were white or white British, and just over half had current gestational diabetes, with the remainder having had previous gestational diabetes. Thinking about their education, 39.8% had a master's degree. Just under half had previous experience of research, and just under a third had previous experience of prenatal testing. So moving on to some of our results, thinking about our first aim, which was exploring women's willingness to undergo testing. We asked our respondents how willing they'd be to take a non-genetics-based test to understand their risk of type 2 diabetes, and the vast majority, 90.2%, said that they were willing. We then asked about their willingness to take a genetics-based test, and again, the majority, 83.9%, said they would be willing to take this test. Importantly, there was no significant difference between women's willingness to take either type of test. We also asked our participants to what extent they agree or disagree that genetic testing to assess future risk of type 2 diabetes should be available on the NHS. And here the majority, 58%, strongly agreed with this, with only one participant strongly disagreeing. Moving on to our second aim, exploring attitudes towards testing. We calculated our participant attitude scores using the GAD-7, which is a validated survey tool to assess attitudes towards genetic testing. The mean score was 16.85 out of a possible 20, where higher scores indicate more positive attitudes. So on the whole, attitudes were fairly positive. We saw significantly higher attitude scores were associated with greater willingness to undergo this genetic testing and greater agreement that this testing should be available in the NHS. Importantly, attitude scores were not significantly associated with any of the demographics data that we collected. Moving on to aim 3, assessing motivation to modify lifestyle behaviours. We asked participants the broad question of would knowing their risk influence their lifestyle? As you can see, 56.2% answered yes, definitely, 36.6% answered yes, probably, and around 8% indicated that they were not sure or that it wouldn't impact their lifestyle. Importantly, age was significantly associated with lifestyle motivation, where our younger participants were significantly more likely to indicate that they would change their lifestyle. We then asked about specific lifestyle changes, so taking medications to prevent diabetes, exercising regularly, and eating a healthy, balanced diet. And broadly, our respondents were more likely to answer that they would be motivated to exercise and change their diet. Interestingly, both of these measures were associated with education, where respondents with higher levels of formal education were more likely to indicate that they would make these changes surrounding exercise and diet. We then compared these specific lifestyle changes. So our participants were significantly more motivated to eat a healthy, balanced diet than to take preventative medications. However, they were significantly more motivated to take medications than to exercise regularly. On the whole, there was no significant difference between exercise and diet. And that brings me on to our final aim, to identify key concerns related to the collection and use of genetic data. We asked our participants to indicate how concerned they would be about the variables on this bar chart and use this to calculate an average concern score. The average score was 9.15 out of a possible 24, where higher scores indicated greater concern, so on the whole, concerns were fairly low. As you can see, participants were least concerned about their ethnicity being identified from the data and the data being used for research. And on the opposite end, they were most concerned about their identity being worked out and their privacy being compromised. So in order to greater understand our participants' concerns, we also collected free text responses and analysed these thematically. The first theme that arose was concerns around health insurance and discrimination. One participant indicated that she was worried about any potential implications for her life, travel, and health insurance, and quite a few participants did mention health insurance in the responses. Someone else worried that it could be used against them by the NHS in terms of limiting their options to other treatments. Another theme that arose was the usefulness of the information and the impact of knowing the risk. One participant expressed that if there was nothing they could do with the information to influence their chance of progression, then they wouldn't want to do the test. Another theme was the accuracy and interpretation of the results, with some worrying that it may be inaccurate or that they might feel pressure to change their lifestyle over something that might not happen. And the final theme was emotional and psychological burden of undergoing this testing. Lots of participants mentioned health anxiety, and one participant expressed that they would prefer not to undergo the testing during pregnancy due to the emotional impact and would prefer to test after pregnancy. So that brings me on to the discussion. What were the strengths and limitations of this work? To our knowledge, this is the largest study to date looking at patient perceptions of genetic testing to assess future risk of type 2 diabetes following gestational diabetes. However, we had a fairly small sample size of 112 and a predominantly white and well-educated sample. As a result, future work should engage with larger, more socioeconomically diverse samples, and further qualitative research through interviews and focus groups that could help better understand participants' concerns. So these results shine a light on participants' willingness, attitudes, lifestyle change motivation, and concerns surrounding this genetic testing. We saw that positive attitudes were associated with willingness to undergo the testing and support for its availability on the NHS. Importantly, younger participants and those with higher levels of education showed greater motivation for lifestyle change, so we could see the impact of socio-demographic characteristics. On the whole, participants demonstrated high willingness to undergo genetic risk testing, positive attitudes towards genetic research, and generally low concerns around data use. However, the free text responses illustrated concerns around insurance, actionability and accuracy of results, and the timing of testing. As a result, future programs should adopt inclusive approaches for equitable engagement with these programs. Information should be accessible, clear, and emphasize the actionability of results. And concerns around data use and collection should be explicitly addressed in order to build public trust with these programs. I'd like to thank Dr. Julia Zollner for all her support with this work, as well as our co-authors and collaborators, and thank you all very much for listening.
Thank you very much, Ria, for that wonderful presentation. I think we have got time for one question from the audience. Demetrios. No surprise. Demetrios, over to you.
UCLH has patients who are very educated, but we have good demographics. So why were your participants mostly white? Were they not approached, or were they approached and they declined to participate? Thank you.
Yeah, so I think it's the difficulty with disseminating a survey. That's the general trend that we find with participants. Other research projects that I've done within the area, I've had the same issue of predominantly attracting white British respondents. Something that we did try to do to address this was Dr. Zollner contacted, I believe it was an Afro-Caribbean network, and conducted focus groups with their members to try and understand their concerns. And on the whole, I believe she found, although she can correct me if I'm wrong, she found that their responses were very similar to what we'd found with our survey. But I think it is a problem with survey-based research that we can't necessarily engage everyone.
Thank you, Dimitri, for the question. Julia has just whispered about the benefits of opportunistic involvement in research as a student. So you and Ria were on the 5th year placement and kind of got involved in this piece of research program off the back of a conversation over a C-section. Yeah. Which is just shows you never know what the outcome of your kind of different clinical placements might be, but it's really great that you've been able to do this piece of work together with Julia and a number of our resident doctors at UCLH. I should also mention that we have another Julia, who's one of our BSc students, who also submitted under this bracket and scored a really good mark, and has a lovely poster presentation that we wanted to signpost on a related area to do with diabetes and genetics. So have a look for that in the poster room. But for now, I think thank you very much, Ria. Well done. Good luck with final.
Thank you very much. So fantastic, Ria. I'm so impressed from medical students. Wonderful. Just a reminder, in the breakout session, in the poster session, we have 2 screenings of an ethnographic film, From Purity to Power, Rethinking Wellness in a Time of Unrest. So we're showing from Lucy Neeland, who's a business anthropologist at Ipsos Centre of Ethnography. And she's showing 2 screenings in the Woburn Suite at 1:30 and 2:00. But we're now going to go out to our photo, and then we'll be having lunch, and we're back here at 2:30. Thank you. So welcome back, everybody. Welcome back after the lunch break. I'm delighted to see so many of you back. I hope you're able to have a look around the posters, go to the film over the session, and we've got a real treat in for you this afternoon. So I was just reminiscing with Richard, because I worked with Richard many, many years ago at the Veterinary College when I was still a very junior research fellow. And these crazy things happen. I was working at the Veterinary College and I was doing some work on a PhD in fetal gene therapy doing sheep. And Richard was next door doing uterine transplants on rabbits. And I remember I said to him, because I was doing scanning, I had a really ancient scan machine that we'd actually inherited from the fetal medicine unit after it had been disbanded because it was so old. So I said to him, well, why don't you scan these rabbits to see whether the uterine transplantation has worked and there's normal uterine artery blood flow? And he went, oh, that's a good idea. So we did. And we also diagnosed a pregnancy, didn't we? We also diagnosed a pregnancy after rabbit uterine transplants. We were just reminiscing about that. So it's my absolute pleasure to introduce Richard. So it's not just Richard, it's a whole team of people who've worked on this. So Professor Richard Smith is at Imperial College London, and he's here with Isabel Quiroga, consultant surgeon at the Oxford Transplant Centre and the clinical lead for organ retrieval. And they're going to talk to you about their journey in uterine transplantation in the UK. I'm going to remind Richard as well of another thing that I remember, which was when you had a fundraiser many, many years ago, probably the early 2000s, when you turned up in your kilt and you played the bagpipes. You've forgotten that, haven't you? You have, yes. Thank you. A warm welcome for Richard and Isabel. Thank you.
So thank you very much for those kind words and brilliant reminiscences, actually. What we're going to do in the next 20, 25 minutes is, between Isabel and myself, we're going to tell you a 25-year story. It's actually more like 27 years now, of how this project evolved. So let me just help if I put my glasses on, see what I'm doing here. Have I got any conflict of interest? I'm the chairman of Womb Transplant UK, and that's the charity that pays for the transplants and is due to pay for 10 deceased and 5 living donor transplants. And it is a conflict of interest, which is only made right by our multidisciplinary team meeting. I'm also a founding member of the International Society of Uterine Transplant. So I think the most important thing about this project, and actually what Anna's just said to you kind of epitomizes the whole thing: collaboration, collaboration, collaboration. Over the years, we have never said no to all bar one person to come and collaborate with us. And you can see from this slide, it's Oxford University Hospitals, Imperial list of fertility. There's the charity, there's the Human Tissue Authority, there's NHS Blood and Transplant, there's Royal Veterinary College, Universitat Politecnica de Valencia, also veterinary, University of Bristol, Surgical Innovation, Cardiff Law, Lancaster University Law and Ethics, and Stevens Group Tissue Engineering. So it's a huge group of people. What's kept us going over that time is compassion, compassion, compassion. This project has been about the relief of suffering for women suffering from absolute uterine factor infertility. And it's got to be really clear with everybody. We're not about transplanting uteruses. That's not the goal. The goal is the creation of babies. That's the vital bit of this. So it's different from any other transplant. From the time of the transplant to success is somewhere between 18 months and 2.5 years. Really important to say, this is a mix of surgical skills. So I'm a cancer surgeon by training and by practice, so follow Halstedian principles of removing organs with a centimetre of normal tissue around them, sealing the vessels. That is absolutely not what transplant surgeons want. Isabel is a renal pancreatic transplant surgeon, and when we're operating together, it's very much a joint process. I'll say seal a vessel, she'll say tie the vessel. And for the retrievals, it's me that leads that, assisted by Isabel. For the implantations, Isabel's the lead surgeon, assisted by me. And it's a real genuine mix of surgical skills here, which is partly how we've come to evolve from 2 separate teams into one highly coordinated team. So what's the size of the problem? There's all sorts of figures bandied around. 50,000 women in the UK with absolute uterine factor infertility, probably more like 15,000 in reproductive age. 100 to 200 women a year go down the route of surrogacy. Mayer-Rokitansky-Kuster-Hauser syndrome is that syndrome where a woman is born without a uterus, without a cervix. They almost all in our experience now have normal ovaries, fallopian tubes, and they have variable sized vaginas. It's an interesting comment made recently by the first woman who went through, which was that when she got her diagnosis, age 16, she had no hope. And she said, now this project and her baby has delivered hope to any young woman who gets that diagnosis today. We've also got hysterectomy related to hemorrhage, hysterectomy related to cancer, cervical, uterine sarcomas, gestational trophoblastic disease, and endometrial cancer. Cervical cancer has been intrinsically wrapped up with this project because our understanding of vasculature allowed us to develop abdominal radical trachelectomy. And gestational trophoblastic disease, which is cancers of the placenta, as you all know, is a subject certainly close to my heart because I was the lead surgeon for the unit at Charing Cross, the national unit, for the last 30 years. And we developed a fertility sparing procedure for women with placental site tumours, so they kept their uterus. Again, a direct side effect of this project. And then there's benign conditions as shown there. So what are your options if you're a woman who's got absolute uterine factor infertility? You can do surrogacy, you can do adoption, and now you may be able to do uterine transplant. Surrogacy has the advantage of low physical risk, a good outcome. Adoption, good low physical risk, opportunity for a stable home for a disadvantaged child. Uterine transplant, you get to carry your own baby. That's very important for some women. There are no legal issues. Most ethicists prefer transplant to surrogacy, and it's the only way you can gestate. But each of these three things have got big problems. Surrogacy, religious issues. If you're Orthodox Jewish or Muslim, you're not doing it. There's legal issues to do with adoption. So the surrogate obviously delivers the baby and then the genetic parents adopt, which creates anxiety. That's one of the emotional issues. The other emotional issues are around what the surrogate's eating, drinking, smoking during pregnancy. And it's totally country dependent. Across Europe, it varies from one place to another. Adoption is a lengthy process, legal issues obviously, and the child, depending on age of adoption, may have difficulty adjusting. Uterine transplant, make no mistakes, this is big surgery to implant the graft. You're on immunosuppressive therapy with all its risks for somewhere between probably 3 and 5 years, and then there's further surgery to remove the graft. So it's a big deal. Who's eligible? Well, you've got to have absolute uterine factor infertility. And I know in this room there'll be people who may refer to us that you've got to have embryos already created by IVF from your own eggs in cold storage. You've got to have 5 of them pre-implantation genetic tested. You've got to be between 24 and 42. You must have no intercurrent medical condition. If you've had cancer, depends which cancer, you've got to be 5 years in remission, and you must not have a high BMI. Now, I want you just to look at that, because every other transplant patient who's having heart, lungs, kidney, liver, etc., are all sick patients, right? Our patients are absolutely the opposite. They're totally fit, healthy people. And Isabel will talk about this later, but that's given us all manner of troubles that we never actually dreamt of. We're not dealing with people used to being patients. So in the UK, we went from small animals to human trials. This is Moore's criteria for surgical innovation. The animal research Anna's just referred to, and we had the 3rd pregnancy in the world in a rabbit, in an animal, which was in that rabbit. We then did surveys, that was SASO, looking at the public, patients, healthcare workers, etc. Showed generally people were quite in for this. 2015, first successful ethics application. 2019, we'd taken so long to get through stuff I'll show you in a minute that we had to go back to ethics. 2020, we were good to go. COVID, so we're shut down. 2022, we did a deceased donor explant. 2023, we did Britain's first living donor transplant. So that deceased donor, unfortunately, there were blocked vessels and we couldn't implant. So if you look worldwide, 135 plus cases, 2/3 are living, 1/3 deceased, 65 births, mostly, do we say, to living donors. The original operating time for retrieval was 10 to 13 hours. That shrunk by a new technique, which ironically looked very like trachelectomy, and I never saw it. We're down to sort of 6 to 8 hours for retrieval time, which is why we then got into living donors as well as deceased. So there just shows you that timeline. 2015 ethics, Ben Jones and Isabel. 2017, we were going through specialist nurses, ITU consultants, British Transplant Society, the College, Human Tissue Authority, the NHSBT, National Advisory Group. 2019, Rutger Ploy, professor in Oxford, and I were having a gin and tonic at the end of a meeting, and he said, you guys have been made to jump through way too many hurdles. And we got sign-off soon after. We went live 2020, and here we are now. The patient pathway, recruitment, medical psychological assessment, 5 embryos, you get on the list, immunosuppressive therapy all the way through, 6 months or more observation till you get the embryo transfer, C-section, and then 1 baby or a hysterectomy. Just pay credit. Obviously, Isabel, Andrea Devani did all the paperwork in Oxford. Baroness Cox, our patron, Nick Mon and Nadine Caneva, patrons who've supported us very heavily, and Neil Hubbard, John Harrison, Laurent Chaminade, public relations and publishing. So our in situ study is 10 women undergoing deceased donor transplant. The living donor program is 5 cases, and this is funded by Women Transplant UK, and we are one of the few units in the world with a living and deceased donor program. So there we go, February 23 to February 25, first living donor case, first live birth 25, and we've done 5 cases in total. all touch wood, surgically successful. 2 living donor, 1 live birth, 1 recently performed. We hope she'll be pregnant quite soon. And 3 using deceased donors. We're hoping that things are going to go well on that front in the very near future. This was the first case. A lot of publicity, huge public relations issues. I want you to just pay attention to 2 things in this slide. This was the biggest hurdle I've personally ever been at, right, before an operation. And at the bottom there, you can see the top of a huge pile of food, which we all brought, which over the following 23 hours was eaten. It has to be said, the last time we did this, time was down to 11 hours. There's the core surgical team. 2 of us here today. The others, some of you will definitely recognise. Post-op, just checking my time, yep. Week 1, scariest week of my career, because we know 20-25% failure rate with this stuff. Week 2, patient, I should say in week 1, we had a few things going on which demonstrated there's different aspects of how we see surgery. Week 2, though, woman had a period, she had a second biopsy. Very high chances then that she would go on to have a baby, but Ben Jones and I were cock-a-hoop. Isabel said, you guys are way too premature on this, and she was totally right, We've had a lot of stress. The embryo transfer followed, and of course, what you then got was baby Amy Isabel. Amy after the sister who donated, Isabel named after Isabel here, not the Scottish spelling, it's the Spanish spelling, Isabel, and that is Bryony Jones, obstetrician, who conducted that delivery. There is the family. This is Grace on the left, Amy over here, Amy Isabel, and Angus the dad. And I love this quote to finish with: success is not final, failure is not fatal. It is the courage to continue that counts. I feel very blessed to have been surrounded by a courageous team and with this wonderful, courageous surgical colleague, Isabel Quiroga. I'm going to hand over to her and try to avoid falling off the podium, actually.
Thank you, Richard, and thank you all. I mean, this is a fabulous audience, and he's never kept to time, so I hope that I won't talk too long. But I just want to take you to the beginning of giving you a bit of a history of transplantation, because we've been doing solid organ transplants for 70 years now. We did the first, somebody did the first transplant, kidney transplant in 1954. And then there's a big gap until another organ, another life-saving organ is also transplanted, and is 12 years later is a pancreas and a kidney transplant. The pancreas is just for the treatment of really difficult to manage diabetes in the context of renal failure. And then there starts a flurry of other life-saving organs that have been done. The liver in 67, the kidney, the heart, world famous, the pancreas alone, and a lung. And then there is a gap in which we ran out of organs to transplant until somebody does a hand transplant. And that was quite innovative, and it was very criticized, because this is not a life-saving, but however, it's a life-enhancing transplant. And when they did a next transplant, a face transplant, now it's not only life-saving, it's not life-saving, it's life-enhancing, but it's also life-transforming. And when we come to 2014, with the first successful uterus transplant, now we see life-enhancing, life-transforming, but it's now life-creating, which is truly amazing, isn't it? So with any transplant, once that the really pioneers and once that they've done a few transplants, it takes a long, long time for us, 10, 15 years, for people to develop the surgical techniques and to figure out how to manage patients. And if I just take you to the origins, for instance, of, let's see if this works. Does it work? Yeah. So in the pancreas, they have been doing transplants for ages. No, it's not working. They've been doing transplant for ages. And despite that, only 150 transplants have been done after 10 or 15 years after the first transplant. It takes a very, very long time until the procedure is taken up like it is now. So
just to give you a bit of background, we do about 160,000 solid organ transplants every year, and to which we contribute moderately to about 3,500 or 3,700 cases per year, out of which come from 1,500 donors. So when we go to think about how we've only done 135 transplants, you can see that we are not here, but even here in this graph, we are at a very, very embryonic stage of the whole process. So what is the surgical technique for a uterus transplant? This is the donor, and in the procedure, Richard and his team the important thing is to get nice length of uterine vessels to the anterior division of the internal iliacs. And important is that we always leave the ovaries behind. So at no point does anybody can say that the donor was genetically related to an offspring after the transplant. And of course, a cuff of vagina. Then we end up with this graph with hopefully nice vessels. And the transplant operation itself is similar to the techniques of a kidney transplant. We anastomose the vessels to the external iliacs, but this is times 2, of course. And the patient will have their own ovaries, and then Richard does his lovely vaginal anastomosis. So how did I get involved in all this? I'm just a normal transplant surgeon. And some years ago, it's now more than 10 years ago, a colleague of mine says, there's this guy this gynecologist from London who's come to get some advice, and he's planning on doing a first uterus transplant in the UK. And to which I raised my eyebrows and thinking, what? He's going to do what? I mean, I really did not understand. And I was thinking, and he was, so we were planning on doing a disease. So he needed a bit of help on how to get to the disease world and to the world of donation. So somebody said, just go and meet him and you will see, give him a hand and just tell him what to do. So anyway, I wasn't very keen, but I went along. I met him. I invited him to the masterclass that we organized nationally, and he was very nice, and his team was very nice. He's still not convinced, and it wasn't until I met the first patient, not the first patient that had the transplant, but the first person I met that needed that transplant, that instantaneously I understood just what her telling us. How she felt, that I just thought, I need to be part of this. I was totally sold to this idea. And what it started as an advisory role, it evolved, and now we are a big team. And as Richard is saying, we do the transplants in Oxford, the IVF and obstetrics are in London, and the follow-up is between the 2 institutions. And this has been our major headache, how to get about to convince everyone that this was a thing worth while doing. So the Human Tissue Authority, the governance, the ones that just keep the regulators of transplantation. So we had to have a new license for all the activities in transplantation. They had to come and inspect us. Then NHS Blood and Transplant are the ones that manage everything about transplantation and the disease world. And we went to millions of meetings, but the main concern is, will this transplant have a negative impact on the life-saving transplants? And then, of course, my institution, you all work in hospitals. We went through not millions, but almost hundreds. It felt like millions of hours of dedicated to meeting with people, and everybody wanted to have a say. And NHS England also gave us their approval. So as frustrating as this was, I understand it, because for instance, in a kidney transplant, some years ago when I was training, or even later, the immediate graft failure due to thrombosis was we quoted about 10%. Now we quote a 1%. In the uterus world, the literature would say that a living donor failure, immediate failure, is 20%, and a decease is 25%. So I hope that as time goes by, that will drop, but still probably not to 1%. And as Richard is saying, this is not a life-saving operation, not life-saving transplant. The women that we deal with are very young. They are desperate to have a family. They are desperate for their dreams. And to make them understand risk is very difficult. So the consent process, we feel, is paramount. And for that, we also need psychological support. And everybody understands the risks of surgery. However, the risk of immunosuppression, when we tell somebody that we will increase the risk of having cancer and infection, that's difficult to comprehend onto that could happen to them. And of course, the medication has some side effects, mainly renal dysfunction, diabetes and hypertension, as well as bone marrow suppression. The pathway is quite straightforward. Richard sees them, then we do loads of investigations, psychological evaluations, plus then being seen in Oxford and having their IVF funded by the patient or by the health authorities now, if they're lucky. And everybody that has a living donor has to go through the process of an independent assessor by the Human Tissue Authority, and then they are listed. Once that they have, they're listed, they will have the transplant in Oxford, there's immunosuppression modification, followed by the embryo transfer, cesarean section, and hysterectomy. So we did the first transplant, as Richard mentioned, in February. That transplant was done on a Sunday. At no point we wanted anybody to say we missed out on my cancer operation or my hip surgery was postponed. So it was everybody that was around there did it for pro bono, and there was about 30 people in on that day, plus others coming and wishing us good luck. And yes, it was very, very challenging surgery, as Richard saying, many, many hours around the operating table, but we have a fantastic outcome. This is us all very happy after many, many hours of surgery. And these are the final group with nurses and anaesthetists. And how to measure success is very difficult. With a kidney transplant, you do blood tests and you know whether the kidney is working or not. Here, you only have blood flow to check viability. You monitor rejection with biopsies, and the function is given by the regular periods. But of course, the aim is to have a baby. And a baby we had. That was one of the most important moments of our career, certainly the most emotional. And the experience so far for us, that was the birth of the first baby. And for me as a transplant surgeon, it's been a marvelous experience, of course. And I've gone full circle. And the whole operation, the whole experience has given the reassurance to those that were already in the program that we can do it. More people have come forward and wanted to have a transplant, but impressively, I think, hundreds of British women had contacted us just offering their uterus and wanting to give that gift of life, in a way, to other women. And for me, yes, I think that this is the right option for some, not all, but for some women. And there's still skeptics, I'm sure, and maybe among this audience there will be some skeptics, but you better than anybody know that women make very difficult choices all the time. They risk their lives, their livelihoods, their health for that pursuit of motherhood. And with the transplants, we are now giving the opportunity to some. We have given hope to many, but we also given the choices to those that wish to come along with us in this journey. So, and this is a massive team effort, and this thing is supposed to just roll like the credits of a movie. It takes ages. Many. You may recognize some people in maybe in this audience, maybe, but people that you know and you've worked with before. So, thank you very much. There's still more people coming, and we also we are extremely grateful. And probably the greatest effort has come from the charity, because they are funding the whole project for now. And then we also written a book to support the charity. And anyway, we are ready now to answer your questions. Thank you very much.
Wow, fantastic to hear that story. A long journey. It gives me hope that I may get there with developing a treatment for fetal growth restriction, which I think started in 2005. So I've got a few more years to go yet, but fantastic. Thank you. Any questions? Yes, we've got one here.
Fascinating. For the IVF cycle, is it a prerequisite to have genetic testing for the embryos that are being transferred?
Yeah, the ethics committee stipulated PGATA tested embryos, and 5 is the rule, and certainly within the deceased donors study, that's absolutely fixed.
Irrespective of the age of the biological
Yeah,
mother.
I mean, we know there's a lot of dispute around this, and it was what was put in, and I have to say I've certainly personally questioned it in the younger patients, but for the time being, it is there. And I know it's not that straightforward, all right?
Thank you for a really inspirational talk. It wasn't clear to me from your images whether you were transplanting the fallopian tubes with the uterus. And that leads to the following point. Is anybody going to get pregnant naturally following this?
Yeah, so the tubes come out from the donor, but are not. We take them off. We just use them to move the uterus around, and then we take them off once the uterus is implanted and transplanted. But the fascinating thing that we've been looking at is all these women have beautiful, I'm talking the recipients with Mara Kotanski of it, lovely, beautiful fallopian tubes. And I'm of a generation that, dare I say it, I used to cut out Alka Clemens clips and reverse sterilizations. And we have looked at those and wondered, could we actually just anastomose the tubes onto the uterus? So I think to transplant the tubes, not so smart because of all the vessels, that palisade, but actually tubal anastomosis, maybe. It's something we're actually thinking to look at.
So as somebody who runs a preterm birth clinic, I sympathise with Bryony Jones, who probably was very stressed during the whole pregnancy. So what did you do, if anything? Did you do anything special with the cervix, with the neck of the womb? Any stitches in it, cervical progesterone pessaries? Was there any evidence that she was going to go into preterm birth at all?
Yes, so the answer to that is yes. These patients do have a higher rate of preterm birth. We have a patient at the moment who has a stitch in. Patient 1 never did have a stitch. She didn't need the stitch. And we're always aiming to basically get beyond 34 weeks here. So yeah, they're regularly scanned during pregnancy, and you're not wrong. I mean, the levels of tension in the latter part of that pregnancy were very high. I know I personally did not sleep through the night from 28 weeks onwards until the day of the delivery. Every morning I woke up 4 thinking, oh my God.
And when did your obstetricians bail out? I mean, I would be bailing out and be like, ooh, 34, can we do the section now?
Hi, thank you very much for the lovely talk. I understand they don't feel pain and contractions. So do you admit them after some time, or you do weekly CTGs or something?
Yeah, so they are admitted towards the end. And you're right, I think it's one of the fascinating things. They don't feel any contractions, although when they put on the CTG machine and they see the contraction, they feel like there's a ghost of a sense of it, I think, through the abdominal wall. I mean, there's quite a lot of things that are fascinating, because there's one of the patients, there's another duo where the sister had very bad menorrhagia. So the uterus has gone in one sister to the next. The recipient has now got bad menorrhagia. So it's not hormonal, it's uterine in their case.
We still have time for a couple more questions. Richard, you were so swift on time. What about, things like Dopplers and stuff like that? How do you, what do people do looking at the sort of development of the baby and this kind of thing? The growth rate is normal and the Dopplers are normal? You just monitor all of that?
Yeah, so I think baby 1 was it 10th centile? Something like that. 10th or something like that. I have to say, so Isabel doesn't practice obstetrics at all, and I haven't done it for 29 years, right? So we're on shaky ground here.
But so we know that it's very difficult to see these vessels. They're tiny, and there's only 2 arteries and just 2 or 3 veins, or well, 4 anastomosis of veins. So the best predictor is just to see myometrial flow, good myometrial flow. So once that we see it, we're happy. And many times they say, "Oh, I can't see these vessels." Well, what can we say, no? But during the pregnancy, they've been very, very closely monitored, and the baby has been fine. Yeah, and worldwide, we know that there's been all these 65 plus babies have all been born healthy. There's only one child that has missed the developmental milestones a little bit. They're thinking maybe a bit of autism, but nothing abnormal compared to the rest of the population.
That's amazing. Yeah, thank you. Hazel.
Hi, can I ask you a recon question? When you're anastomosing the uterus onto the vagina, do you spatulate it or do you just go for a straight linear one? And how do you balance that risk of stenosis with then potentially leaving a bit of vaginal remnant behind when you're removing it?
So we've actually completely modified our technique. So the first case, we had a long vaginal cuff like a Wertheim. We've shortened the cuff now. It's 2 centimeters at the back, 1 at the front. We do 12 Vaseline sutures. We've been using Vicryl. We've actually got a bit of a debate going on because I think we should maybe change to PDS. The last case we did has vaginal stenosis, and actually we were in theatre last Friday sorting it out, but she had the least vaginal stenosis of any of them. And the rate of stenosis is 70–80%. And it's all down to MRKH, if there's no doubt about that, because the one we didn't have MRKH. She's not got stenosis at all. And in terms of spatulation, I'd originally said we will spatulate, but of course I've always spatulated the vagina posteriorly. What we didn't realise is once the uterus is in, we can't touch it. So as gynecologists, we're always moving it around. Isabel hates us touching it at all, quite rightly. Yeah, I tore the vessels off on one occasion, right? What I did not realise in the first case or the second was that, of course, we could take the bladder down further anteriorly and spatulate anteriorly. And that is what we now do. Because once the uterus is in, we can't touch it. So that vaginal anastomosis, I mean, the clever bit is what Isabel does, but it's actually much harder than you'd think it was going to be.
We got a last question at the back.
Thank you so much for an amazing presentation. I was just wondering with the donors, whether there was any age limits, both young and high, both for the living and the deceased, and yeah, whether they come from.
So with the deceased, it's 18 basically through to roughly 50, but we partly run it around menopause status. For the living donors, I mean, the original case in Sweden, she was 63, I think. She was certainly in her 60s. We have got some people who we are considering as living donors who are late 50s, particularly if they've been on hormone replacement and have normal vessels. But we're acutely aware that when we've investigated some of these people, the vessels aren't up to it. Which is why, dare I say it, we've been 2 sisters so far, not mother-daughters.
That's absolutely fantastic. Thank you so much, Richard and Isabel, for coming along today. It was a wonderful talk. Thank you. So we're now going to move on, and I'd like to introduce Professor Melanie Davies, who's chair of the EGA Hospital Charity, and she's going to be chairing the session where we highlight those people who've been funded by the charity who come back today to talk about their experience. Thank you, Melanie.
Well, just as Richard leaves the door, I thought I'd show you he's a man of many talents. And a couple of years ago, he led a group of us on a great trip to Nepal and Bhutan. I think on the left, I think we're visiting Maternity Hospital. And on the right, we're just heading up for the Tiger's Nest Monastery. So thank you, Richard. Great memories. So we're going to move on now to the next session. And I'm very pleased to introduce this as the chair of the Elizabeth Garrett Anderson Hospital Charity. Just a couple of words of introduction, just to flag up to you that this is your charity. It was founded for the EGA Hospital back in 1979. It was under threat of closure. Obviously, it was saved, and there was money left over, which went into some investments, and a charity was formed. So this is the mission statement, and it's what we still do. We try to improve the health of women. We provide equipment and furnishings for the hospital. training and support for our staff, and we give money for research and innovation. And I'm just going to highlight 3 aspects. The Innovation Fund is for small hospital-based projects that are really going to make a difference to patients. We advertise this, but of course you can put something forward at any time of the year. So watch out in the spring for the next Innovation Fund panel. Then there's the Travel Awards. Anne Boutwood was a very well-known consultant at the EGA Hospital and a great surgeon. And every year we fund at least 1 trainee to go overseas to gain experience or to lead research. And actually there's a nice picture there of Hajra Katak, who has come back to us now as a clinical lecturer. We also every year fund a research scholarship, which covers the PhD fees for the successful candidate. That's opening now, so if you keep an eye on the website, we'll be open to applications up through Christmas into the end of January, with an announcement in February that hopefully will allow either a new candidate to start their PhD, maybe in the May entry, but it's also open to people who are already undertaking research through the Institute, who can apply for funding for the remainder of their studies. So now I'm delighted to be able to introduce 3 speakers who illustrate what the charity has been doing. The first is Omar Risk, who got the travel fellowship and went to Sierra Leone, and he's going to speak about point of care testing in Sierra Leone. So, you need help.
Hi, everybody. Really nice to meet you. Thank you for having me here today. What an incredible talk to follow on from. I'm feeling kind of imposter syndrome. The day that Miss Jones was doing that cesarean section, I was not very far away, very stressed for a different reason, because I was stepping up from SHO to registrar on the Queen Charlotte's Labour ward. Yeah, but it was nice to have an insight into what else is happening at Charlotte's at that time. I can see my slides on the screen here, but I can't see them on behind me. Is there something that I need to do? I'm very sorry. So just I'll quickly introduce myself. I'm an Obs and Gynae Reg academic clinical fellow. Thank you. Academic clinical fellow Imperial, about to start a PhD. And I want to talk to you about point of care tests in Sub-Saharan Africa, in particular, one type of point of care test, and why I think it's important for addressing maternal mortality globally. I want to give you a bit of context. I want to help everyone here to be advocates for global women's health. I want to talk to you about the scale of the problem. I'm going to show you some dots from 3 different countries. Every dot is a woman in 100,000 who will die in pregnancy in each of those countries. A purple dot is a woman who dies with a hypertensive disorder of pregnancy. And a red dot is somebody who dies of bleeding, which is the leading cause. Preeclampsia is the second leading cause of maternal mortality. This is the UK. We have a maternal mortality ratio of about 12 to 13. So there's 13 dots. There's not one whole dot with that's purple, because we've got much better at managing hypertensive disorders of pregnancy in this country. Zambia, where I'm going to be for my PhD, the maternal mortality ratio is 250, largely driven by bleeding. A whole line of women in this grid dying with what is, in theory, a preventable condition. The risk of maternal death of preeclampsia in Zambia is 500 times greater than it is here in the UK. And in Sierra Leone, where my travel fellowship was, the maternal mortality ratio is 350 per 100,000. These maternal mortality ratios are improving thanks to the work of people on the ground in Sub-Saharan Africa. But you can look at this and you can think that it's some kind of tragic misfortune, but it's not. We can do something about this today, and it requires attention, political attention and advocacy. So that's the context. And now I want to talk about, well, what is the point of care? And so the Pineapple study was my colleague and friend Katie Kurt's PhD. This was the home for my travel fellowship, and you can read her recently published paper through that QR code. And this is a visual abstract that I can see doesn't come up massively well, but it shows the 3 delays and the reason why, one of the reasons why women die unnecessarily in Sub-Saharan Africa is because of a delay in having a condition recognised, a delay in getting to a place of care, and a delay in receiving care once there. And so the numbers on this table that you can't read very well show that in her study, where she recruited about 600 women in hospital with hypertensive disorders of pregnancy between 24 weeks to 36 weeks, that a point of care PLGF test using 2 different devices could be used as a rule in and rule out test for bad outcomes. And so on one of the devices, a level below 20 was very abnormal, had about a 1 in 6 risk of death or eclampsia. 1 in 3 of those babies would go on to die. And whereas on the other hand, the green, lovely in green, a PLGF above 60 on the Ronia device still had an unacceptable risk of maternal death of 1 in 20, but no babies died in that group. And so Katie was doing this in hospital, and this has been the basis now of a randomized controlled trial of PLGF testing with decisions to deliver in Sierra Leone, Zambia, and South Africa. But I was asked to have a look at, well, can we do it in the community? Not is it feasible in a very big sense, like do people find this acceptable, but can we do it? Could we do a research study that involves point of care PLGF in a community setting where the bigger burden of disease is, and actually a different test case, like can we try to triage people? Could we try to even predict outcomes earlier on? And so I went to Sierra Leone for a month at the end of 2023. I met a research assistant or a community health worker called Amara. I'll show you a picture of him in a second. And we drove around in a cab basically for a month trying to find clinics who would let us who would work with us to do point of care PLGF testing by working with midwives and the district health officials under the ethics of the original Pineapple study. And we worked in Leicester, which was led by community health workers, Malama, led by midwives, and Recupa, which is a hospital but doesn't have an operating theatre. So there's a kind of like second tier in the Sierra Leonean system. This wasn't, so it is feasible. We could do this, and we developed all the processes and systems you'd need to do research for point of care PLGF testing. That's Mara doing one of the Ronia tests, and I think that picture on the right is a really good image of like the kind of community setting that I'm talking about with the mosquito net and there's no sonic aid, limited blood pressure devices. Like that's the kind of place that we're working. In terms of results, so my target was to recruit 50 patients. And what happened when I was in Sierra Leone is that there was an attempted military coup and I live next to a barracks. So I didn't get so far in managing to recruit 50 patients, but I want to talk to you about the story of the 13 women who we successfully recruited, consented, and followed up. And it is actually amazing. Amara's work when I had left Sierra Leone to continue to follow up patients to find out what happened. 8 women went on to have normal outcomes, to term delivery at birth, and they were okay. 1 patient had a fit. So at this time, we didn't know that PLGF was validated for this use. So just bear that in mind when I'm showing you these numbers. She had an undetectable PLGF level. What 0 means is a little bit unclear on a point of care machine, but so it was an undetectably low level. There was 1 preterm birth with a very abnormal PLGF, another preterm birth with a normal one, a term stillbirth, again, with a very, very low PLGF level, and a second term stillbirth. But can you imagine this rate of morbidity in a London unit? It's not acceptable here, and it shouldn't be acceptable in sub-Saharan Africa either. Just thinking where next? Where next for me, like what this work supported, what the award allowed me to do was develop a PhD fellowship application. So I'm starting a PhD in about 2 months with King's and Zambart and the University of Zambia. I have a fellowship that the EGA award was part of the feedback that said that I'm competent to be able to do this type of work. That's very much on the discovery end. It's about the genomics. We haven't got an acronym for it yet, but it's about the multimodal architecture of preeclampsia in sub-Saharan Africa, advancing biological understanding for enhancing risk stratification and precision care. But I'm also going to be embedded in a project called Cradle Smart that I already have a lovely acronym, funded by the SCDO, about community empowerment approaches to develop local sustainable maternity care with co-developed technology. Why does this matter? So what is this PhD going to do? It's about early risk prediction for preeclampsia in sub-Saharan Africa. We can predict it from like 14 weeks. If we take a history, like NICE tells us to do, we detect about 40% of women who get preeclampsia. We tried to do the same in Sierra Leone. That didn't work, has a detection rate of about 5%. And the gold standard, I guess, is the Fetal Medicine Foundation advanced algorithm. but that doesn't have implementation potential in London because it's too expensive and we don't have enough sonographers to use uterine artery Dopplers, and the lab tests are expensive. But we want to try to make something that performs as well as that, but that has implementation potential in countries like Sierra Leone and Zambia. Why does it matter? Aspirin is cheap and works, but in countries that we work in, the uptake is just 2%. We need to work out ways to target aspirin. I think other people are working on randomized controlled trials of aspirin in sub-Saharan Africa, but we know that it works and in a high-income country setting reduces maternal and fetal morbidity. Maybe it also prevents mortality. What is Cradle Smart? What actually are we doing? It's a cohort study of 10,000 women in 3 countries, evaluating the predictive performance of a bundle of point-of-care tests and neural network estimated gestational age, gestational age estimation, and trying to calibrate the right maternal factors and blood pressure devices that work for sub-Saharan Africa. I'm a nerd and I care about prediction and Alrock curves, but that's not the whole story. We have to balance prediction with cost and accuracy. And I might find out by the end of this PhD that actually the thing that we need to do is check blood pressure well, and not do lots of fancy tests. Or maybe we find that these tests can provide a kind of cost-effective benefit. My last bit, I hope I've still got time. What the fellowship is funding is something a bit more about discovery. We have lots of things that we think can predict preeclampsia. Oh, it's another rubbish thing where the text is too small. Basically, these are they're C statistics. This is how well different features predict preeclampsia. The one in the red box is blood pressure. No wonder, that's the best predictor of preeclampsia. And there are lots of different clinical predictors that we use. Nestled in next to it is a polygenic risk score for preeclampsia that among European ancestry or white women performs as well as any other clinical predictor, but it doesn't work so well among women of African ancestry. And there's a good reason for that, and it's the data that polygenic risk score was trained on. The largest genome-wide association meta-analysis in preeclampsia included 20,000 women. So here, each dot is 10 women. Can you guess how many of those women were women of African ancestry? Can anyone guess before I say? You can probably count it. It's 0.1%, 20 women in that meta-analysis, genome-wide association meta-analysis, were Black women. So Antonio, my supervisor, and I and others are interested in trying to build multi-ethnic cohorts to improve preeclampsia discovery and prediction. So thank you to the EGA charity who kind of supported me in a really critical juncture in my early career. So really thank you. I'm grateful to the participants and the midwives who support this work. My supervisor is that Kate, who I was able to meet through this project and who has been a real advocate for me so far, and also my mentors and peers. And thank you. Thanks for listening to me.
Brilliant. Thank you so much. And perfectly to time as well. Any questions?
Maybe I'm naive. Why not just give everyone aspirin? Just insist on everyone getting aspirin in pregnancy?
Would that be okay here? Would we do that in the UK?
You asked the wrong person. Perhaps. I actually suggested that perhaps that was an approach that was possible in the UK 10 years ago.
Yeah.
I know we have more money in the UK and more resources, so we can be more sophisticated. But in Africa, why not?
I think that if it would be, I think there's a different question about whether or not globally everyone should have aspirin. I think that if we are saying that the evidence base says that we need to target it and there's a potential risk and harm to giving it to the whole population, there's some people who don't benefit. I don't see why it should be any different for a population in sub-Saharan Africa. We just need to design the pathways that work well for the settings that we're working in. And I think we can still achieve similar benefit. We shouldn't be exposing people to harm. I think that's the kind of next 5 years of work, is to work out, well, what is the right pathway and what's cost effective. With the evidence available, it's hard to say, I think. Thank you.
Okay, well, thank you very much indeed, Anna. Brilliant. So our next speaker is going to be one of the recipients of the PhD funding. This is Chiara Petrozzolini and she's the Research Scholarship winner in 2023. And her subject is one that I think is important to quite a few people in the room, about postnatal sleep disturbance. So sleep disturbance in the etiology and prediction of postpartum psychosis.
Hi, everybody. My name's Chiara. I'm an SD7 trainee in Obs and Gynae, and I'm currently finishing my PhD on postpartum psychosis. Thank you so much to the charity for funding my research and for inviting me to talk today. So, postpartum psychosis is a severe but treatable mental illness that happens in up to 1 in 500 women who give birth. And it can present in lots of different ways, which is part of why it's really tricky to spot sometimes. But the main thing you need to know about it is that it's a medical emergency. And that is because its symptoms develop very, very quickly, they escalate very rapidly, and they are associated with a significant risk of suicide and infanticide. Now, the etiology of postpartum psychosis isn't very well understood. There's a few recognized risk factors. One of them is a pre-existing history of bipolar disorder. But having said that, in about 50% of cases, women don't have a pre-existing history of mental illness, and the cases are somewhat out of the blue. And so that means that prediction is really difficult, and early intervention is also really difficult. And so I decided to look at sleep, and I did that for a number of reasons. So the first to be aware of is that in one of the recent Embrace reports, there was a recognition that many of the women who died by suicide had marked and enduring sleep disturbance. And this vignette is just an example of one woman in this country who had asked for help in emergency services, saying she wasn't able to sleep for a number of reasons, didn't get the support that she needed, and unfortunately died by suicide a few days later. So there was a recommendation in the report that we should be assessing women with persistent insomnia or other sleep complaints very seriously in this time, because it could be a marker of a severe underlying mental illness. And sleep and mental illness are closely interlinked in complex ways. There is an element of sleep disturbance in virtually every psychiatric illness. And so for a long time, it was presumed that sleep disturbance was just a symptom of mental illness. However, in lots of studies done in the 70s and the 80s, somewhat unethical studies, where they experimentally sleep-deprived people, it was demonstrated that you can induce new-onset mania and psychosis in previously completely healthy individuals. And that's also been shown in really vulnerable individuals, so women with pre-existing bipolar disorder who are well. If you sleep-deprive them or change the pattern of their sleep, you can induce new-onset psychiatric symptoms. And similarly, we know that sometimes sleep changes can precede mental health deterioration by several months. And so both of those things imply a direction of causation, really. And so the accepted model now is that this is a bidirectional relationship where sleep disturbance, sure, can represent a symptom of a mental illness, but it also very much contributes to the disease process. And in postpartum psychosis, not needing to sleep or not being able to sleep is by far one of the earliest and commonest symptoms. And in prospective data in women with bipolar disorder, they've identified that women who lose at least one full night of sleep in the intrapartum period are at significantly higher risk of developing postpartum psychosis than those who do not. And so there definitely is a relationship there, but that relationship is very poorly understood. And that's exactly what I've tried to unpick in my PhD. And the other thing I've tried to address in my PhD is this, which is the social narrative. This is just a collection of greeting cards that I've come across over the course of my PhD, and I think they really speak to the way that we address sleep in the perinatal period. It is very culturally accepted that you are going to be sleep deprived for a significant period of time, and that really that's just funny, and you should just get on with it because it's a normal part of motherhood. But I would argue that just because something's common doesn't mean that it's normal. And actually, as I've just told you, there is data to suggest that sleep disturbance can trigger severe mental illness or be a sign of a severe mental illness. So I would encourage you all to fight against this social narrative, which in my view is actually quite toxic. And so I put together the SLEEP study, which stands for Sleep, Clock, Genes and Education in Postpartum Psychosis. And there's lots of different components to the SLEEP study, but essentially all these studies have the common goal of improving outcomes for women and families affected by postpartum psychosis through early intervention. And what I'll talk to you today is just about a couple of findings from my PhD and just give you a bit of an overview of what I've been up to. So a lot of my time has been spent looking at genetic data in women with bipolar disorder, who, as I said, have an increased risk of postpartum psychosis. It's important to recognize that even in that cohort, it's really difficult to predict who's going to become unwell postnatally and who's not. That means that obviously resource allocation is really inefficient. And so both bipolar disorder and sleep traits are known to have polygenic inheritance. So that means lots of common genetic variants contribute to disease risk together. And you can basically use the summary statistics from genome-wide association studies for a specific trait to determine a polygenic risk score. So that's an individualized genetic risk score for each person that gives you an estimate of how likely they are from a genetic perspective to develop a condition relative to, the general population. And basically, that's what I did in these women. So I looked at a cohort of nearly 350 women with bipolar disorder who have had children. Some of them got postpartum psychosis, some did not. And I did various polygenic risk score analyses to try and see if we can predict from a genetic perspective who is more vulnerable. And the first thing to say is that polygenic risk scores for psychotic illnesses, so bipolar disorder and schizophrenia, are not predictive of who's going to get postpartum psychosis. And this is a replication of a study that's already been published in The Lancet in 2021. And even, with adequate, ample power to detect a significant effect, even with tools that are actually very good, essentially you cannot explain whether or not someone's going to become psychotic simply by looking at their genetic predisposition to psychosis. So the answer has got to be somewhere else. And now I'm just going to show you some data from some of the other polygenic risk scores I looked at. So I looked at insomnia and short sleep duration. I'm just going to talk you through these graphs. So each of these dots here represents a polygenic risk score of an individual. And what you can see here on the side are basically like tilted bell curves. And they're normalized against healthy controls. So your average person walking down the street that has no pre-existing history of mental illness will have a polygenic risk score of 0. And what you can see here is that, so I'm comparing women who got postpartum psychosis with those who did not. And you can see here that women who got postpartum psychosis had a lower polygenic risk score, so a lower genetic predisposition to these sleep abnormalities than the women who did not. And that difference was highly statistically significant even when correcting for multiple possible confounders. And for each one standard deviation increase in the genetic risk score for the sleep abnormality, there was about a 30% reduction in the odds of them having had postpartum psychosis. And you can think about this in a slightly different way. So if you imagine everybody sits on the bell curve at some point, and you compare the women in the bottom 10% with the top 10% of the genetic risk score for the sleep disturbance, those in the lowest 10% had about double the risk of having had postpartum psychosis than those in the top 10%. And now that might seem somewhat counterintuitive when you first kind of hear these results, but actually in time, we have felt that they make a lot of sense. And the way we try to explain them to ourselves is this. So if you are somebody who has a genetic predisposition to sleep disturbance, it may well be that over the course of your lifetime, you developed heightened tolerance to sleep disruption, which then means that when you get the acute sleep loss that comes with childbirth, then the impact that that will have on your mood might be somewhat mitigated. And this fits with the fact that one of the few risk factors that we know is pretty solid for postpartum psychosis is primiparity, so first pregnancy. So if this model is true, then it may well be that what the role that sleep has in postpartum psychosis isn't so much generating the psychosis in itself, but it may be more so the novelty of the sleep disruption that has an impact. And just to show you quickly, it may well be that these polygenic risk scores have a predictive impact. So this is just a ROC score showing you this. And the grey line essentially means no difference. You may as well get out of a hat and just guess at random whether a poor woman with bipolar disorder is going to get postpartum psychosis. We have very few predictors that we can use at the moment. The red line is bipolar subtype. So one of the few things that we have is whether if someone has bipolar 1 or bipolar 2. So we can use that to help prediction. And you can see it's not that much better than random. But the blue line basically shows what happens if you add the polygenic risk scores that I've just spoken about to bipolar subtype. And you can see that we're starting to get somewhere. And so I have hope that there is potential here. And just to talk you through the other things that I've been up to. So I've been running a prospective observational cohort study at UCLH. And the premise here is that we know that the majority of women who develop postpartum psychosis will do so in the first 2 weeks postpartum. So that is definitely the bit of highest vulnerability. And we also know that the majority of women will present with mania, so a state of elevated or irritable mood. And whilst postpartum psychosis is uncommon, mania is actually pretty common in the perinatal period. And so the idea here is if we are better able to predict mania in this vulnerable time, we may be better able to detect the women who are at risk of developing postpartum psychosis. And so in this study, we are essentially trying to identify whether there are sleep variables, objective or subjective, that can predict mania risk over time. So women are recruited in the third trimester, up until 2 weeks postpartum. They wear a device on their wrist called an actogram, and essentially this tracks their sleep. Same technology as a Fitbit or an Apple Watch, and they complete some questionnaires on their sleep and mood in this time. And we have finished the data collection, which is big achievement. And I'm currently deep into the data, looking at it in detail, and there's definitely some exciting stuff. So I'm not ready to give you the punchlines just yet, but I did want to include some images of this data, which I think are kind of powerful in themselves. So just to show you, this is an actogram, and basically each of these lines represents a successive day of the week. And this is somebody in the third trimester who is fit and well, no history of mental illness. And I should probably say that intentionally in this study, I have been recruiting women with and without a pre-existing history of mental illness. So this person is completely low risk. You can see the black stuff here. Basically, that just means movement. So this device will track movement. And then the absence of movement is used to infer sleep. So these pink windows that I've drawn in here are basically where we estimate that these people have been asleep. What you can see within the pink window is that there's some blue lines, and that basically means that this person will have pressed the marker button on the device a few times to signal an event. And that usually means I've woken up, I've been tossing around in bed, I needed to go for a wee. And so what you can see here is that there's a fairly clearly defined sleep window, but that sleep is pretty disturbed before the baby's even in the picture. And then let me show you what sleep looks like when you just had a baby. So again, completely healthy individual, no history of sleep disturbance or psychiatric illness. You can imagine that trying to estimate where the sleep window is here is very challenging, and that's probably because there isn't one. And so I think this is quite a powerful representation of what sleep can look like, even for those who don't have underlying vulnerability. And I've also spent a lot of time in the East London Mother and Baby Unit over the last 3 years. I've been interviewing women with lived experience of postpartum psychosis, and I've intentionally only interviewed women who don't have a pre-existing history of a psychotic illness, just to really try and unpick what the role of sleep has been in their illness. And again, in the interest of time, I won't be able to present that data today, but what I can say is that I'm a bit of a qualitative research convert, because the results have actually completely blown my mind, and I think are likely to change the narrative in this field, and have been actually in some ways far more interesting than any of the quantitative stuff. Really powerful stories to hear. And I also wanted to take this opportunity to thank the EGA charity for funding a separate project of mine that won't directly be part of my PhD, but it's very close to my heart. I have basically been running an RCT of simulation. And what this is all about is that basically, as I hope I've drilled into you, postpartum psychosis is a medical emergency. We use simulation in maternity all of the time, and we know that it improves outcomes for emergencies. And it is quite mind-boggling to me that we don't do this for mental health, given the morbidity and mortality associated with it. And so this is a randomized control trial that's multi-center. And the idea here is to try and demonstrate that if you educate maternity staff using simulation, you can improve staff's confidence and skill set in the ability to diagnose and manage postpartum psychosis. Essentially staff get randomized to either just a lecture or a lecture and a simulation, and then everybody gets exposed to a second scenario several months down the line to see if it makes a difference. And we've run it at the Whittington, and spoiler alert, it works. And I'm hoping to bring it to UCLH very soon. And it's gone really, really well. And I'm hoping that at some point soon, we'll have RCT level evidence that something like this should be mandatory as part of something like PROMPT. And this should be treated like any other maternity emergency. And I just want to say thank you so much to the charity for supporting me in this time. I've got to do some amazing things over the course of the PhD. I feel really, really lucky. Got to present in lots of different places. I got to run the RCOG Perinatal Mental Health Conference. More recently, I got invited to the Labour Party conference to a maternity roundtable discussion. And in a slightly out-of-body experience earlier this week, I actually got to go to Parliament to talk to a few MPs about maternal mental health policy. So I just want to say, and hence the bewildered face. So I just want to say thank you, because it has been absolutely amazing. And thank you as well to the other funders and the Action on Postpartum Psychosis charity. And thank you so much to my supervisors, especially Prof. Siasakos, who's my primary supervisor and has been absolutely incredible throughout all of this.
Because time is short, I think we may need to move on to our third speaker. But Chiara, will you be here over tea?
Absolutely.
Which follows this session? Because that was such a stunning presentation. There'll be lots of people wanting to talk to you. But our third speaker, again, is a recipient of the EGA Charity Research Scholarship in 2022. And this is Lily Erinoso Olofe. So she's going to talk to us about a condition which is not women specific. So this is a health condition that affects women in particular. So she's going to talk about, do female hormones influence the inflammatory response in women with asthma? Thank you for coming, Lily.
Okay, so asthma is a long-term chronic disease that causes the airways to become inflamed, narrow, making breathing more difficult. So as these images show, this is the lungs, and it branches off into what's known as the bronchioles. So in asthmatic lungs, these narrow to look more like this. And this is often triggered by allergens, such as pollen. And so these bronchial epithelial cells make up the lining of these small airways. And biomarkers for asthma include high mucus secretion and elevated for inflammatory cytokines such as IL-13. So more than 300 million people are affected worldwide and 8.2 million in the UK. Asthma has a disproportionate effect on women when compared to men, as the data in these figures show. But from about the age of 15, the incidence in females is a lot higher compared to men. But despite this, most research so far has been carried out on men. So this project is investigating if female hormones do have an influence on the inflammatory response, and this will be by using a human bronchial epithelial cell model. Okay, so the first aim is to differentiate these bronchial epithelial cells into a pseudo-stratified epithelial layer using an air-liquid interface model, which I'll go into detail in the next few slides. And then from here, I'll assess the inflammatory response with general asthmatic triggers under hormone exposure, mimicking each of the 4 stages of the menstrual cycle. So that's what this figure here is showing. Specifically, we want to mimic the peaks in the ovulation phase and the luteal phase. And then from here, we want to derive gender and asthma-specific primary cells from inducible pluripotent stem cells, or iPSCs, and this will be part of a longer-term personalised medicine approach. Okay, so iPSCs can be generated from somatic cells derived from either urine or buccal samples. And then this is just a diagram to show the sequence of events. So then these samples will be reprogrammed to pluripotency, and then from here differentiated into bronchial epithelial cells. And this could allow for the generation of donor-specific air liquid interface models for better diagnosis and prognosis. And yeah, this would be a long-term personalized medicine research. Okay, so as mentioned earlier, the way we're going to model these airways is by using an air liquid interface culture or ALI culture. And these are used to create in vivo-like conditions by exposing the cell culture to air whilst the basal layer remains in contact with liquid, which is what this figure here shows. And this just creates a more realistic in vitro environment for structures to develop and function. So the specific cell line that I'm using is an immortalized cell line known as HBC3KT. And the reason for this is because the results are reproducible and more consistent compared to primary cells. And then the markers that I'll be looking for following differentiation are cilia, which is this image here. They're like hair-like projections that grow from the epithelium, mucus, and then tight junctions, which are the barriers that hold the cells together. So these cells will be grown at air liquid interface for up to 28 days. And during this time, some cells will be exposed to hormones and then some not exposed to hormones to compare. And then following this priming of the epithelium, they'll be exposed to the inflammatory protein IL-13. And this is just to induce asthmatic epithelial features in the cells, as it plays a key role in the pathobiology of allergic asthma. And then following this, an allergen will be added to trigger an inflammatory response. So far, I've established the air liquid interface model and also the biologically relevant hormone and allergen concentrations and the secretion of some inflammatory markers. So the methods that I've used to do this include real-time PCR to measure inflammation at the RNA level. And with this, I'm specifically measuring for IL-8, IL-6, and then the phenotypic markers for cilia, FOXJ1, and mucus, MUC5AC. And then also an analyzer to measure inflammation at the protein level, and histology to show that the model has been established and mucociliary differentiation has been achieved. So this is some images of my previous ALI cultures that I've grown. So this first image is using the H&E stain just to show the structure. Here is the membrane, and you can see there is a multicellular structure, which was a good sign. And then here I used a periodic acid shift stain, which is used to stain for mucins. So here we think this might be mucus, but for extra confirmation, we use special staining known as immunohistochemistry, which uses antibodies to bind to a specific antigen being expressed in the tissue. So this brown coloration is an indicator of MUC5AC, which shows goblet cell differentiation is present. And in its healthy state, the epithelium, the MUC5AC in the epithelium contributes to the protective mucus layer. And in asthma, it's known to increase. So my experimental next steps will be to validate the hormone asthma signals in the air liquid interface model, and then broaden these inflammatory and hormonal readouts. And then I'll also be carrying out a scoping review on how hormones influence airway diseases and exploring generating airway epithelium from iPSCs derived from somatic cells. And then from here, link the laboratory results to clinical asthma patterns across the menstrual cycle. This will highlight the need to adjust treatment for disease in women that reflects their needs and disease pattern, and deduce whether fluctuating female hormones play a role in the onset, progression, and exacerbation of asthma in women. So thank you to the EGA Hospital Charity for supporting me the last few years, and my lab groups. And yeah.
Thank you very much, Lily. Has anyone got any questions? Would you like to take any? I mean, the study of asthma is probably quite new for this audience. I had no idea that it could be influenced by female hormones and the cycle. Maybe there's some networking to do with some of our earlier speakers about apps, because charting it through the menstrual cycle is one of your future directions, and there's a lot of knowledge of that in this room. Anyway, thank you very much for speaking. So I'm delighted the charity is funding such a breadth of work, from the bench to the clinical side, and both UK and international. So it's the end of the session. Coffee and tea is now served. And would you come back in at 4:05? Thank you.
On here. Hi there, I'm Divya, one of the gynecology consultants, and was the previous audit lead for gynecology at UCLH. Unfortunately, Annie Baha, who's the current clinical lead for audit, is not here. We've got our first presentation by Raf Napolitano, who has presenting some work carried out by his fellows, which is a service improvement project looking at screening for fetal growth restriction and management of small baby. Thanks, Raf.
Shall I go with this one? Yeah, maybe. Off. Thank you. Thank you for having me at the end of a long day. I'm sorry we could not be here, some of our clinicians in the morning, but it looks like you had a very successful day. So hopefully I'm not going to take you for long, because you're eager that you need to go for drinks and concluding the day nicely. Thank you, Sarah. Thank you, Anna. Brilliant organization. Thank you to Jo Bodder. I'm sorry that, she had difficulty in her family. She cannot be here today. But she asked me to present this because it's at the core of what we do every day in maternity. And I'll try to make it interesting also for some of you who do not scan or do not see patients all the time, but you work in straight contact with us from the Institute. So hopefully you will find it interesting. This is the job of Valentina Letano, who's one of our graduated master students in ultrasound, and Matthias, one of our sub-spec graduated as well, who contributed to all of this analysis. So just at the state of the art, what do we do in terms of screening and management of fetal growth restriction? It's a major problem, a major cause of stillbirths, and we still not solved the problems. We know something, so after 20, 30, 40 years of scanning, I can just see the gynecologists in the audience. Stuart, don't look at me in this way. Why am I talking about these things after 30 years of doing scans and Dopplers, and you still not solve this problem? Whereas, stewards can make babies and do things, and so, we know something. So there is something that we solved. So we know something about screening and prevention. So with the introduction of the multi-parameter screening test for preeclampsia, we can also screen for fetal growth restriction, placental insufficiency. This has been introduced at UCLH. And yes, previous speaker said how difficult it is to do things for the sonographers, not at UCLH, not for our master student fellows. They implemented this one for free almost, and with a bit of training, standardization, a huge amount of work. We will report, hopefully, if you invite me again next year, on the first results of our implementation. But we know a bit that implementing first trimester screening for preeclampsia giving aspirin to the appropriate people, you will also prevent some babies developing fetal growth restriction. But we're not going to talk about that today. We talk about two policies that we implemented since 2018 at UCLH. One was to have a more individualized and more evidence-based screening policy at the anatomy scan, which is the second point of assessment in pregnancy from the scanning perspective in all women, and how we arrange a different targeted third trimester ultrasound scan policies. And we have also introduced two different new criteria for diagnosis of suspected fetal growth restriction and also management. What is the issue here? So we've all been taught and trained that early fetal growth restriction is different from late, and we're all taught as well when babies die very early. This is a large single center series from King's, probably still the largest as a single center, where all stillborn babies are plotted against charts, and you exclude all any other possible causes of stillbirth, so allegedly all placental insufficiency babies. And you can see at the beginning of the third trimester, the vast majority are small, and more 70% of them in the Truffle-1 study, for example, are associated with hypertension. So it's unlikely that we will miss them from the screening perspective. So it's easier to diagnose, more difficult to treat because we don't know how to treat them other than delivering the baby. And that's why the issue is there with the prematurity. Later on, there is a bit of a gap, and I suspect some of those babies are dying because they are not identified earlier. But the vast majority of stillborn are occurring post 36 weeks, and the vast majority are also big on size. And that's why using our traditional scans biometry is not enough, are difficult to diagnose, and people can argue are easy to treat because if you recognize it, you diagnose it, you just deliver. But I will show you that it's not that right. Interpreting the data in that way, there are issues also with the late prematurity. So an example is implementing universal screening for uterine artery Doppler, blood flows for the mom to the placenta in the second trimester, is still the best isolated predictor of developing fetal growth restriction or preeclampsia later on in pregnancy, but it's not recommended in any guidelines, national, international. And then this is one of the issues in how trials are run. Yeah. So I take a woman, I give her uterine Dopplers, and then I'll tell the clinician, this is the results and this is what you do. And then you forget that there are 20 weeks more of pregnancy, and anyone in those trials, it was not recorded what they were doing. So this is how we are trying to do something different from what was done before in terms of introducing a new screening policy. And paradoxically, or maybe not surprisingly, women with increased resistance in the uterine artery Doppler, they have a higher chances of fetal growth restriction or preeclampsia or abnormal outcome. And therefore, it should be used in high-risk women by their history. But we know that in high-risk women, chronic hypertensive, diabetic, and so on, that risk is there already. So what that extra screening policy will add, we're going to do third trimester scans anyway. So the aim of this study, that it was part of a clinical management change, was to assess the impact on small for gestational age detection using this new screening pathway, which included universal second trimester uterine artery Doppler at the time of the anatomy scan, and different pathways on when to do third trimester scanning. We introduced extended diagnostic criteria for suspected fetal growth restriction, so we are not missing only the babies that are small, but we are catching some babies that are a little bit bigger, but they have blood flow abnormalities. And also we introduced a standardized way of managing them. We wanted to make sure also that we didn't create problems. We didn't create prematurity. We didn't do more harm. So this was a single center retrospective time series analysis. In 2018, there was introduction of these new policies, and then we compared the data the year before and the date after, all women who had babies born after 22 weeks. The intervention was the implementation of the policy, and the comparison was what was done before, which was according just with the NICE guidelines. So doing uterine arteries in high-risk women only, those women, they would have had extra scans anyway in the third trimester. And then the criteria on when consider a baby small were a little bit vague. The Royal College guidelines said something there, but not that specific. And there was a clinician choice in how to manage those babies. And the primary outcome was, first of all, babies less than the 10th centile, but also we look at secondary outcomes such as abnormal neonatal outcome and also maternal intervention. So I'm going to start from the end. I'm just going to show you first what were the results of women who actually had the babies diagnosed as a suspected fetal growth restriction, and they were managed in our small baby clinic, which was a new service that we implemented, again, at zero cost. Thank you to our managers, that they supported a lot, Rebecca, our current manager, the managers of that time, and our fellows who do all the work in this clinic, but also all of the fetal medicine colleagues that they put together this protocol. So basically on the top here you see 4 criteria on how women, how babies meet the criteria to be suspected small. For those of you who are very savvy from the clinical aspect, basically we put together biometry, changes in the growth, but also blood flow abnormalities in the context of a baby who's not appearing small on scan. And that of course will increase our sensitivity. We'll have more babies scoring as potentially affected by growth restriction. The high-risk group, if any other associated problems on scan, we deliver them earlier. The low-risk group, we deliver them a little bit later. It's quite interesting how, when this paper was published, then it is cited in the current Royal College guidelines on SGA management, and they used our paper to say, well, if you screen properly these babies, some you can manage them conservatively, and you can wait until later, but they pick up at 39+6. I'm not sure how, as an absolute cutoff. So Anna, we might have to change it and say 40 is absolutely crazy because it's against the Royal College guidelines, even if the Royal College guidelines use your paper to decide if you need to deliver them or not. But anyway, so first results are as such. What we thought antenatally was predictive of the postnatal phenotype. Did it actually translate in changes in the outcome? The answer is yes. So this was published just last month in the American Journal. This is the work of Bianca Tauda, one of our graduated master students in ultrasound, on 1,000 babies. The overall composite severe abnormal outcome was lower into what we consider the low-risk cohort classified antenatally. And a lot of it was the fact that we managed them conservatively, and we did not add also risks of late prematurity. Even if the severe abnormal outcome probably it's not too much associated with the prematurity pictures, but you know, the respiratory morbidity still plays a role. I just want to highlight that there were no cases of stillborn in babies managed conservatively. And did we have a change compared to what was done before? This one again is a small time series analysis comparing with the babies who were retrospectively classified as small before we implemented these management policies. And in the high-risk group, before or after 2018, no big difference, not a big surprise. Those babies were also delivered a little bit earlier. But then later, if you look at the low-risk group, there was a difference because we deliver babies a little bit later. The birth weight was higher, lower risk of prematurity. Some of you might not be that interested in hypoglycemia, hypothermia, but those are events that they do affect our workload, our neonatal unit admission, which was reduced after our implementation. I was expecting a clap from the neonatologists in the audience, but no. Stuart, remember this when they don't give us codes and where is Nikki or other neonatologists? Feel free to speak. So our intervention policies was as such. We introduced a universal uterine artery Doppler for all the women, our famous pathway. The main advantage was that this pathway be women, so women who otherwise will have just symphysis aldehyde, if they had increased resistance in the uterine arteries, then they would have get third trimester scan, mainly at 28 to 36 to target these two incidents of fetal growth restriction, the early and late. Then we extended the criteria of why a baby would be considered small, and not just baby who were small, but also if they were dropping the growth, abnormal umbilical, low cerebroplacental redistribution, means the baby is struggling in the womb, and then there is some redistribution of the blood flows. And then again, introduction of this standardized management protocol. Pre-32, they go to fetal medicine, very high-risk babies. Myself, Anna, George, Melissa, you will not see many of those in our practice, but you see them on labor ward. Whereas post-32, they are managing the small baby clinics. So we had more than 10,000 women that managed to meet the criteria to be analyzed into the analysis. A huge amount of work. It did require merging 5 databases. So a lot of work that was done by Matthias, Valentina, and so on. We did have an increase in the SGA detection from 35 to 51%. And that's not surprising. Overall, the policy is there, not just the uterine screening, but how we scan them, how do we manage them, when we deliver them. This is what is lacking in all the previous randomized trials. And it is much higher than the average nationally. Think about nationally is about 25, 27%. Of course, that came at the cost of an increased test positive rate, and therefore you might scare more women and more babies. But the way I teach my fellows is what you do with the scan, not just with the fact that you find something. Another good outcome was that we increased very much the detection at term. As I show you from the graph, the most difficult situation where babies are not that small and actually they might die because all of a sudden something happens there and the placental insufficiency plays a dramatic, catastrophic role at the end. We did increase the gestational age of birth, we did increase the birth weight, we did increase the birth weight centiles. Yeah, so that was also reassuring from that perspective. The two populations were comparable in terms of demographics. We didn't manage to show changes in a significant reduction in the stillbirth. It was very small, the rate anyway. The study was not powered for this, even if you're talking about the 10,000 women. But probably there is a trend there in improving also abnormal neonatal outcome. No differences in maternal intervention. So also we were reassured by the fact that we didn't do more cesareans or induction. So conclusion is that an integrated antenatal pathway for screening and management of fetal growth restriction can increase the detection of small babies at term. There was no difference in abnormal neonatal outcomes of maternal intervention. However, there was an increase in gestational age and birth weight. And this is my view on the future agenda. So what we will need in the future is not just using arbitrary hard cutoffs, but having AI or not AI generated systems, you know, with our statisticians, Zonglung, with Alex Zaikin, help us to analyze all of those data. They will find a clever way where we give a black box to a clinician and say, these are all the risk factors. You deliver these women at 38, 39, or 40. Very different from what I think we are doing in our antenatal clinics nowadays. So I want to thank you to Valentina, who cannot present here, but she put a poster. Matthias, she was presenting a Keypros FMF World Congress last May, which made me very proud. And this is all the small baby team that was at the Truffle conference in Naples. In Naples, we do conferences even in the churches there. And look for our courses if you're more interested. Thank you.
Is that right, Joel? It's now.
Very dangerous, this podium.
Yeah, perfect. Can I ask a very quick question?
You may, yes.
Being very naive and having not done obstetrics for like over 11 years,
we like gynecology.
Yeah, I'm very helpful and useful. I feel the impression I get is that you have lots of resources and you're able to integrate these kind of pathways. Do you think it's something that's easy to roll out in maybe less resourced hospitals in NCL? I don't know. Is this the question?
It's not easy, but I would say it's possible. And this is one of the challenges. I come from Naples, where there is not much resources, but maximum resources for what you get given. And this is what I try to teach my fellows. Yeah, we do the best of what we have. There are many policies they manage to integrate in their working life every day. And it's not surprising that standardization can create a better outcome independently from what you do. You know, my dream will be if I can randomize a woman to be looked after by Anna David versus not, by Melanie Davis versus not, but you cannot put these things into a trial. Whereas if you have a comprehensive policy, it's not that expensive, you don't have too much scanning time, but probably you can improve the outcome. So many of these things are translatable, and a lot of studies in lower income countries, actually, one of the speakers spoke earlier, are concentrating over first time point of care at 36 weeks, where you can do a scan, ideally with a portable device, ideally with AI in the future. You put it into a black box, it tells you what to do.
Lovely, thank you. There was a question at the front.
Yeah. Thank you, Raf. Fantastic work. You advanced the slide quickly, so I didn't see the number. There were stillbirths in the high-risk group, and how come?
So
they happen in between scans, for example. I think it was one of your previous slides.
Yes. So there were overall in the 5 years, 2,600 women we looked after. We had 2 stillbirths. One was in between the scan, growing normally, normal Dopplers between the 34 and 36 weeks, relatively unexplained. Another was of a woman who declined interventions, and those are both here in this analysis. A woman who declined delivery, and do you want me to go to the obstetric bits that you like? So grand multips, transverse baby, and then refusing ARM, being self-discharged 3 times, seen by 4 consultants. Unfortunately, we failed on that one.
The other one, the 34 to 36 weeks, what did the placenta show?
Placenta normal, but there was a true knot. There was a true knot on that one? I think so. No other findings, no. I know that Demetrius is going to ask me. Find more about stillborn. But I think the important thing is that at least I'm reassured for now, there are no stillborn in the expectant management group. I know that many of you in the audience, they think, why you bother with this? 39 weeks, risk of special needs in the future is virtually 0. Baby can come out. Why you're killing yourself? So I think there is a room to have a more individualized, personalized care. At least I don't like to put women into boxes. I have been, because I have nothing better, but if we find a better quality multi-parameter test that will tell us what to do, can better classify babies who need to come out versus not, I think.
Lovely, thank you so much, Raf. I think unfortunately we have to move on to the next. Lovely. Brooke van der Molen is just walking onto stage. Brooke is our, where is she? Oh, there she is. Senior trainee, currently doing, I think it's called SITM now, in pediatric and adolescent gynae. Don't laugh at me. We'll just get her talk up. So this is really interesting. Brooke's presenting evaluation of adolescent choices, genital differences with congenital adrenal hyperplasia. And my understanding is this is looking at retrospective review of new patients who were seen in not your clinic, but in the services clinic. Thanks, Brooke.
Okay, thank you so much. I was wondering how I was going to link to the previous talk, and then we ended on the need for individualized and personalized care. And I think that does link really nicely to this talk. So as Divya kindly introduced me, my name is Brooke. I'm one of the ST6 trainees currently at UCLH. And I previously worked at UCLH as the PAG Fellow, and I am doing the SITM currently. So I'm here to present on behalf of the PAG team, and my supervisor, Miss Lerner, is here as well. So thank you very much for all your supervision, but also lots of the lovely artistry in the talk is also from her. So I'm talking about genital differences in patients referred to our service with congenital adrenal hyperplasia, and specifically the choices that the adolescents make. So this was a retrospective review of patients referred to the service. So just for a reminder, those of you who might have done MRCOG, we're talking about congenital adrenal hyperplasia. So this is an autosomal recessive group of conditions. There's lots of different ways that it can affect someone. And it affects 1 in 18,000 people in the UK. All of those, the CAH deficiencies are characterized by an impairment in cortisol synthesis. But importantly for our patients, over 95% of the cases of CAH involve 21-hydroxylase deficiency. And that's important because if you are deficient of 21-hydroxylase, as you can see, the pointer's working, yeah. You can see here, if that enzyme is knocked out, you don't produce cortisol, you don't produce aldosterone, and what it results is a kind of shunting down the steroid pathway, which can result in an excess of androgens. So that's how it affects the patients that are referred to our service. So how does an excess of androgens affect someone? Well, we all kind of understand that it can affect you with excessive face or body hair, acne, and potentially subfertility as well. But it can also cause genital differences. So if you are pregnant with a baby who is 46 XX chromosomes, and that baby is exposed to an increase in androgens, then that can affect the development of that baby. So it can cause clitoral enlargement. It can cause fusion of the labioscrotal folds, and you can see some of these illustrated in these diagrams. And also, very importantly for our patients, it can cause the persistence of a common channel. So rather than having two separate openings on the vulva, so a urethra and a vaginal opening, they'll have a single common channel. So it depends on to what extent they're exposed to elevated fetal androgens in utero. So it can affect patients basically in very different ways. Now, what often happens when a baby or a child is born with CAH and genital differences is the parents may request, doctors may request, they may perform a genitoplasty in childhood. Why might that be done? Well, one of the reasons that is often given is parents understandably concerned about the future for their child, that they want to normalize their child, they want them to have kind of a normal, and I say that with inverted commas, normal genitalia. They might be more like their peers. They might wish to kind of feminize their external genitalia. You're expecting a girl baby, and maybe that area doesn't look like what you expect it to. So we try to kind of create something that looks more feminine. And ultimately, it can be done to kind of reinforce that sex assignment. So these are all non-functional indications for surgery in childhood. And we always want to be thinking really deeply before we're doing a surgery, especially on young babies, young children, is are we doing the best thing for them? Is this the best time for them to have this procedure? Because there are risks associated as well. So one of the risks you can have is vaginal stenosis, especially if you're having surgery, for example, to that common channel, or you may be performing surgery to the clitoris, and that may result in them still having the common channel, requiring further surgery later on in life. A lot of these patients who undergo surgery in childhood still need repeat surgery, which may be done in childhood or later on in life. So big range there, but 10 to 80% is estimated. Also, because you might be moving the urogenital sinus, it can result in urinary incontinence later on in life, a really significant complication, especially for a young child. They can, of course, if you're doing clitoral surgery, they can later on experience a loss or a reduction of clitoral sensation. And that's not something they're going to be able to tell you about when they're 4, 5, or 6. It might only be something that they're able to appreciate much later on in life when they can't remember those discussions and the warnings of those potential risks that could have occurred with their surgery. Also, you may be doing surgery to reduce clitoral prominence, for example, but that doesn't necessarily negate the possibility that that person may still have clitoral prominence later on in life, because that area can respond to excessive androgens. And these patients have to take lifelong steroids. It's a really difficult thing to deal with. You can imagine, especially in teenage years where you've got to take these daily medications. And some of our patients do struggle with the compliance, and that can result in elevated androgens later on in their life, which can then result in their clitoral prominence kind of recurring. So it can still be an issue even if they've had surgery to their clitoris when they were younger. And of course, if you're removing part of the clitoris, you may remove a lot of the clitoris, resulting in an absent clitoris later on, again, because that child's vulva may look very different to what it may look like after they go through puberty. And what we're talking about here is this kind of normalizing surgery, because that's often the reason it's given. But are we really normalizing someone? Are we helping to reduce the stigma or shame they might feel later on in life? Or actually, we could be worsening it. And often our patients tell us that they feel kind of worse stigma or worse shame because they can't recall the discussions that happened around their genitals. They had surgery on their genitals, which they can't remember. They don't necessarily fully understand what happened to them. So we may not be doing that benefit that we think we're doing. And also really importantly is that we are assuming someone's future gender identity, because we are kind of assigning them the gender that maybe the parents were expecting for them. But I'll talk a bit later on about why that's important, particularly for this cohort of patients. And this is just to illustrate a patient who had a vaginal pull-through operation as a child. And as you can see from this MRI, that actually they've got a really shortened vagina as a result. So their uterus is sitting quite close to the level of the neck of the bladder. So that can have long-term implications as well. So what is the guidance? Well, this is the guidance from the Endocrine Society from 2018. And importantly, they mentioned that in patients who have CAH, who have genital differences, that we advise parents be informed about surgical options and including the option for delaying surgery and observing them until the child is older. And also they mention here that the option to forego surgery should be considered. It's quite a sea change really from a time previously where perhaps every child may have kind of undergone early surgery, or their expectation was they would undergo early surgery. So we're starting to see a change there. This was a systematic review and meta-analysis from 2018 that included 29 observational studies of patients with CAH who underwent genital reconstruction. So the average age at surgery for these, the children included in this study, or some of them were adults when they were recruited, but the average age that they underwent surgery was 2.7 years old. And this was 1,178 patients included here. They were followed up for 10.3 years. And importantly, in this cohort, 1 in 3 of them developed vaginal stenosis. That's quite a significant amount. Also, just looking at their patient cohort, 88% of them had described themselves as having a female gender identity. So that's a really large proportion who didn't necessarily identify as having a female gender identity. And so if you're doing surgery to those people in order to give them a kind of more feminized genitalia, are you kind of going in keeping with what they would wish for themselves or not? So that's a really important part of that. And also this FSFI, which is about the sexual function, the data was only reported for 63 of the patients out of over 1,000, and that the mean score for their sexual function is 25, and that scoring goes up to a total of 36. So it's quite a low score, but really important is this: we don't have a lot of data about how kind of early genital surgery on these patients affects their long-term sexual function. And in recent years, intersex advocates and also professional bodies have recommended that we consider a delay of surgery that's not acutely medically necessary until that individual is mature enough to consent to the surgery themselves. We do have limited data from patients with CAH about what their wishes are. So this was a study which said that 60 to 80% of patients recommended early surgery, but also a lot of the patients that recommended early surgery are those that had early surgery themselves. So they were more likely perhaps to recommend early surgery if they went through it and they were happy with the results. So we wanted to look at our cohort of patients and sort of answer this question, because often on the referrals that we may get, either from parents or from doctors, they might be asking, when can she have the surgery? So we looked back at our patients who were referred to the service, who were referred with CAH and genital differences. They weren't necessarily referred for surgery. Some of them were referred because they had had surgery in the past, or people that wanted to explore their genital differences and what their options might be. So in adolescents who were those who were adolescent at the time of referral, so we included if they were under 25 years old, and there was 58 patients. The median age was 17, but they ranged between 10 and 25 years. Of these patients, 34 of them, so 58%, had already undergone genital surgery in infancy. And on the right, you can see the types of surgery that they had undergone. So the majority that had surgery, 42%, had a combination of vaginal and clitoral surgery. 10% had vaginoplasty alone, and 3.6% had clitoral reduction alone. In this group, included 5 patients who actually had late onset CAH, so they didn't necessarily have genital concerns maybe at the time of kind of early childhood, so they hadn't undergone previous surgery. 3 of our patients who did undergo genital surgery, so had repeat genital surgery in childhood, so that's a really significant population as well. 8 of our patients were unaware that they had previous surgery, and 8 of the patients were unaware of what surgery they had in the past. I think that really reflects on how in the past, especially, we weren't necessarily talking to the young people about what may have been done to them, or the different types of surgery, and helping them to understand what was done to their body. A lot of people kind of maybe leave that conversation until they're later, thinking that that would be better for them. That's what they would choose. Reassuringly, in this cohort, no patients were affected by menstrual obstruction, and none of them had recurrent UTIs. And in our cohort, 5%, so 3 of them, were also exploring their gender identity, and all of those patients who were exploring their own gender identity had previously had vaginal and clitoral surgery. So you can imagine that kind of further confuses them later on. Also, what we want to think about here is, is the way that we frame these discussions. And of these patients, when they come into the clinic and they're referred with CAH and genital differences, we have a chat, build up a rapport, talk to them alone, talk to their parents as well, and try to understand from that young person exactly what they want to know about their genital differences. Some want to know, a really detailed plan for surgery, but others don't necessarily even know why they've been referred. So after that conversation, we also offer them an examination to understand, the genital differences that they might have, what surgery they might have had done to them. And in our cohort of patients, 23 after this discussion, 23 of them, so 39%, did not wish to proceed with a review of their genital differences. And 8 of these patients had not undergone any surgery in the past, so that the rest of them had undergone surgery, but they didn't necessarily, they either weren't bothered, they weren't ready for that information. Some of our patients here were from the ages of 10, so they just might not be ready to think about sexual function in the future or how their genital differences might affect them. Of those who did want to explore their genital differences, 22 of them were then planned for examination under anaesthesia. So it's a really important part of planning our surgical management, is they usually have an examination under anaesthesia to understand what their surgical options are, for example, the length of their common channel and that type of thing. So so 22 of them were planned for an examination under anaesthesia. 7 patients who had clitoral issues or clitoral concerns also had a raised testosterone. And in those patients, they were planned for psychology and endocrinology input, because sometimes by understanding perhaps any issues they have with their steroid control, which might be driving their increased testosterone, by improving their steroid control, that can improve either their clitoral enlargement, can potentially reduce the size, but more importantly, the issue they might feel from their clitoris, if they have raised testosterone as well, can be an increase in sensitivity and discomfort. And sometimes by improving steroid control, that can improve those feelings, and they may not require surgery later on. So then they have that kind of input, some time to optimize their steroid control, and then further gynecology review. 6 patients had an examination in clinic, and then they were offered vaginal dilation therapy, so a non-surgical option for those patients who may have vaginal stenosis as a result of previous surgery. So in conclusion, when we're talking to our patients, we're always looking to understand, what if they have capacity to consent at that time, to examination, and perhaps to the interventions that we may be able to offer. So we are asking them to consider, if they're able to consider their genital differences, their condition, and their concerns, and then they can relay those concerns to us, that they understand that everyone's genitals, there is a big variation, and no one's needs to look, the way that they might see in a textbook, that they may be able to have some consideration about sexual function and sexual pleasure, that they can reflect on their own experiences of their clitoral function, so how it may be affecting them. And we also do require, if they're looking for a vaginoplasty procedure, that they are ready also to use vaginal dilators, which is an important part of preventing stenosis. So these diagrams just show what the before and after may look like for someone who has a vaginoplasty. So in conclusion, genital differences in patients who have CAH can be explored with the support of a specialised MDT service at a time that is led by the individual that is affected. And if we can improve our knowledge on adolescent decisions with genital differences, we can help to inform and support the parents of infants as well as children with CAH and genital differences. And as ever, further prospective studies are needed. Thank you.
Thanks, Stuart. It's really, really interesting. One question I have for you is, it looks like a lot of these people have already come to you having had the surgery at a time when they haven't probably got the understanding and able to say what they want. So have you presented this to, say, the paediatric surgical community, and how was that received?
Yeah, I mean, I know Hazel works very closely with the paediatric urologists, some of whom do the surgeries. I think there's a mixed feeling. I think it's really helpful to have kind of the involvement of PAG service as well, when perhaps those discussions might be going on. But I don't know if Hazel, you want to add anything to that? Sorry.
Yeah, great question. So at GOSH, and certainly most of the centres in the UK, surgery is not being performed on these infants because there's no functional indication, and the paediatric urology as a body generally have been receptive to this, and actually one of them reached out to me just the other day wanting to hear the outcomes of the adolescent population who are knocking on our door. asking for surgery, but as this demonstrates, 40% of young people aren't really fussed at a timeline that parents and their clinicians think they should be fussed.
Thank you. Do you have any other questions from the audience? No, I think we are super late, are we? So Stuart, I'll hand over to you. Thank you very much, Brooke.
Thank you.
Well, good afternoon again, everybody, and congratulations to all the long stayers in the audience. We are nearly there. There are just two elements that we need to cover. One is some thanks, and the other, much more importantly, are the prizes. So let's cut straight to the prizes and pretend we're at the Academy Awards. So everything's been judged, the newses are all in, and the envelopes are ready. And the prize for the medical student prize is Ria Patel. Well, Ria gave a fantastic presentation on a wonderful project. We then want to look at the oral presentations. And the first prize winner in session 1 is Kim Botting. Congratulations, Kim. And our runner-up in the same session is Laura Pentecost. Unfortunately, I have no awards to give away. Then going into the second session for the oral presentations, our winner is Ife, excuse my pronunciation, McDonald Bowyer. And our runner-up is Mez Hakim. Now, I hope all of you had the opportunity during lunch and after lunch to have a look at the posters. There were some fabulous posters out there. So congratulations to everybody who had a poster. And my understanding is this was the most difficult section to judge. And so our overall gold medal winner for the winning poster is Lois Harvey Prescott. Congratulations, Lois. And then we have some sort of categories. And the first one is our medical student. And our winning medical student is Emily Helsby. Next one is from our MSc students. And boy, did we have an amazing MSc turnout, both in terms of the posters, but also the attendance today. It's just how amazingly important the MSc group, I think, is for the Institute. So the winning MSc student was Fatima Kumar. And then further up the food chain to our PhD students and MD students, our winner is Hadi Wahid. And then finally, our winner clinician academic is Telma Martins Viveros. For our BSc students, our winner is Julia Back for the risk prediction models. Okay, so we really are about to finish off. We really want to hear from you. Okay, this meeting is all about you. And so please do feedback what you thought was good, what you thought wasn't great, and what you want to see next year. Because we want more bums on seats next year. This meeting continues to grow from year to year, and we're ambitious. We want to get even bigger and have a bigger impact. So please do feedback. I want to say thank you to people who have helped organize today. And in particular, the Women's Health Professional Services Group. So Sarah Mayhew, Ollie Barmer, Ian Waller, Marsha Jackson and their team, who I think have put together a fantastic day. The organising committee, which I'm a very small part, continues to amaze me with the number of speakers they know, the people that they invite. And I think they've done once again a really wonderful job. So thank you to all of the organising committee. The venue felt good as well. It was bigger than last year. I see lots of nodding heads. I thought the food was a bit better than last year as well. And the fact that we're all in one room, I think, is really big. I mean, it was a tantamount to how successful the meeting is that we had to spill over last year. But this is better. The feeling in one room, people contributing, people engaging, I think is much better. So thank you very much to the venue for looking after us. So you'll be relieved that we're now at the end of this speech. Please join us just across the corridor. There's no long walk like we had last year for a drinks reception, a chat, and some vital networking. And thank you to you all of you, for engaging, for getting stuck in, for asking. And I think we've all had a great meeting today. Thank you very much.